Well, hello, OLF, and welcome. Hey, come on, make some more noise than that. All right, very much. It is an absolute treat for us to finally be back in person. It's been so long. We've been doing, billions of Zoom calls, and let me get this off. We are, by the way, streaming as well. It's been fantastic to be here and actually see all our friends in person again. And thank you all especially for coming out this early in the morning. I wanted to say to appreciate all of them. They've been working hard over the past year to get this all set up. And we'll talk a little bit more about them at the keynotes, and give them some recognition. But just wanted to give them a shout out as well. Our first speaker today is going to be Dave Stokes. You may remember him if you've been at past events. He's spoken here with us many times. Unfortunately, has a policy of not allowing them to travel. So we're going to have to do this session by a pre-recorded video. So unfortunately, he's not able to join us, but he always does a great job. So I'm sure it's going to be a fantastic talk. He's going to be talking about some of the new things that are appearing in MySQL 8. He's a MySQL community manager. He's the author of MySQL and JSON programming guide, and I'm really excited to have him back this year. So please give a warm welcome to Dave Stokes. Thanks.
Hi there. This is a talk about the new features in MySQL 8. My name is Dave Stokes. I'm a MySQL community manager. I've been on the community team for 11 years. And I must say, I'm sorry I'm not in Ohio this year. Oracle does not allow me to travel. But hopefully next year we'll all be face-to-face again. And let me proceed. I started using MySQL when it first became available. I've used it in many projects. I've been an open source advocate and user for a long time, usually because I was working at places where we couldn't afford the big buck stuff. I joined MySQL AB many years ago as a PHP programmer on the certification team, eventually became a certification manager. Joined the community team 11 years ago. Like I said, I have most of the MySQL certifications out there, including the 8.0 Dev and DBA. I live in Texas and have the required Hound Dog and pickup truck. And by the way, the slides for this talk are at slideshow.net/Dave Stokes. And if you need to get a hold of me, I'm at Stoker on Twitter, or there's my email. So MySQL is 25 years old, which means we've been around a very, very long time in the software business, and we're still adding new features and still growing. And let me first say, if you're using MySQL 5.6, it was end of life almost a year ago. So please upgrade to MySQL 5.7 or better yet 8.0. Now MySQL 8.0 was made generally available in April 2018. For those of you who are waiting us to work out the initial glitches, they're long gone. And I want to let you know that we also release every 3 months or so. We also are on the CI/CD bandwagon like most of you. By the way, if you haven't looked at our software for a while, it is much more complex than it was back in the 5.5 era. Oracle has put a whole bunch of engineering rigor on our product, and by releasing every few months, we get better products to the customers quicker. We used to wait a long time before we got new versions out to you. By the way, same release number on all our products. That's the server, the clients, the connectors, the routers, utilities. And by the way, they're tested together and made sure that they integrate together. So no more wondering which version to run. Our latest is all 8.0.2.7. So if you're going to run a cluster, shell, workbench, router, or connectors or whatever, you want the same version, and the latest and greatest is 8.0.2.7. So the first thing is when I start talking about MySQL 8.0, mainly to folks who are running older versions, what has changed? Well, a whole lot. We basically pulled out all the guts and redid it. The first big change was a data dictionary. In the past, if you've gone under var lib MySQL, you've seen a whole bunch of .frms, MYIs, MYDs. That was your metadata. And besides taking up inodes and being the target of judicious junior DB system admins who weren't quite sure what they were doing, those files tended to attract attention that they didn't need and get deleted accidentally. So that is all now kept in the database inside an InnoDB table. InnoDB is our most popular storage engine. It knows how to do point-in-time recovery, so if something does go wrong with your server, so like the power gets cut, it knows how to recover to a certain point of time and keep everything together. And by the way, since this is using less inodes, there's a lot less mess. And the side effect of this is that there is good news. Since it's not showing up inodes, you can now have millions of tables in a schema. By the way, there's bad news to this in that you can now have millions of tables in a schema. I think most people give up around 23, 25 million tables. If you want to do it, you can do that. I know sometime that someone will be bitten in the butt by this, but so far, no. By the way, we re-optimized everything for UTF-8 MB4. Well, why is that? Well, we needed to have Unicode support because we have users all over the world. The old days of just being able to use Latin 1 with the sweetest collation are long gone. Yes, this is 4 bytes instead of like Latin 1 byte, but we've worked on it to make it more efficient. This also gives you support for the Chinese, Japanese, and Korean character sets, which are becoming more important every year. And also the big thing that everyone wants in their database are emojis. So you now have that with MySQL 8.0. Also, we added hash joins. If you're doing a equality query, it doesn't have to always be an equality, but where you're comparing two values, like this one's table 1.column1, table 2.column1, and we have a less than sign here. We'll now do a hash join. Before, everything else was a nested loop where we would read through one table and then loop off to the other table. Well, the hash joins, you throw them all in memory and your data comes back much faster. This is very impressive performance that you don't have to turn it, it's just there by default. And here's some performance examples. In blue, you see our hash join, and in orange, you see our nested loop. And you can see in a lot of cases down here, you can barely see the little blue line. So some of your queries are going to run a lot faster. Also, MySQL can be used as a NoSQL JSON document store. So JSON's become the interchange format of choice, and we decided to come up with a new protocol. And the protocol is based on Google protobufs, which cuts down on a lot of possibilities for SQL injection. By the way, this is not an ORM, it's its own protocol. It works with our JSON document store, it works with our relational tables. The API, you'll find, is very modern and follows best design practices, so you don't have to fight SQL syntax unless you want to. And you get the ability to use SQL or our new API. It's your choice. We're trying to give you the most flexibility possible. Also, we have a new shell. It's an advanced client and code editor. It has command completion, extensive support. It actually speaks 3 dialects. SQL, as you expect, because we are a relational database and you need structured query language. Also, you can use libraries and write scripts in Python or JavaScript and call them later. Very handy tool that. It's also our admin tool for InnoDB cluster and replica set replication. So if you need a high availability cluster or you're using traditional MySQL replication but don't want to have to do a lot of the setup, and I'll go into a little bit of that more later, it's there. It also has a 5.7 to 8.0 upgrade checker to make sure that you're not using new reserved words and that you're aware of some of the changes going to go on. It has a very fast bulk loader, so if you're importing comma separated, tab separated, or JSON data, it will do it in parallel with multiple threads. Also, we have utilities that I think will impress you for dumping schemas. You know, just one schema or one database, or the entire instance and the restoration. Very, very fast. So if you're using MySQL dump, you might want to look into these. Much faster, much easier, much more robust. Well, our new shell, hopefully you can see this well, is no longer monochromatic. You authenticate in and it tells you what mode you're in: JS for JavaScript, PY for Python, and SQL for SQL. Now, if you run a status report on this, I want to point out that it tells you that by default we are using TLS 1.3 because it's easier to keep the bad stuff out by default. If you don't need it, you can turn it off, but if you do need it, it's there. This also tells you that we're talking to port 33060 instead of our traditional 3306. That's because we're using the X protocol, which you can see the protocol version here. You notice that all the client and server communication character sets are in UTF-8 in this case, compression is disabled because we're not sending data back and forth. Something else we added with 8.0 was invisible indexes. In the past, if you had an index you weren't quite sure was useful, you might delete it. And suddenly everyone in the world is depending on that index. You didn't need it, but everyone else did. And then you have to go back and rebuild it, which can take seconds, minutes, hours, possibly longer. Well, what you can do now is alter the index using an alter table statement and make it invisible. That means the optimizer for the entire server can't see that index. And if that index isn't needed and no one complains for a while, don't delete it right away. Just make sure, because it might be something that runs once a quarter or half a year. Mark it as a candidate to be removed because indexes do take up space and there is maintenance and all that other stuff. But if you need to make that index invisible again, you just do another alter index and make it visible. Also, we've added invisible columns. Well, why is this, Dave? Well, imagine you have an old application where the queries are badly written and they do select star from customers, and you want to add a primary key to a table. Well, you just can't add an extra column to the database because when you do the select star, all that's going to be reported and your code would have to be modified to accept that new column. Well, if you mark a new column as invisible, it doesn't happen unless you directly query it. So if you want to add a new column called foo and you want to see everything in the table, you'd have to do select star comma foo to explicitly get that. Here's a quick example. Here we're going to create a table and we're going to call it not here. Have a column called ID, that's our primary key. Have a column called A, that's an integer, B, that's an integer, but it's invisible. So we insert some data into the table, and if we do a select star from not here, we get ID and A, no B. To get B, we have to explicitly say comma B. We also notice here I could have put in select ID comma A comma B. New asynchronous connections failover for those folks using replication. We've done a lot of work with this and doing stuff in parallel. Things work in parallel by default right now. One of the neat things over is that if you have a lot of sources going to replicas and suddenly a new source needs to be used because the old source is failing or going offline, you can have a list of possible donor sources and that will take care of it. Now, this helps keep everything synchronized with multiple servers or groups of servers that share data. Now, the list of potential sources is saved on the replica, not on the primary. So in case something goes wrong, the replica knows where to go ask to get its replication data from. And you could also weight this for your priority. And this supports our group replication. Something else I found very handy is in the past as a DBA, someone will come up and say, hey, I'm Bill from accounting and I can't get into this table. And you go out there and look in your MySQL.user table and there's 5 Bills, 2 Billies and a William. So it's kind of hard to know which one is which. And you'd also end up with a lot of security exposure and it gets messy and you tend to upset folks. So what we can do now is we can, when we create a user, we can put in a comment there, say, hey, this is Bill Johnson. He's in room 114, extension 1234. Or you run an alter user. In this case, we're saying this user has her email there. And if you look into the MySQL user table, you'll actually see how this is annotated in there in a JSON document. Also, something we've added is the ability to turn off redo logging for loading data. Pretend that you have a new replica coming up in your replication data, and it is feeding another server or two, and it has all the nice stuff enabled. But when you're trying to put in data, you also don't need to write a copy of that data out there. So what you can do is turn off the redo log, which means as the data is loaded, it's not preparing to go back and restore it because you're restoring it for the first time. The shell backup utilities I mentioned earlier are very nice. They work in parallel, multiple threads, do file compression. In this example here, util.dump instance, the file where I'm going to put it, I put it in here and do a show progress. You can't really see the progress bar on this, unfortunately. I should do a video of that. And it tells you how many schemas are dumped, tables, the compressed size, the uncompressed size, the number of rows written, and the throughput. There's also a way just to do a particular schema, and the corresponding restore utility also works in parallel. Something we do that's rather neat is as we're doing transactions for replication, that stuff is written to a file that's compressed. And when we send it to the replicas, it stays compressed, and the replicas can read it in an uncompressed state. There's no writing it, compressing it, sending it over, uncompressing, and then reading it. It's much faster, much easier, takes up less time and network space. Also, we can generate random passwords for you. For a long time in MySQL, you've been able to determine the complexity of your passwords, length, number of uppercase, number of lowercase, number of special characters, how often it has to be changed, number of times you have to wait before reusing a password, that sort of thing. But there is really no easy way for folks to get a random password. Well, now the server will generate for you and store it in hash. So what is stored is the hash version of this. And if you want to see more, here's a little blog I wrote on that. Also, we added explain analyze. For those who debugging queries, trying to get better performance out of them, explain works by running your query or looking at your query and determining the optimum way to run it. Now, in the past, explain has always used the historical information, kind of like a GPS. And like a GPS, if you have old information, things can go bad. Like when I go to lunch, left out of the driveway, right at the stop sign, over the railroad tracks, and there's the restaurant on the right. Well, may not know this morning when I go to get out of the driveway is that my neighbor has washed out the road, there's a train parked over the railroad tracks, and the restaurant's moved to the other side of the street. So historical information is great, but it's not perfect. With explain analyze, we can actually go out and run the query and get the actual time. By the way, if you're running explain and explain analyze and see a skew between the numbers, it's time to run analyze table on your tables. Multi-value indexes. We don't have a array data type, so a lot of people started using our JSON data type for arrays. The only trouble with that is our indexing software was stuck where you had one row equals one entry in the index. Doesn't work for arrays. So with multi-value indexes, we can actually index every item in that array, so you have multiple index entries per row. JSON document validation. This is from the wonderful folks at jsonschema.org. They're working on getting this as an RFC. The idea is JSON's free format. You can't really, everything's free flow. If I want to store the data for an email as email and you want to do it camel case and someone else wants to spell electronic mail, or someone just calls it mail, that's okay. But when you're trying to search for someone's email address and you have those various keys out there, it gets really messy. So what the JSON schema folks did and what our engineers instituted was a way to check the schema of the data coming in versus what you want. Now, in this example, we're going to use the JSON schema valid function, where we're going to say we're expecting an object, and the properties of the object is that the key is called myAge. The data will be a number. If it's not a number, reject it. The minimum value is 28. The maximum value is 99. So if it's under 28 or over 99, it'll be rejected. And by the way, it's required. You actually want to know their age. For some reason, you really need that in there, and you want to make sure that it's there. Now, it's easier to keep the bad data out than go back and fix it. So when we create this table here, we're going to have a column of type JSON, and we're going to set up this constraint check that you've seen here using the JSON schema valid function. And if we go to input data that doesn't fit, here, the first example here, myAge 27, constraint check, myAge in range is violated. It's not going to let you put in the bad data. For those of you who should know that you always check everything that the users give you before you put it in the database. This is another way to reassure that you're there. Meanwhile, if we go to insert a record where everything's valid, it goes swimmingly. By the way, nice little blog on that if you want to go into that. By the way, you don't have to run MySQL upgrade. It now runs automatically. We have enough versioning information stored in the data dictionary to be able to tell. In the past, you'd see stuff on the internet where someone said, hey, I just upgraded MySQL and I'm getting complaints about this column's missing or this is acting weirdly. We were changing metadata, but we needed MySQL upgrade to go out and update some of the versions of that. Well, it runs automatically, so you don't have to worry about that anymore. One of the other things you just saw is a constraint check. What they do is they let you check your data that it has certain values that you want before you put it in. In this example, we're creating a table called T1. We're going to check to see that C1 is not equal to C2. And C2 down here is a column. C1 here is another column. Also, we're going to check to make sure that C1 is greater than 10. We're also going to have a constraint. And notice here that we're naming the constraint C2 positive. Well, why do you recommend that, Dave? Well, if something fails, it's going to come back here on this one and say constraint check 2 or constraint check 1 failed. Doesn't really tell you anything. If something fails here, it says constraint C2 positive failed. And you look at your data and said, ah, I had a minus in front of that. Also, we now have histograms. These are a way to look at your data to tell the optimizer how it's laid out. The optimizer assumes that your data has an even distribution all the way along through the column. So when it's making a prediction on how it wants to run your query, trying to optimize it, it assumes that everything's even. And if it's not, the prediction is wrong. And it's like going to a contractor and saying, hey, could you do this for me? And say, yeah, I can do that for $5. It ends up being $50. You can get upset. Same thing with the optimizer. It makes a bad guess and the query plan goes bad. Now, the great thing about histograms is that if your data isn't churning, you only have to do it once or rerun it as your data changes. The bad news is that they're not as up to date as, say, index, but the good news is indexes have a lot of maintenance and overhead. So this gets rid of that overhead issue and the cost there. So if you have data that doesn't churn, but you still want to be able to search through it quickly, consider using a histogram. Also, we added cats. No, I'm not talking the musical/movie. Some folks at, I believe, the University of Michigan came up with the idea of contention-aware transaction scheduling. What happens is you have a hot row, hot column in your data, and every query is coming in, is hammering and saying, I want that data, and I want to lock it. Well, the basic idea here, and I'm boiling down an academic paper, which is a bad thing to do. The idea is this is a way of how to get rid of the contention or reduce the contention. When the load hits a certain percentage, it switches on and it handles the hot queries faster with higher priority than anyone else. Now, previously we had a first in, first out. So someone coming and locking something that's kind of a low priority and they're just kind of gazing through stuff. Everyone else has to block behind them. Where if you're trying to do transactions on that data, you want to get that in and out as fast as possible. By the way, we've done a lot for JSON support. One of the neat things we added was the JSON table function. What this does is it takes your unstructured JSON data and temporarily turns it into a structured table for processing with SQL commands. In this example, we're going to take a JSON column called doc. We're going to read the entire document, and we're going to take anything that is called name in the document. This is the here pointer for the document. We're going to cast it as a car20 and call it country name. And we're going to find anything that is called independence year, cast that to an integer, and then we can pass that on to the outer query and parse that with any SQL commands that you want. Very handy, very great. If you need to permanently have the JSON data turned into something you could parse with SQL commands, we have generated columns where you can extract part of the JSON document and put it into its own column. We added common table expressions. For those of you who've ever had trouble writing subqueries, this is manna from heaven. Great things about these, you can reference them multiple times from your query. They're very easy to read, very easy to write, very easy to understand. Some subqueries you look at and just go, oh my goodness, what are they trying to do? Now in this example, the keyword is with, and our first common table expression is we select AB from table 1. Our second one is select CD from table 2. And then in our main query, we're selecting B and D from CTE1, and we're joining CTE2, so CTEs can be joined. Very handy, much nicer than running subqueries. We also added windowing functions. So if you're doing analytics on your data, this lets you partition your data by a column. This is great for reporting any sort of analytics. And in this example here, we're going to go out to the payments table. We're going to set up a window that we're going to call W, and we're going to get all the information. We're going to order it by date, and we want the week before this week and the current row. So if your boss wants to know how the current sales promotion is going, you can run a query like this and get the information. This gives you much more granular analysis than using a group by or some of our aggregate functions. Also, I'd like to introduce you to InnoDB cluster. This is the way we'd like to have you start thinking about your applications. Your application is up here with a copy of MySQL Router, which is a lightweight proxy. Router has all the smarts about what's down here. Your application should not know anything down here to keep it as simple as possible. What happens is you have a request that comes into MySQL Router, and in this case we're running a read-write split. If you want to write a row of data, it's going to go to the primary. If you want to just read, the router will know which one of these machines to hand off the read request. If something happens down here, your application doesn't need to know anything about it. You might have to retry a write. So if something goes wrong during the middle of your write, check it, make sure it's gone through. If not, reissue the write. And this is all administered by our shell. Also, for those who don't need high availability and still want MySQL replication, we have something called replica set. The prior incantations of MySQL replication, you had to do a lot of tedious work. Oh, I have to point to this level of the log file to be able to read it over here. This takes care of a lot of that. It uses the clone function that I'll show you in a little bit. It has almost all the features of high availability, except that it won't do the manual switch over or fail over for you. So if you're in a little more traditional environment of MySQL replication, take a look at this. Okay, clone plugin. This is really neat. You have a new box brought into production. It is set up to work on your InnoDB cluster, and the first thing it does when it gets on the cluster is said, feed me Seymour, I want information. So what happens is the new machine says, okay, I want to clone an instance, and on the remote machine, it will do a copy of everything from that machine at the InnoDB table space level. It pulls it all over extremely quickly. You can do it with SSL on. It uses password protection, all that. Very, very fast, very, very neat, very, very impressive. Also, you can use MySQL without SQL. This is our JSON document store. In this example, I'm going to create a schema named FOSDEM, And if after I create it, I type db, it sees that my pointer is at FOSDEM. db.create collection, I'm going to create a collection called A. And if I want to add a document, it's db.add and put it in a JSON document. Boom, it's there. If you're working in an environment where you don't know what your data is going to look like, but you need to start saving data and you don't have the time to go out and set up relational tables, you don't have to set up indexes or foreign keys or all that sort of stuff, this is a great way to do that. If you're used to using JSON document storage, you're going to find this very familiar. It's also a JSON document store and very quick. Also, this is something that's not part of the free community edition. Everything before this was available in the free community edition under the GPL version 2. You can go out and get binaries for just about any platform. The source code is out there as well on dev.mysql.com, and we're also on GitHub. This is our paid-for cloud infrastructure, and you might have heard some about this. This is the MySQL database service. This is the new hot product in Oracle, and basically it's Oracle engineers running your Oracle instances for you on Oracle hardware and on Oracle software. And you have 3 options at this time. First is standalone, and you get a single instance of MySQL, just like you'd have on your laptop or your server. And if you want a little bit more, you set up high availability. It sets up 3 servers for you in an InnoDB cluster. So if one of the machines has some sort of problems, it will be taken offline. If you need a new primary is needed, it will elect that, and then it will bring the secondary machine back and refeed that with data. Also, if you're doing analytics, we have HeatWave. HeatWave is designed for high-speed analytics. It is absolutely amazing. And also there's a thing called AutoTune, which is machine learning on top of that to watch your queries and the configuration and tune that for you on the fly. If you're working for a startup, please go to oracle.com/startup. We have a whole bunch of credits and marketing stuff we can work with you on. Very impressive program. Also, if you want to try that MDS, you can get $300 in credits for free for 30 days at oracle.com/cloud/free. The lower end instances, the standalone instances, the $300 will last you quite a long time. For HeatWave, it chews up a little bit faster. Please follow us on social media and connect with us. MySQL.com on Twitter, on Facebook, and on LinkedIn. By the way, if you're using the JSON data type, please buy a copy of my book. The manual is good, but this is a guide to teach you the ins and outs with lots of coding examples. Talks about the MySQL document store, talks about a lot of the really neat stuff out there that helps you use the JSON data type to its fullest. And with that, we're going to go to Q&A. Hopefully I've been able to join remotely, and I would love to hear any questions you have. And if I can't answer them, I want to thank you for listening to me today, and I hope you have a great rest of the show. And goodbye, Ohio Linux.
So welcome again, everybody. Sorry for the, we had a little technical trouble, but we're working out the kinks. Folks who are on YouTube, I know we've had a few issues with the stream as well. We're trying to get those ironed out. Apologize. This is the first time we're doing a high. It's been very much a learning experience. I want to introduce our Kyle Jenkins. It was last night. Has been a developer and has very much gotten interested in team dynamics and making organizations better. He is on the 6 types of working genius, and I think you're going to find it to be a very effective. So please, Kyle.
Thank you very much. Person? That's much joy right now. And I'm hoping that what we can do is take this joy and bring it into our everyday lives, not just getting to see people at conferences here and there. So what I'm presenting is the 6 types of working genius. I have to start off this with a little bit of legal. This model is was created and is owned by Patrick Lencioni and his consulting company, The Table Group. I am not associated with them outside of the fact that I have my certification in being able to facilitate this with teams. I do, however, work for an IT consulting company that focuses very much on, with our goal being, we want to change the IT professional, to change that perspective. It has been one of a lack of trust for many years, and our focus is let's start building that trust. And that's really engaged me with them a lot because trust and soft skills are such an important concept to me. So just a little bit about myself. I've been working in IT for 14 years now. I've been working with improving and been living in Columbus for 7 years. I started off as a full stack jack of thing from client-side on a website to keeping the servers maintained at 5 a.m. when something goes wrong position, to primarily now focusing on front-end frameworks, architectures, things of that nature. However, since coming, I've always gained this interest in soft skills. This really sparked up because what I discovered after we started a trust initiative within improving, and what I discovered was how many behaviors that I was raised in within the IT profession, the behaviors themselves were actually untrustworthy. Not that I do this intentionally, but a lot of the way we communicate, the way we commit to projects are actually in a manner. So this really sparked this concept of soft skills, trust, and has really led recently into teamwork. We've been taught we need to learn how to work together, yet even then we still work in a lot. I've worked on teams where, hey, we have 8 people on the team. Every single person is still working on their own project. There's no teamwork. Also on the side, you can see me here, so you see what I like to show off my Final Fantasy character, because she's cute, so why not? Which you wouldn't other get to see otherwise. So into the model itself. Widget. Simple. You can use to generically describe pretty much anything within IT if you really tried for it. This is our present this model for us. 6 pieces of a project. 6 geniuses. The idea is that when you're working through these, projects go smoother. So we'll start from the top. The genius of wonder. These are the individuals that are always looking around at the environment around them. Whether that's in the world, whether that's in the code, whether that's in the team, looking at your processes, what is it that we can do better? What problems are there that need to be fixed? They're not at this point. They're just looking around. I love to identify these people because they're the ones that are always sending out all posts to their entire team because no one else actually goes and looks for it themselves. I'm one of them. like, oh, what this person is doing. Is this something we can use? Is this some way we can better our lives, better the way we work, better the way we write those tests, get more test coverage? We have our problem. Someone's defined it. This is usually known as the classic genius. Prior to genius, you're looking for the inventors. Trying to change that. The genius of invention. These are say, oh, you found us the problem. Should improve. Let me solve. I want to come up with that solution, and preferably from a blank slate. I don't want to create this myself. These clean APIs, these better. What really starts driving those new businesses coming about is we have this new idea. We can make this big. From there, we have the genius of discernment. Quite complicated, most complex one, in my opinion. This is used with expertise. The idea here is now potentially more than one. I'm working with a team. I may have multiple inventions coming about. Which one is actually going to provide the most value? Which one that's really going to help us move along? Which ones are solving the problems? Or any of them? Have we actually identified a solution here that is going to work? Now, expertise, it may be you need to understand things a little bit, but this comes down more. This is one of we can't really prove that this exists, but we know it does. This is the person about real estate, but you're going to take them with you to check out a house, and whether because you've learned these people, as these are the ones where you want to take those inventions and talk to. If there is one thing out of this presentation, I want you to take this. Do not discern your own inventions. You actually can't do it. You can be a genius in both invention and discernment, and you still cannot. Someone, please. It really helps failures moving forward throughout your projects. The other trust. You need to be able to trust your team. And of course, you start that by extending trust. A book I do recommend is The Speed of Trust by Stephen Covey, who breaks this down into a lot of complicated pieces. Lots that we can do on a regular basis to build those trusts and build those trustful relationships. Once we've discerned it, we move into one, which is the genius of galvanizing. These are groups. We have a solution. We've determined this is how we're going to advance the business. This is how we're going to get this project through smoothly. These are the architecture updates, whatever that may be. The galvanizer is the one to rally the troops. Get it. From a team perspective, that may just be getting your team on board with it in order to issues later on. It may be communicating to other teams. It may be communicating to your stakeholders, the rest of the business, whatever it may be. These people are really good at getting people to rally behind it and get on board with the invention. Then we have the genius of enablement. These are the individuals that then says, oh, this is what you want to implement. Okay, what do you need? What resources? What tools? What can I do to help? I'm not going to implement it. I'm going to provide you anything you need in order to be able to start, in order to start getting things done. This could be seen in many perspectives, whether it's project management, BA work, defining those stories, collecting the tools. It needs to be there. Then we have the tenacious. These are the individuals who, well, get it done. These individuals love crossing that, checking that box off the checklist to the point where they might get checklist, they'll go add it on the checklist just to check it off. These are the go in there and just knock it out of the park. Note that it takes a lot. Make sure they're doing the right thing. But you had to pick one. Which one resonates with you the most right off the bat? This is the item that's going to bring you joy. Like when you think about your task list at work, and not even just think about work, think about at home. You're doing projects at home. What gives you that joy? What really drives you? So, curious. Anyone here on the wondering side? Really like thinking about it? Got a couple over here? OK. What about the invention side? Really like creating new things? Discernment? Listening to ideas, helping identify where things, what's right, what's wrong? OK, I have a few there. How about galvanizing, rallying people around? I think I saw one. How about enablement? Someone calls for help. You're like, cool, what can I do? Here? If you're over here, OK. Tenacious. Really like seeing that checkmark checks. OK. We've got a good crew here. We've got a little bit of everything. So as part of this, now that we've gone over these 6, there's a couple topics I want to talk about. Guilt and judgment. It's very easy for us to feel guilty when we're not as good as other people on our team at very specific tasks. And this happens a lot. As I noted before, invention being that classic genius that we're used to, when you're not an inventor, it's like, how come these people can do this? I will note, this goes alongside. We've seen examples where people will have the same Myers-Briggs profiles, the same disk profiles, but have completely different geniuses, and literally wonder, what's wrong with them? Why can't I do this? And it creates that feeling of guilt. But now that we've been able to identify 6 different elements within the project flow, all of which are important, all of which we can consider geniuses in their own right, all of which you can get good at, all of which you can get better at, that really focuses for you and what you are good at, we can now turn that guilt into pride and say, yes, Kevin over here is really good at knocking that piece out of the park, really getting that stuff done. But now I know, you know what? I'm good at rallying people around it and getting people on board so that we have less issues moving forward. And we can take a lot more pride in who we are as individuals. Pride is a huge deal in today's world. We're always talking about being pride for who we are as individuals and how we think, but not necessarily how we work. Now we can have that. The other portion of this is judgment. I've seen people who get things done really well. You hand them the task, they're going to knock it out very quickly, decent quality. And at the same time, I hear managers complaining about it like, how come they aren't trying to do better on their tests and write more tests? How come they're not trying to get this into a CI/CD pipeline? How come they're not looking around at how they can improve and actually get better at what they're doing? But now we know, like, OK, cool. Instead of casting judgment on them for these pieces, realize that, OK, that might be their frustrations. They don't enjoy that, so of course you're not going to, and that's OK. And we have other people that can focus on that as well. The other side to that is because by the same right, you might be getting frustrated with somebody else on something. They're probably frustrated with you for having different geniuses. And always looking around, why are you distracting me with this new stuff? I'm trying to get stuff done. And then we start making excuses for ourselves. It's like, well, it's OK that I'm this way. It's something referred to as the human attribution error, where we'll be frustrating somebody else, but we'll give ourselves the benefit of the doubt. Now that we understand this, right, it's a lot easier to start saying, OK, let's take these people. I used to judge these people for not necessarily looking around, for not trying to improve things as they're going, and they're just so focused on getting things done. Now I can appreciate this. Rather than trying to expect them to do this, like, OK, we have other individuals who are good at this, and we'll appreciate them for coming up with new ideas. We'll appreciate them for rallying people. We'll appreciate them for looking around regularly and doing that. And I'm not just going to expect that from everyone. A prior mindset, and I've seen this before, especially in a smaller company world, where there's this expectation for everyone to do everything just as well as everybody else. Well, this causes problems in the long run. It sounds like a utopia dream. I love to have 20 jack-of-all-trades that can do absolutely anything at any point in time. Everyone's perfect at debugging prod issues. It's unrealistic. But now we know that. We can understand a bit more why. So with that, as we look at all 6 of these, as we call it the working genius, the idea is fairly straightforward. Everyone has 2 geniuses. The idea here is imagine the amount of energy you have being represented by a coffee cup, because we love coffee, why not? Or Monster or Red Bull or whatever you're trying to use to try and keep awake during the day. Or for the healthy people, water, because that is supposedly the best source of energy we have, as it turns out. When you're working within your geniuses, when you're able to focus on tasks that are within those 2, this cup stays full. It can actually rebuild what's in there because you're getting that joy. Just as much as people, there's a good chunk of people who go home every day burned out. They work 8 hours a day, 40 hours a week, because that's what they have to do. And they're just looking forward to retirement. They're sick of it. On the same right, there's also people who work 10 hours a day, 6 days a week, and can't imagine retiring at all. Right? That's what the geniuses provide, is that level of energy. You're going home and you still have energy to get things done. Along that, everyone has 2 competencies. So these are the next 2 down. Within that same coffee cup, the idea here is you're slowly draining through. Right? You're not going through it fast, and you're probably fairly good at these items. But doing them so much, you just keep draining a little bit. Geniuses can bring it back up. And on that same front, everyone has 2 frustrations. I could just drill a hole in the bottom of this coffee cup right now. If you're focused on your frustrations too much, or really at all, your energy just collapses. You have no energy at the end of the day. You may make it halfway through the day, and you're just like, I'm done. I'm taking PTO. I can't keep doing this. With that said, while this is true, all jobs use all 6. We do know this. This is not an excuse to say, oh, cool, I never have to galvanize people. I never have to discern anything. Or you know what, I'm not tenacious. I never have to get something done. Bad news, you have to get something done. But if we can redirect which roles we're playing, balance them around the teams, knowing that some people actually do like just taking on that work and getting it done. Some people do like taking in new ideas, like talking with other people and taking in those ideas and figuring out which one's going to work for us. Some people do like rallying people around and can redefine those. We can refocus more individuals towards their geniuses. Therefore, we start reducing burnout. People get more joy in what they do, and they feel more fulfilled. Even if they're not tenacious, they feel like they got something done that day. And they're enjoying what they do. The truth about burnout. As we discussed that idea of draining energy from your frustrations, previously this was always thought to be caused by, you just have too much work. Clearly, we need to start taking things off your shoulders. We need to hire more people, which requires, by the way, for you to coach them, which is probably on the, enablement side, which if you're not an enabler, hiring more people might just be stressing you out that much more. if that's not taken care of properly either. So we need to reduce your workload. Here, you can stop doing these items, not knowing that some of those items you're getting rid of may very well be part of your geniuses, and that's actually what's keeping you there in the first place. I've had this happen to me a few times. Oh, you're taking on too much. We'll take this off your shoulders. No, but I like doing that. Don't take it away, please. And that, well, OK, well, yeah, everyone gets burned out. That's the normal thing. Take some PTO. Take some time off. Not realizing that quite often when we take PTO, I love picking on tenacious here because I'm not tenacious and I know how this feels, is, oh, well, I'm going to take PTO so I can go get stuff done. Well, you really think I'm just going to come back more burned out because I'm just going to go focus on my frustrations while I'm on PTO. And in this case, PTO is now just a, OK, keep me from burning out perspective. PTO should be moving more towards, oh, you know what? I'm perfectly fine at work and whatnot, but you know what? I want to spend some time with family and relax. I'm not there to reboost my energy. I'm there because I just want to do other things and actually enjoy life. So the new way we're thinking is, hey, we can understand people's geniuses. We can understand what they love. Let's focus on moving people towards that so that we can eliminate the burnout. Fact is, there's always going to be too much work. You're always going to have a backlog of work, which is good. It's why we have jobs. We have a backlog of work. But if that backlog of work is in our geniuses, we're able to get through more of it without draining our energy throughout the day. You can still leave the day after 8 hours or 8.5 because someone decided to do a 5 o'clock meeting for some reason or other, and still have energy to do things in the evenings. Go to your meetups. Go to conferences. Woo! See people. Versus, nope, I'm going home and passing out. Make sure you're keeping the tasks you do have that you do love. And now we can start identifying, OK, what type of tasks do we have that really aren't dependent on my role? One thing I love about this is that there's this assumption that the CEO of a business is also the chief galvanizing officer. They're the ones that have to rally everyone around. That's not true. Easy able to pass it off. I see tech leads always thinking they're the ones that have to coach everyone that comes into the team. They're forced to be enablers. The fact is they're not. That could be assigned to anyone else on the team. The invention side, not dependent on tech leads. This is the idea of teamwork. This is the idea of using your team and bringing people in. We don't need to cause judgment because some people aren't inventors or any of the other geniuses. We can utilize the team and the people who are there who really enjoy it more. The other thing to be aware of is your competencies. So while I said, oh, it only drains a little, et cetera, this is actually where a very significant amount of burnout happens. For example, galvanizing. Having to give presentations and rally people around your architecture, things of that nature. Let's say you have no genius of galvanizer on your team. Well, who does it go to? Well, it goes to the person who's kind of next best. You're not that great at it, you don't really love it, but you're good at it, so we're going to give it to you. And all of that work goes to that person. They're forced to work in those competencies all the time because no one else wants to do it. And now they're the ones slowly burning out. This is happening in a mass amount of cases. Frustrations, on the other hand, we tend to actively avoid them in the first place. We just try and put off those tasks as long as humanly possible. And we do this subconsciously, not really knowing that's why we're doing it. Now we know. So competencies are actually what we have to be careful of. So kind of a midpoint, just takeaways right up front. We have 6 geniuses. Everyone has 2. Always have someone discern your inventions, please. Like I said, one takeaway. Always be willing to discuss with someone. Find that person you trust. Because we will all invent something, even if we're not inventing for geniuses. We'll always try and invent something. Tend to do it. Extend trust to those discerners. We can take this guilt and judgment that we've had before and really turn it into pride and appreciation. I can't express this, anymore as much as I want to, because I do see this all the time. where I see managers always like, well, I can invent this, but I don't want to invent this for the people. Well, the fact is, if you're the inventor and everyone else is not, well, might be a good thing. Take pride in the fact that you can do it and appreciate them for being able to implement it. If we learn to listen to each other, if we're able to listen to each other as we're going through this flow, it goes significantly smoother. Everyone has 2 geniuses, 2 frustrations, and 2 competencies, but every job will involve all 6 letters. It's not an excuse. The goal is to refocus as much as possible. And burnout does often come from competencies, not just frustrations. Any questions so far before I move in? Okay. So this model, while I've talked a lot about personality so far, we only see it about 20% of a personality assessment. DISC, Strength Finders, Myers-Briggs, we do appreciate these. And there's a huge focus on personalities, how to manage people. But what we love about this assessment is that we see it as an 80% productivity assessment. This is about getting projects through. Prior thinking, there were really only 2 steps to a project. You had ideation and implementation. Hey, we have an idea, go implement it. Okay, engineers, go implement it. That was it. There's a reason why the classic genius was always on that idea side of, oh, we have this invention. I also want quick statistics I pulled up the other day when I was just kind of taking a look at this as I was going through this presentation again. 90% of startups fail. So I thought was kind of that is a very large amount. That's been a true statistic for a very long time. I've heard it over and over again. Another number, though, is 47% of those failed because they didn't analyze their market properly. And I sat there thinking, where is that in here? It's like, that's really a lot on the discernment. Right? You have this great invention, but is it actually solving the problem? Have we covered all of our bases? And then there's the galvanizing side of that. I'm starting up a new business. Who do I need to galvanize? Well, when we're thinking about a small team, it's like, cool, I got to galvanize my devs. But when you're thinking about a business, well, you have to galvanize all of your stakeholders. That's your employees. This goes a little bit onto the conscious capitalism side, for anyone that's heard with that, about knowing who your stakeholders are, which is going to be all of your employees, might be your shareholders at a larger side, your community, how are your decisions are affecting your local community and how that perspective looks. In case you haven't noticed, in today's world, the community can completely destroy business, no matter how large it is. We've seen this happen a few times recently. All of that matters. Who are your stakeholders? Every decision that's made, everything that has gone through this process, every little new architecture or change you want to make, who is it that has to be galvanized and has to rally around that in order to make this smooth? So now we've got 3 major steps. The ideation side, as we know it. We've come up with this problem. We've come up with a solution. And now we have this activation in the middle. Because this was missing, we didn't identify people as geniuses in this area and realize, oh, there's people really good at this. So activation is made up of discernment and galvanizing. That really, a really centered portion in order to not end up with failure. This stage, and it was specifically called out, because this was missing, we replaced it with the concept of fast failure within the agile world. If we had this idea of, we'll keep things small and we'll just keep creating or coming up with ideas and implementing as fast as we can. Now that we know these were there, now that we know people are really good at these stages, we can actually fail significantly less up front, just taking a little bit more time with less cost. And then implementation, that enablement and the tenacious. Thankfully, there are a lot of ETs in this world. because as you can guess, they're very needed for when things need to get done. And they're greatly appreciated. A lot of people don't like assigning tasks to other people because they're like, well, why should I assign tasks to other people when I don't want to do it? Therefore, I'll just take care of it myself and work in my own frustration. Not knowing that some people love to just be handed something that says, oh, could you do this for me? And they want to help. And they want to implement it. And when you can identify those people, always say thank you to them. There's another concept here. Responsive and disruptive. And I think about this a lot because of how often people like to disrupt meetings. We tend to drive a lot of discussions, meetings, anything we're in towards our geniuses. So the wonder is responding to the environment. They're responding to what's out there, really trying to identify how can we improve. The inventor then says, OK, cool, let's change the environment. I'm going to go disrupt everything around us. I want to disrupt and create this new thing and solve the problem. The discerner then responds to the inventor and says, OK, cool. We've got these inventions. Let's work our way through them. Let's see what directions we can go. Then the galvanizer then, disrupts from the discerner and says, oh, this is what you want to do? OK, cool. Guys, stop working on what you're working on right now. We should be doing this instead. This is our new high priority. They're the ones rallying people around it. The inevitable says, oh, OK, new high priority. Cool. What do you need? We'll take it from there. Just tell me what you need so we can get this done. And then the tenacious are actually changing the world. They are changing the environment. They are making those changes. They are in there disrupting. This brings us to a concept that we call altitude and turbulence. This is the portion that saved my butt several months ago while I was working on a project, where we ended up with a lot of turbulence because we were going in circles. Little did I know, I thought this was just a normal thing to do. The reason we call this altitude, the metaphor we like to use this is you're in a plane with your friends, your team, hanging out, the wonderful rich life, because why not? Your head's in the clouds, you're up there, and now it's like, you know what? Maybe we should get some dinner. We should probably land somewhere and actually go somewhere to eat. So it was, oh, cool. We're over Texas. Let's go over to Houston. The discerners are like, well, hang on. They're having storms again. Probably a bad idea. So you go back up to the invention side and says, cool, let's go to Dallas. Great steakhouses there. Why not? You start working your way down. You're starting to land the plane. You're moving through. Everyone's excited. You're about to land the plane. And then your manager comes in and says, you know what, though? There's this steakhouse over in College Station. Everyone's encouraging this. I really want to try this. Your plane's about to land and just fired right back into the sky. Starting all over again. Turbulence. This happens with projects all the time. You're working your way through as you're going down, and that new invention comes up. Or you're working on that galvanizing, you're working on enabling people, cool, we're getting this through, manager steps in, you're fired right back up. What about this idea? What about this idea? Right? What happened? Why are we running in circles? I ran in circles for about 3 months recently. Wasn't pretty. Didn't know at the time. But, oh, this is just normal. Now we know. So the idea being is like, cool, how can we reduce this turbulence? Many times, and what I've found personally for at least the IT projects I've worked in, a lot of this comes down to the lack of galvanizing. We never really got everyone around the idea before we started. We're in there ready to implement, and someone is like, is this even what we should be doing in the first place? Somehow making it all the way back up to wonder. And restart. So driving off that concept, so now we've got turbulence. Now you can start seeing, OK, how is my project moving? Are they really moving as smoothly as they should be? Let's talk about meetings a bit. Everyone loves meetings, right? Oh, I just heard a lot of sarcasm. So quite a few years ago, I think I was just looking up early 2000s, Patrick Lencioni wrote a book called Death by Meeting. Read it recently, I thought it was pretty good. Turns out it ended up working really well when we started thinking about geniuses. And what he discovered, it wasn't about having less meetings. It's about having more productive meetings. Now note, they work a lot with leadership, and with leadership, meetings have to be productive. That is the majority of their jobs, right? And what he discovered is that there's 4 types of productive meetings. If you're not doing one of these, you're kind of questioning, okay, are these? Each of these meetings also reflect off our geniuses and the geniuses that should be getting utilized within these meetings. When we're not, it disrupts the meetings. So it's important to put on the right hat as you're going in these. Notice, everyone has to have all 6 hats. So within the book, he goes over the brainstormer offsite of like, here's our opportunity to look around. Here's our opportunity to say, what is the direction that we want to look at next? What problems are that we want to solve? Within an agile team, this is your retrospective. Here's your opportunity to sit back and think and says, how are we going to improve this process? Now, as you may guess, if you're dealing with tenacious people, they're kind of like, what is the retrospective for? I just want to get stuff done. Stop inviting me to these meetings. But if you're a wanderer, if you're an inventor, here's your opportunity to really shine. Really enjoy yourself within a meeting. The ad hoc strategics, I feel like we've never really had a good term for this, but the idea behind this is you have a problem. Something came up. You need to solve it. We like to call these the ID tangos, because this is the cool. We have a problem. We need an invention. We need it now. So you set up a meeting. You get there. And for better or worse, for some reason, we like 30-minute meetings. We like to make things as short as possible. Like, yeah, we can solve this in 30 minutes. The recommendation from the book was this was a minimum of a few hours, because you do not want to walk out of there without a solution. Because that's the whole point, is you have this high priority problem. You don't leave until you have this solution. The reason called the ID Tango is, cool, inventor comes up, says, cool, we have an idea, discerner's there, and is like, is it, this is the right solution or not? Yes, no, probably not, okay. Any other ideas? Throw them out there, bouncing back and forth. Once you've got that through, okay, now this has been a productive meeting. We came in with a problem, we're walking out with a solution. Bear in mind, when it comes to meetings as well, if you're lacking that genius on your team or within that group of people, go invite people from other teams. If you know a really good discerner that's on another team, invite him in. He'd enjoy it. He wants to help solve the problem too. If you're lacking inventors, lacking people who can really solve those problems, go find some. They're probably working with other teams that have them. Rally tactical. These are actually important, whether people like them or not. Your all IT meetings, that opportunity to see what's going on. This is that chance for galvanizing, to really get people around. Here's the direction we're moving for as a business. Here's the architecture we're looking at. This is that galvanizing opportunity to really get everyone on board when it's used properly. And that's where your focus is. And you're going to see a very different perspective when you have that good galvanizer really running that and driving things through, versus, say, an inventor who, for some reason, in the middle of it, still is trying to invent stuff. Because we see that happen, too. And enable people to move forward. And then we have our daily stand-ups. It was kind of shocking to see that in there, because it was no relationship to Agile. And it's like, nope, that's literally is every day. You're going through your list. You're going through your people and saying, OK, you got 60 seconds. What do you need? What's going on? Getting things done. This focus is the purpose of stand-up. If you're really focused at your stand-ups each day, is about how are we getting this done today? Or what are you getting done today? Any blockers? No? OK, cool. Move forward. Worst thing, and I've seen this so many times at stand-ups, is at that point, someone is in the middle of it is then, but is that the direction we should really be going? Really bad place for it. Because the point of this meeting is to focus on that tenacity. Put on that tenacity hat. Let's get this through. So as we look through the process and we look through this flow, the meetings flow very well with it. And you're able to identify with every task, with every project, where are we going down this? Have they gone through the appropriate steps? And when we're dealing with them, have we put on that correct hat? Because that's really what's going to drive these meetings and really make them, put them in that stage of, one, creating much less disruption, much less turbulence. Stop irritating people. Right? What you don't want to do is go into the wrong meeting and then start inventing things when we don't need an inventor here. And now that we have these words, and hopefully you have enough trust within your team, you kind of say, now's not the time for invention. And we can start communicating better and start understanding, okay, cool. Now, that said, does that mean you're never going to see a problem at stand-up and you should take that step back? No, you may very well do it. I'm not saying you never need it. What I will recommend is take it out of stand-up, because it's no longer a stand-up. Create that ad hoc strategic and says, we're dealing with this. We have this blocker. We have this problem. We're not sure where to go. Cool. Set up that ad hoc strategic. Invite whoever's needed. Go through the same process with that problem. Bring it back down. Really start analyzing those pieces. So the recap. 6 geniuses. Everyone has 2 geniuses, 2 competencies, 2 frustrations. You want to focus on those geniuses and help identify those. A lot of these are identified very simply by looking at the tasks around you. What is it that you're doing that you enjoy? Again, always have someone else discern your inventions, please. I have to say this a lot. Earlier the better. You don't want to spend 4 days on something invention, get it into code review, and then suddenly it's like, yeah, that wasn't going to really work. Extend trust to your discerners. Extend trust to everybody, but I'm really going to point to discerners here. From an agile flow, if you're used to it, the product owner probably ends up being that primary discerner. I will also say that there's a reason why, at least a while ago, product owner was considered one of the 5 worst jobs to have in IT. 1, the entire businesses depend on your decisions of what you're letting through. And 2, you have to get everybody to trust you at the same time in order to push things through, or you get a lot of pushback. Guilt and judgment, turn it into pride or appreciation. Every job was a 6-letter job. And beware of your competencies, not just what's frustrating you, right? You really want to try and focus more towards the tasks you really do love. Keep an eye on the turbulence. Watch your project. Look at your projects. Are they bouncing up and down at all? Or are they going smoothly? If they're bouncing up and down, bring that up in retrospective. How can we solve this? What are we missing within this flow as we're trying to push things through? An interesting tip that I've heard done, and I always thought this was interesting, is look at your calendar, look at your meetings, and go point out to each one, even update the meeting to even say, which geniuses are you supposed to be bringing into this meeting? Which geniuses should be reflected in this meeting? So that you know before you even get there which hat you're supposed to be putting on. Keep that meeting smooth, keep it productive. And look at the tasks around you. All of them. Are you a coach? Do you enjoy actually onboarding people when you're hiring new people? If not, does anyone on your team actually enjoy that? Maybe take a little less off their board, maybe on the tenacious side, pick up some of those and say, I want you to focus on onboarding. Maybe improve that documentation a little bit so that they're ready. Who knows, you may have people actually enjoy it. So where to go from here? 1, workinggenius.com, primary website. I highly recommend his podcast. He's got an entire first season of podcasts, and they just started up a second season with even more information. I do recommend taking the assessment. It does help you identify where it's kind of a nice starting point to help you identify where your 6 pieces are, or where the 6 elements are with you. They've kept it extremely cheap. It is $25 per person, 20 if you go through a certified facilitator. And the nice thing about that, it's also holiday season. This makes a great gift. This works in all your relationships, whether it's with your spouse, whether it's with your friends. Getting an understanding that, oh, hey, I'm in this relationship and neither of us are tenacious. Maybe we should start hiring people here and there to take care of a few things for us. And to understand each other there. Or, you know what? My best friend and his wife, they're tenacious. Let's invite them to help us a little bit and bring us that tenacious energy. Knowing where your frustrations are, because as I noted, you need all 6 hats. By knowing it's a frustration, it actually becomes easier to tell yourself, you know what, I need to put on this hat. And to do it and take care of it seamlessly and quickly rather than put it off and be unproductive instead. And the book is coming out next year. That was just announced a few days ago. So looking forward to that one. The first thing when I mentioned Patrick Lencioni, everyone's like, so what's the book? It's like, it's not there yet. Turns out he's not tenacious. It takes a little bit. And a little fun piece that was recently talked about is these have not been seen to change as you get older. So when you have children, and you're now able to identify, you know what, I've got this teenager and he's not tenacious. And that's okay. But learning, and it's not that he has to, can't eliminate those tasks. Yes, you have to get your homework done. But there's a huge difference between asking a teenager or trying to learn how to work with them, between saying, go mow the lawn, and you know what? How'd you like to redesign the garden? Let's say they're an inventor, right? Can you work off that invention to also help take those projects out around the house? So I thought that one was pretty cool. And they're currently reworking the assessment so that it is more applicable to the younger individuals. It is very work-based. And with work experience base involved, since that's where it was originally targeted. Now they're managing to expand that out. And there is a significant amount more there about team dynamics. Unfortunately, I had an hour and didn't want to push too much. My focus here was let you take this away, try integrating a few tips. Let me know how it works. Any questions? Yes? Mm-hmm.
What would you say is the distribution both in the general population and in a typical dev team, engineering team that's not intentionally hiring with this in mind? And what would you say is the optimal distribution of it?
Optimal, I can't necessarily speak towards. At least one of each genius should be covered. As part of the facilitation practices, what we do is we take the assessment from all the teams, we have them work. The nice thing about the assessment is split into 2 pieces. It's quantitative and qualitative. The idea being the assessment can give you the initial, but in the end, this is about what sparks joy for you. What do you really enjoy? So sometimes it's easier to start, you know what, I thought it was this way, it's shifted. This is what it actually is. So we work with teams to kind of identify those, and we lay out a team map. And what we focus on is everyone's geniuses and frustrations and making sure everything's covered and how those interact, right? If you end up with 5 inventors, well, that could be a problem, particularly if you have no one to galvanize it. So at minimum, one of each. And that's what's what they found is that really does drive teams there. General population, there was one of the podcasts actually goes over their statistics and finding. Oddly enough, the link on Working Genius takes you to Apple Podcasts. For some reason, I think that podcast is only on Google Podcasts, because I found it on accident a few weeks ago. And they talk about where the general distribution is. The majority are found to be enablement tenacious, or it's a combination of desertion, enablement, and tenacious as like the larger population. I still question on the discernment side because so much more of it is about gut feel. When they were first doing the assessment, there's still a lot of confusion with discernment and expertise. One of the podcasts is very specific about that one. So it's still, I think it's still numbers as we get more, as they're introducing this into more people, more children, more businesses out there. It's there. I do believe for the IT side, I have seen a significant amount of inventors. Anything I've done personally, both either within improving with just kind of a group of people, or as I did the similar experiment today at my current client across about 60 people, and like where people were and were not. Very low on the galvanizers. Very high on the invention side and tenacious side.
Thank you.
Yes?
I have a long-winded question.
Okay.
So, first of all, this is a really good talk. I'm a big proponent of this, but I've been subject to a counter proposal or way of aligning teams, which is to get to true greatness, I need to make you uncomfortable. So you're an inventor, and I am going to make you a galvanizer. And I've seen this even in the Phoenix Project and some other literature too, where this seems to run counter to what you're proposing. Do you have any ways of handling situations where you're in that, where you have a manager who is like, you're comfortable here and you have a core competency, you're the galvanizer, I am going to turn you into an inventor.
So I think that's one of the challenges that we have throughout, our profession as a whole, but also many other professions, where there's this expectation that everyone should be great at everything. There was a concept, even within Scrum as a whole, it was always this, oh, everyone can take on anything. We have this QA task, well, why is that limited to just these individuals? There's been a lot of attempts to kind of shift that. I think this is where we're really starting to discover, and interestingly, this is not a new concept on that front. A lot of teams have embraced strength finders, which is very similar, where they say, so strength finders, for those who don't know, break, the idea being that everyone has 35 strengths, from 1 to 35. And when you're focused on your top 5, you're going to enjoy everything you do more. You enjoy life more, right? And they really want you to focus on the top 5. At most, you stay within your top 10. Now, that doesn't mean I can't do it. I will tell you right now that in order for me to do this with you, I'm working on my strengths finder number 22. Which is my first real motivational one that I can actually kind of use, which is positivity. I try to be positive throughout this whole presentation. So it's not that you can't. However, if you want to keep those employees, if you don't want to burn them out, then you want to let them focus on their geniuses more. Because you're right, it's nice to have that inventor, but the idea is, do you already have 2? If so, why? Right? And that's where this comes down to. A lot of this is going to come down to culture. We have significant turnover issues right now. Someone's welcome to deny me on that. Right? And a lot of people, like, if I were to focus on the whole, oh, well, everyone just works from home, and that's an issue. Well, that's not true for everyone. In my own theory, I would say a lot of people who are stuck, like, I want to work from home, are on the tenacious side, because they don't want to be bothered. They just want to get stuff done, right? But if I'm a galvanizer and I want to interact with people, if I'm a discerner and I want to listen to people, sometimes that doesn't work out as well, right? And so there has to be those kind of cultural fits alongside. And if you really want to boost that culture, the idea is you focus on where those strengths lie. Classic mindset. Managers have to be coaches, right? Oh, you're going to manage this team. This is an interesting scenario, right? You have this great architect, team lead. He's been there for years, but wants to move up. And where's the only direction that he can move up is management. So one, you just took him away from his geniuses, away from what he loves to do. You lost a great architect and gained a bad manager in one shot, right? Because he doesn't necessarily want to enable people. The other side of this, and the reason I like to discuss management a little bit, is that assumption that managing people, dealing with the day-to-day, timesheets, and monetary side doesn't reflect the idea of coaching and personal coaching, getting people up there. Improving recently started an initiative called Path, and it's about building our career paths. Our path coaches are a completely separate role from our managers. And I thought this was ingenious. Granted, I came up with the idea like 5 years ago, but no one listened to me. But now I can just say I think it's a genius because it's just what it was, right? Very few organizations will embrace that type of change and really say, cool, what is that you're focused on? I am limited on time here, so there is one more thing that I do when it goes. So I've got a challenge question here. If anyone can successfully answer it, make sure they're there. I've got a $25 gift card because I love soft skills. If you can successfully answer this question, why did I wear my sunglasses on my head this presentation? I like the answer. Oh, that cut off. Was that me? Oh, that would be, and I may have just lost power. Anyone? So another soft thing that might be worth looking at. Oh. What? What's that? Actually, no. So the concept is called the alter ego. Great book, Todd Herman. There's also a nice interview on him on YouTube. I highly recommend it. Kind of helps you go stretch beyond and do some awesome things. So just wanted to point that out. Oh, low battery. That would do it. And no mouse anymore. So yeah. But thank you all for coming. I will be around all weekend, so I'm always up for more questions, and I love talking about this stuff. Anything else? Thank you all. For free. So if you are interested in having me come in and talk, those are free. I would also love to do more assessments and things of that nature with community. This works for all teams, community-based, work-based, et cetera. So.
Thanks. Appreciate it. Our next speaker and presentation is Zach Kohler. He's a chemical engineer by training, but a hacker at heart. He started programming in 3rd grade, has never let up. His first foray in open source was in the early high school, and he discovered Linux and free software at university. Electronics is his second love, and he fuses the two by playing with early computer hardware, modern microcontrollers, and FPGAs. When Zach isn't messing with computers, he can be found growing plants, drawing and exploring the world on foot. Thank you, Zach.
Just give you a moment to get set up here. Do we have HDMI coming through yet? All right, thank you everyone. Really glad to be back here in person this year. My talk that I'm going to give is a kind of a follow-up to what I gave on the virtual conference last year. Last year I talked about setting up this development environment, and now this year I'm going to go through and talk about the small hobby operating system that I built in that development environment. So my name is Zach Kohler. My handle is Y2KBugger. I'm a chemical engineer, but it seems every job I go to, I end up doing programming. And so I've actually transitioned my role from a materials engineer programming, electronics, and retrocomputing. And some of the things that are completely irrelevant to what you're about to experience, I like to run. I'm interested in punk rock, and I do cheese making. Real wheels. So today we're going to talk about why am I motivated to even look into this, why write another operating system. It's never going to be something big and professional like Linux. Then I'm going to explain like a 5-minute version of my talk from last year, covering the bare metal RISC-V renode environment. Then I'll give a brief overview of kind of history of operating systems or like what their purpose is, why do we have them. And then I'm going to talk about the particulars of my Kohler OS. That's my operating system. I didn't name it after myself because of vanity. I just saw a really good opportunity to call it Chaos. So this kind of separated into the early startup. So when you hit reset and you pull that electrical pin high on the CPU, what happens when you first start? What is the first instruction to go through that CPU, and how do we get to the shell? And then once you have the shell, you need to load other programs. And I'll just talk about the multitasking and the process lifecycle. And then finally, I'll wrap up with system calls. Like, you'll note that some jobs of operating systems are missing from this, and that's because I've intentionally kept it very simple. And of course, I'm going to build on that later. So the whole purpose of this talk is I wanted to learn from a toy operating system and explore that line between hardware and software. So why learn about this? Computer science is really based on abstraction. All these simple interfaces allow you to create complex systems. When you send a text message, you're probably going through 100 layers on multiple devices and all through the routers and the internet. But you don't think about that, and you don't have to know that to write the application that sends the text. And when you're sending the text, you really don't have to think about it, and this is a very, very good thing. But sometimes it's good to peek under the hood. And so you have a whole set of layers just in a single device, and now we have networks of networks. But for one computer, you have silicon at the bottom and a bunch of different abstraction layers before you even get to software. And at that interface between software and hardware, you have the CPU architecture and then the compilers that create binary code for that architecture. So last year I kind of talked about the CPU and instruction set. And so this year I'm going to talk about the operating system. So two other things that I've done before getting to this point. The first one was I just breadboarded up a Z80 CPU, and I hand assembled a very simple program, 2 + 2 = 4. And with the switches, I put in each opcode and then into memory, and then ran the CPU at about 1 Hertz. Every time I press the button, that's 1 clock cycle. And I can actually inspect all the buses on the CPU and see exactly what was happening at each spot. Go access memory, pull this value in. And it was really cool to see it happening in real life. And then I followed that up with making a CPU emulator where you could actually adjust the microprogramming and say, okay, let's create a jump instruction. What do you need to do on the register transfer level to say, move the data around, move the stack, move the pointer, move your program counter to do like a jump or a conditional branch. And so this is like my next step on that journey. So what is bare metal? When you go to run a program or when you compile, like say a C program today, you're typically compiling it to run with a specific operating system in mind. In contrast, when you're using bare metal, you'll use the -free standing, and you tell the compiler that you're not going to be running this on an existing operating system. You're going to have full control. So why would you not want to run it on an operating system? Well, maybe you're writing an operating system. So I think if any of you have seen the -free standing argument, It's typically you've been compiling the kernel on the command line, or you looked into the build scripts. I think it's also used when you're compiling a driver module on its own, a kernel module. But when you do that, you're kind of sacrificing a lot of the things the operating system gives you. Even just trying to open a file, you don't have that anymore. So it really makes it so that every single instruction that's running through the CPU is something that you've either written in assembly or written in C. And so it's really good for learning if you're trying to understand at this very low level. Sometimes there's like a little in-between layer where you need a lot of control over the hardware, but you don't want to schedule processes yourself, and you'll see why in a minute. You'll go grab like someone else's real-time operating system, and it'll give you some of those utilities, specifically maybe the multitasking or some event-based architecture. And I did this in RISC-V, so I figured I'd give it a little bit of a shout out. RISC-V is an open source instruction set. It's been around for a little while, but it's really been gaining traction recently. It's a RISC architecture, and it's an academic architecture, or it evolved from academic architecture, where they took all the bits of what we've learned over the last 50 or 60 years about CPU instruction sets, took the best from all the world, all the different ones out there in the world, and then created this open standard. So the goal is to say, have everything from small embedded CPUs all the way to supercomputers be able to use different extensions of this CPU architecture. This avoids the costs of being kind of locked into ARM or Intel. And hopefully we get some performance improvements, and really, especially going from idea to production for actually creating new hardware and new chips. I mean, like you could see a lot of phone companies are starting to create their own silicon now, let's say for AI acceleration. RISC-V takes 18 months out of that development cycle because you don't have to deal with ARM and get all the contracts worked out. It's like the Linux of CPU architecture. And then the simulator that I'm using is called Renode. It's kind of targeted at embedded firmware, and it gives you a lot of flexibility over what that virtual hardware looks like. And I have it set up to be very, very simple. It's just a CPU, memory, and a hardware timer interrupt. So basically, and a serial port. So I specified that in Renode, and we're going to program that. So I need to program drivers for the two pieces of the hardware. Some other emulators, you could think like QEMU, or if you're playing video games on an emulator, those are more, some of those are made for like desktop emulation, or some of them are made for video game emulation. And they're not as flexible, like they're opinionated in a way that makes them useful for what they're made for. But Renode, it's like you configure the hardware down to where you map the memory. So what were the first operating systems? The first operating systems were human operators. It was batch processed. You get a stack of punch cards, and you would bring them to this guy, and he was the one that would set everything up and run the computer. And you'd put your program through, and you'd get some output. So it was very, very simple. You had your input, you get your output, or else it crashed and you get a bunch of error messages. But every program had full control over that machine. You couldn't run two programs at once. You had to wait for the one to be done. So you'd drop off your cards, in the evening and come back, the next day and get your cards. You had to wait in line. And so when we replaced human operators with an operating system, what do you get? You kind of abstract away all the things that make a certain computer specific, and eventually you end up with a portable operating system. But you get certain interfaces for input, output. How do you control all the different processes running on a computer? If you're going to be running more than once, you can call that time sharing. More than one at once, that's time sharing. If you need to protect different processes from one another, you have memory management. And you also can separate out what parts of memory that different processes can see. So you don't want some app that you download from the internet to be able to control your Wi-Fi hardware except through your operating system, who can build like a secure interface that gives the user control. So just one note about time sharing. So let's say you were going to try to have a human operating system swap out those like punch cards. You'd have to be doing it 1,000 times a second, and you would never be able to do anything. So think of it, if you had to have input to your program, you would have to have someone stand there and change the flow of the program as the computer's running, and that's not something that you would really want to do. Okay, so what am I going to cover in my chaos operating system? I scratch out everything except the time sharing aspect. RISC-V supports all of this, all the rest of this, but my operating system just doesn't implement it, and that's to keep the code clean and simple, and I just haven't got there yet. Like, I would love to write a file system and then be able to load programs off of a persistence method. But right now, everything is statically allocated in the memory, and all the programs are written in the same program language as the operating system itself. It's kind of homogeneous. So when you first boot up the operating system, you get what's called like a monitor or a shell, depending on how you think about it. If you're into like retro computers, they always call it a monitor, and maybe you're going to peek and poke at memory or load in a program from a hex dump. Or if you're thinking more of like modern Linux, you have a shell. It's the thing that talks to the operating system when you say, I want to launch a program. The shell goes and does all of that and interacts with the operating system for you. So basically, it's the first layer on the kernel. In mine in particular, lists out all the programs. It allows really, really basic job control. Like if you know Bash, you can put a program, you can stop a program, put the job into the background, or kill it with Control-C. Mine's like a very basic implementation of that. So if the shell launches all the programs, but the shell itself is just another process, how does the shell get launched? Okay, so we're going to rapidly get more and more technical here. If you look at these slides and you see the start label, that's written into the operating system. That's in assembly. It's an assembly label. And it's kind of a contract between the linker to put that in the correct spot in the binary image and a contract with a renode to say, when I load this binary image into the computer, we're going to start the program counter right at that location. And so this is where we go to find what is the very first thing after you hit reset that the first instruction the CPU is going to run is going to be right here. And so you can see I set one of the control status registers, mtvec. Basically, that is the address of the interrupt handler. So when you interrupt a CPU, the code, no matter what it's doing, if you're running a program, you're running an app, if you get a hardware interrupt, it's going to finish that instruction and then immediately jump to the interrupt handler. And so we got to set up where that is going to jump to, because that's like a core component of the operating system. We also turn the interrupts on because they're off by default. So that's what that second block is doing. It's just saying, okay, we have a bit there that turns on the machine level hardware interrupt. So after you set up the interrupt and turn them on, we got to set up a stack pointer. So if you're just writing an assembly, you don't have to have a stack. You could write it without it. But when you're doing more complicated things like a function call, you need a stack to be able to push your arguments onto and a way to get back. So anytime you're writing C, every time, as long as it's not inlined, every time you call a function, you're going deeper into that stack. So if you're going to run C code, you have to set up the stack. I found this out. It makes sense, but I didn't know it wasn't automatically set up to some point in memory. So I was writing an assembly, doing this. I got it started up. And then I called a C function, and the C function worked. But as soon as I called another function from that function, it just crashed. And I was trying to figure out, why is it crashing? Well, it's because I didn't have a stack set up. It was trying to write to a memory location that didn't actually have memory on it. And so you set up, this is the stack for the very base interrupt service handler and for the early startup. Also, we initialize the thread pointer. That's the register in the CPU that I use to identify each process. And so that's kind of, you can think of it as a global pointer. And then after we set up that, the stack pointer, we can get out of assembly because you want to do that as soon as possible. Before I played around a lot, making stuff come out of the serial port directly in assembly, but really you want to get out of that as fast as possible to make everything look a little bit cleaner. And so we call this function init kernel. And we'll go through and initialize the UART, which is the serial port hardware, register all the programs, and we'll talk about that later. Basically, you're associating the executable code of a program with a name, which is a single character. And so once you get all those programs loaded, you can see lookup program, init process. That program S is the shell. So we're going, grabbing that program out of memory, doing everything we need to initialize it. So we give that program its own stack, and it gets its own stack pointer. And then we set it to be the current process. The scheduler knows how to use the current process when it runs the later in the operating system. We'll talk about that later. And then we initialize the hardware timer. So what that does is we tell it how many milliseconds between actuations, and then every so often it'll throw a hardware interrupt and it'll automatically jump. So that's the last thing we want to do, because if we do it too early, it'll start interrupting our early startup. We don't want that to happen. And that final bit where it says eCall, that just forces an interrupt immediately. It's a software interrupt instead of a hardware interrupt, but what it's going to do is immediately jump to the interrupt handler. And so once we get through all of that, we jump to the interrupt handler. The scheduler takes over, sees that current program, and will do everything that it needs to do to jump and start the shell. And so now we're presented with this, and we have a couple programs that we can run, and we have a couple of these job control built-ins. Okay, so what is the makeup of a program and a process? I try to keep this as simple as I possibly could to have a working multitasking operating system that I could play with. And so what's the dumbest thing you could think of to do a program? It's just a C function with a name. And so when I say register all programs, I have a list where I've registered every single program that I want to run as a C function. So it's a pointer to the executable code. And then I just simply give it a name, and then that's a struct. And then when you initialize that into a process, you take that little function, you give it its own stack and stack pointer, and this is everything that that program needs to run in isolation. So you can kind of think of it, everything that we did in the early startup to run that main kind of bootstrapping bit. This is a more rigorous way of doing that for each individual process. But those are the basic things you need to do to run a C program. Yeah, so let's talk about the life cycle of one of these processes. And so you start with a C function. It could be any C function. There's a couple of things you need to do to terminate it within the operating system, kind of a standard. But when you go to register that C function, you give it a name. So we'll take hello world, and then we'll register it with H. And so now that C function has become a program. Then when we go to call initialize a process, so say from the shell, we take that program and we initialize it with that process. So again, we give it a stack, and we give it that stack pointer, and we initialize the stack with the data that we need to be able to go through the context switch. And then once you tell it, when it's done being initialized, you get a process that's ready to run. It's not running yet, because when you're initializing it, you're running in the shell. So you're basically setting up the process, saying it's ready, and putting it on a shelf. And then the next time one of those hardware interrupts comes along, then the scheduler will say, okay, let's stop the process we're running and see if there's any other processes that are ready to run. And if there are, it'll make that the currently running process. And so in a round robin fashion, if you have 4 different programs or 4 different processes that are waiting to run, it'll run them one at a time, each getting a different slice of time. If the program terminates normally, it becomes a dead process. If you kill it, it becomes a dead process. But you can also, from the shell, if you do Control-Z, issue a intent to stop whatever's running in the foreground, and then it becomes a stopped process that can be restarted. Oh, I should have put another arrow for restart, opposite of stop. Okay, so I'll give you a quick demo. I just want to launch one program from the shell. Okay, so I'm going to kill the current one I have open and just start from scratch. This on this side of the screen, on the right-hand side of the screen, is basically polling for the serial port to come online. And so when it's fully booted, you see we're greeted with the chaos shell. And then if we look in the renode output just a little bit, you could see loading segment, some numbers and some bytes at a certain location. That is renode taking the image that I've compiled using GCC, picking it up, putting it into the memory, and then it knows that _start label is where it's supposed to start, so that's where the program counter goes. The program counter is the register in the CPU that says, this is the next instruction that needs to execute. And so that will match up with the binary image that we loaded. So now we've gone through all that early startup. If I say question mark, we print out everything in the usage for that shell. And so let's run just a simple program. So I say H and I get hello world, hello world. What that's doing is telling the process, it's taking that program, turning it into a process, setting it to be ready, and then when that hardware timer comes along, it runs that program. So most of these are short enough that they're probably getting ran in one time slice. But if you kind of think about it, all we're doing, or at first it could appear that the shell is just a C program and it's calling another C function. So I could have very, very easily written the shell to say, if the character is an H, call this function. It's just like a dispatch, like with a switch. But that's not what it's doing under the hood. So I want to give a demo to show that it's not just calling out to another function, that it's really starting processes and doing multitasking. So let me start fresh again. And if you see, we have a program called count forever. So now we have an infinite process. And so what this does is just counts the digits over and over and over again, and we're running. And so if I want to kill that process, I do Control-C. So now it's dead. And if I list all of the stopped processes, it's not there because I killed it. So let's run it again, and let's stop it. Now let's list out the stopped processes. So now we see we have one C that is stopped. So I could still run hello world, and it stopped at a bad place. It stopped at 0, so it's going to continue at 1 if I continued it. But let's start them all back up. And so that's running again. So, and I can just as easily stop it. And let's start another program. I think I called it Laugh Forever. And put that into the background. So now when I list them out, we have 2 stopped programs. Both of them are just sitting there. The only program that's running now is the shell. But I'm going to issue the final command, restart all stop processes in the background. And I'm just going to stop them so you can read it a little bit better. But you can see the output is switching between numbers and ha 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 ha. So what it's doing, you're getting about 15 characters of output before the hardware timer comes along, says, okay, back to the other process, back to the other process. It just switches them back and forth. So if you're writing a game, maybe you have two different processes running at the same time. One of them is sitting there looking for input. The other one is doing something with the video output. But when you're controlling it, it feels like everything is all happening all at once. So I guess the key to the whole multitasking thing is the thing called the context switch. So how do you switch from running one program to running another program? You're used to, I mean, all your devices work this way, but it's kind of an unnatural thing when you actually look at the code for it. It's really interesting because it's something that can't be written in C. It's kind of outside of the spec. If you tried to write it, you would fail, unless you put inline assembly, and then you're not writing it in C anymore. It's CPU architecture dependent. So if you're running on ARM, you have to do the context switch one way. If you're running on x86, you do it a different way. And the way I implemented it was on RISC-V. So you'll see the RISC-V assembly for this. And then, as I've said, it's triggered by that hardware interrupt. Every time that timer comes along, we go and we switch between any of the available processes. And so the stages to the context switch. So let's say you have that laugh forever running. It's just going ha, 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 ha. When that hardware timer kicks in, it's going to immediately jump to that interrupt handler, and then assembly code will go and back up every register in the CPU, saying, okay, maybe X1 has a value of 400. It'll take that, put it on the stack. And so everything that the CPU needs to be running at that moment, it'll back it up into memory onto the stack for that process. Then it takes the other program, so let's say the count forever, it switches that to the current process using the scheduler, and then restores all of the registers backwards from the stack. And then at the very last moment, it switches the program counter, which remember that is what is the next thing to execute. It'll switch that to exactly where the count forever was, where it left off. And so I'm going to show the code here. I'm not going to go over every detail of it, hopefully. Hopefully for you. But I just want to give you kind of a feel for what those three stages look like. And so this is the interrupt handler. So you can ignore this. This is just the first case when we don't have a running process. We skip the backup. But you can see in the store process, we allocate all the space on the stack, store all the CPU registers that we need to onto that stack, back up the old program counter. So the program you just interrupted, the CPU backs up that the program counter that you just interrupted. It backs it up in a register called MEPC when it calls the interrupt. And so we have to back it up ourselves a second time, or else it's just going to jump back to the same spot. And so we back up what the CPU has saved for us into that final location on the stack. And now we have our stack pointer for that count forever process. So we take the process that had just been interrupted, take what its stack pointer was, and store it in that process struct. Let me show you here. In the running process, you have that the very first element of that process is SP. So that's the stack pointer for just that program that just got interrupted. And so when we back it up, we're saying put it at that pointer location for TP, the thread pointer, which again, that's the global pointer for the currently running process. That's the one we just interrupted. So if we store that pointer that's at that location, we're storing the stack pointer for that process we just interrupted. And so in essence, we've backed up everything we need to resume that process at a later time. The entire state of the program is just stored here and can sit there forever without running. So when you hit Control-Z on your bash terminal and it says you stopped a process, you're doing the same thing. You're backing up everything of that running process and just putting it somewhere, and it does nothing. It consumes no resources except for memory. Okay, so here's the middle bit. You can see we restore the stack that we're using for the interrupt handler back to that global memory, and then we call the C function handle interrupt. So what that does is it does a few things, but when it comes from a hardware timer, the interrupt will just run the scheduler and reset the hardware timer. So when you run the scheduler, you just say, okay, we have a currently running process. Are there any other that are ready to run? And just in a circular fashion goes through all the possible processes that are there. And if there's one that's ready, it puts the next in line. And it swaps them out, that global variable for the currently running process right here. And so after the scheduler is run, we put the new currently running process in this TP register so that we can use it later in the assembly right here. And so what do? We just do the reverse of what we just did. We backed up all the registers, we backed up this pointer, and we backed up the program counter. So we restore the stack pointer because we're not going to use it in our assembly. Whoa. And we restore the program counter from the MEPC, or to the MEPC, and so that when we leave the interrupt handler, it's going to take that program counter and jump back to exactly where we were before that process was interrupted. And so that's our way of telling the operating system, this is where we need to go. That's that MEPC. And then we just do the reverse of all the registers. Take them all off the processes stack, and then finally shorten the stack again. We give it back that memory. And then MRET. MRET means exit that interrupt handler. It's part of the assembly, and it tells the CPU, okay, do everything you need to do to jump back to where we were. Namely, the most important is swap out the program counter for that MEPC, the machine exception program counter. And so this is how we leave. It's kind of, you can think of it as the opposite of eCall. And it goes right back to exactly where the program was running, and the program that was interrupted never noticed anything happened. So when people say context switches are costly, this is what they mean. When you're switching between programs and you're doing all this time sharing, you're executing a bunch of instructions just to back up that one, the one process and switch to another process. In the grand scheme, it might not be that, it's not that much overhead anymore. So what are system calls? Software interrupts or eCall, they're all the same thing. It's how a program can talk to the operating system without, it's basically asking it to do something for it. And so let's say you're in an operating system that actually has user privilege modes enabled. Basically, you're not allowed to talk to the hardware. If you were actually writing a program that output to like standard output, you wouldn't go and bit bang on the serial port. You would want to talk to the operating system and say, hey, open a file, and I'm going to write to this file. And maybe that file is mapped to the hardware device. And so how does that communication happen? That's through software interrupts. So I have a basic implementation, and it's kind of experimental right now. I'm kind of getting the feel for how all of this works. And so half of this I'll show my code, and then the other half I'll show what a real standard library implementation looks like. So my normal hello world program, you just print the string and then terminate the process. The hello eCall world, I think I have that designated as E when I register it. We print hello, load the integer 5 into the A7 register, and then we call eCall. So basically, at that point in the program, control jumps from our user space program, this hello equal world, it jumps into that interrupt handler again. And if you look at what happens when we actually call that handle interrupt, let me make this a little bigger. So after we back up the currently running process, I said we call the scheduler. Well, it does a little bit more. The handle interrupt will check to see if it was caused by the hardware timer. If it was caused by the hardware timer, it's going to run the scheduler. And so that'll let the next process go. Otherwise, it's going to have this eCall. It'll check the code and say, why did we get here? How did we get to this interrupt handler? And if it's from the eCall, it knows that it's supposed to be a system call. And so it'll look into this A7 register. So that's what I'm designating right now. I think that's the actual standard in RISC-V for the calling convention for Linux. But we could make this any register. But basically, you have to create an agreement between the user space and the kernel to say, when I call a system call, I'm going to put which function I want to call as a number in this register. So maybe I loaded 5. You can see I put 5 in there. 5 might be open a file handle or a descriptor. Or it might be do something else. I don't know. But it's communicating. And you can also use multiple registers to put arguments to that function. And then when you finally call eCall, that's when it all happens. So the operating system's job is to say, okay, if it's a 5, do the thing that you're supposed to do when there's a 5. But I don't have any of that implemented. So what I do is I just print out that number. And so I'll give a quick demonstration of that. But you could see how we're jumping between user space and the kernel. So if I do hello equal world with the E, you can see it prints the 5 in between there. It's like a really roundabout way of printing at 5. But it's kind of to demonstrate how a system call would work. And this is way too small for you guys to see, I think. But if you go get the slides, can anyone see that? No. So this is Muscle. It's an alternate C standard library. And you can see in about 25 lines of code, you have the definition of fopen. So that's what asks the operating system to open up a file. And if you look at it, in line 27, it looks like they're calling a function called syscall. Well, what that's doing is taking the standard C calling convention for whichever architecture it is, and then they implement syscall with assembly. So like I said, it's architecture specific. So this is the one for MIPS on the right. So the left is the C, that's portable code. And then on the right, you have handwritten all the code that you need for it to act like a C function, written in assembly specifically for MIPS. You'll have to do the same for ARM, for x86, for RISC-V. But basically, it's taking all the arguments, putting them in the right spot, and then it calls on line 29 in the assembly. It calls syscall. And then that jumps to the kernel and allows it to handle it. So this is Linux specific, but it's also it's POSIX specific. And so it follows that calling convention. But this is how it's implemented in a real library. And the total amount of code from the portable C and the assembly side is just 60 lines of code. So it's amazingly, they really crunch down that architecture-specific bit into a very small amount. So I talked about why I'm exploring this thing in the first place, probably because I'm crazy. And then I talked a little bit about this programming environment where it's very easy to see what's going on in all the registers. If you look at my previous talk, you can actually debug in and see each CPU register, pause it at any point, and step through all the assembly code. And that allows you to really get a feel for what is happening at each step. I talked about why do we have operating systems, because we couldn't live without them. And then we went through my basic chaos operating system, from startup to how to make a system call. The real key bit to take away from this is just remember, you may have 4 cores, and so you think, okay, I have multiple cores, I have 2 things running at once, but you have hundreds of things running on your computer if you're running Windows, or like dozens if you're running Linux. And they're all running in time slices, and they all could run on one CPU. This is the fundamental time sharing idea. And all of that happens with a context switch. The programs don't know that they're being swapped out, and it's all done from right underneath them using assembly or machine code. So things I didn't cover, there's probably a million things I didn't cover, but other things you might want to explore I might cover in the future. Probably file systems and privilege level interest me the most, because the file system, you're interacting with hardware, but you're also providing like a really robust API for the rest of the operating system to use. And I didn't go into the drivers that I've written. It's not like it's like a specific driver module. It's just the segment of the code that talks to the hardware. And so you initialize a couple registers in that hardware, then you pass it some data. Every time I want to print out a character, I write to a memory location, and I might go into that further in the future. If you want to try this yourself, you can pull down the code, and I have a tutorial about how to set up this environment, and basically installing all the tool chains, GCC, Renode, to actually run this for yourself. And I also have the whole thing open source. You can get the link here. And thank you. Does anyone have any question?
So I might have missed this, but the hardware interrupt and the timing that's involved, is that something that you implement, or is that something on the architect?
So it could be implemented in real hardware, but the way I've implemented it is in Renode. So it's a good thing to dig into. It's part of the simulated hardware. So when I simulate the hardware, I specify everything I'm going to run in these 2 files. So this is the whole hardware spec right here. So we have a system bus, which is how all the different pieces communicate to one another. We have a CPU that attaches to that bus. And then we have the memory. And then we have 2 pieces of hardware. We have a hardware timer and the UART, which is the serial port. And so both of these are implemented in, I think, somewhere between some amount of C++ and C#. I know for a fact the LiteX UART is written in C#, as well as Renode is written in C#, but it's not a transistor level emulation. It's really like high level. So it's hardware emulation. Okay, so I didn't write Renode for sure. So all the hardware emulation that's just a publicly available thing. So LiteX UART, I did not write. I just put the hardware together. So I'd say it took about maybe a year of on and off playing to get like this very, very minimal hardware. I modified things that people gave commercially. So let's say you created a new product, it's a dev board, or you created a CPU. And then you want people to use your CPU, so you make a development board. Then if you want people to use your development board, you set up a Renode specification. So you come up with something that's maybe 100 lines long and has all these GPIO pins, Wi-Fi chip, Ethernet chip, all these complicated pieces of hardware that perfectly emulates their dev board. And then they have a transistor level or possibly like register RTL logic level simulation of their CPU. And so I took those things from vendors and condensed it down to like the very, very minimum CPU there could be. I guess that took like a year. And so at that point, all I had was a serial port that I could output AB, AB, AB. And when I gave it input, I could switch what was coming out of it or make it echo back. And so since this conference last year, I've actually made it into an operating system where I can swap processes.
Thought about running this on real hardware yet?
Yeah, all the time. It wouldn't be that hard because if you look at the CPU I'm using, VexRISC, that specifically CPU.VexRISC is a C# emulator, but it's made to emulate an FPGA implementation of RISC-V. So if I went and got that FPGA, I could put the CPU out there, and it'd be pretty easy, I think, for me to put the memory map correctly and modify it just enough to get that working. But yeah, that's what I want to do next. And then after that, I want to create my own CPU. Not something RISC-V, but create my own instruction set that's like really dumb and just as simple as this. A minimal amount of instructions, and then write my own context switch for my own CPU. That'll be after I just run this on normal hardware. Yeah, that was a good question.
Have you seen any of Ben Eater's stuff on?
Yeah, so I had that slide in and I took it out. I think I gave that 2 years ago. But let me go to this slide. That's what started all of this in 2015.
Okay.
So I get,
My
yeah,
question is, I'm curious if the kind of stuff that he does, you could do something comparable with this, or is that?
like a YouTube channel.
That's not what I meant specifically. If the code that you are writing, the OS you're writing, reasonably could be used on a breadboard computer built
Yeah, definitely. So the breadboard computer that I showed was, well, that was a Z80, so it definitely could run real code. Could you do multitasking with Ben Eater's computer? It doesn't have interrupts. You'd have to add interrupts to it.
Let me rephrase that. Would it be possible to build a RISC-V CPU out of discrete logic gates?
Yeah, it's really hard. There's a couple YouTubers that are working on that right now. Robert Bausch, I think, is one, or maybe, I don't remember his name, Robert something. But he reverse engineers CPUs, and he's been working on making a RISC-V. I guess it's not breadboard. He's doing discrete components, but he's making boards. It's been like a 2-year-long project, and I think he's still working on it. But you could definitely make people have made TTL computers, which is basically like a dual inline pin. So when you think of like a computer chip, they've built it out of that, and it's just like 4 or 5 big boards. And there's a guy who built one of these. He's actually the guy that wrote the Dalvik Java implementation for Android. He built one, and he ported Minix to it. It was his own architecture. He invented it, ported Minix to it, ported the C standard library, and then all of TCP/IP and put it on a server. And so he has this thing that he breadboarded every component of the CPU. Like he made the CPU, and now it's running a web server, and you could actually talk to it. That's really cool. It's called Magic 1. I would go look at that YouTube video. It's called like 10 years of Magic 1. Any other questions? We got 8 minutes. Mm-hmm.
Have you considered maybe porting your operating system to something like that?
Like a real development board? That might be a better first step than FPGA, actually, because then I wouldn't have to mess with the FPGA stuff. They've been pricey. I've seen a couple. I think they're like a couple $100 because they're low volume right now. I bet there's some cheap ones I could find nowadays. That was like a couple years ago. That's cool. I'll have to look into that. Do I see a hand there? It's hard to tell with the light. All right. If there's no other questions, thank you so much.
Thanks, Zach. Those of you who purchased lunch tickets, they're going to be in Union A and B. If you're on your own, there's down the hall here in the lower part of the conference center, there's Subway and some places like that. There's some places to eat that are not too far away. So thanks for attending, and we'll see you in about an hour. All right, it's my pleasure to introduce Stephen Pritchard. He's a Puppet certified professional currently employed as a senior consultant at Onyx Point, focusing on Puppet, compliance automation, and all things DevOps. Stephen?
Minor point. Actually, the company I work for is called Secura now. That was written some number of months ago. So, want to talk to you all about a little bit about GitLab. I like GitLab, so should you. Let me see if I can get this working. Nope, keyboard it is. All right, so who the heck am I and why should you care what I think? Well, I have been running Linux users groups forever, since 1994 actually, and I even do other nerdy things, like I ran for a while a Vim users group called Vim Geeks. I've been known to write a book. I do a fair bit of training for work, but in the context of this talk, the important thing is I'm a fan of GitLab. I actually got started using GitLab at my current job, and had never used it prior to that. Just kind of fell in love with it, to be honest with you. It's a darn good tool. And as a bonus, the company Onyx Point that I was working for is a GitLab partner. We have since been spun off into a separate company, and so I put a question mark on the GitLab partner thing because I'm actually not quite sure where we're at with that. But I guarantee you that if anyone listens to this and comes out of here thinking, you know what, I really could use some GitLab consulting, I guarantee you that I can fix that and find out exactly what's going on and straighten that all out. I'm a principal solutions architect at Secura. Secura does compliance automation software. So we've got a table right over there. So come see us this evening and we'll tell you all about it. So it's hard to talk about GitLab without doing a little bit of an introduction to Git. So what is Git? I think XKCD summed it up best. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. And cool, how do we use it? No idea. That's pretty much it. That's how everybody feels about Git until you suddenly become a master of it because you've been using it for so long. I kind of thought that the mouse over text on this one was particularly amusing. If that doesn't fix it, git.txt contains the phone number of a friend of mine who understands Git. Just wait through a few minutes of it. It's really pretty simple. Just think of branches as ... And eventually you'll learn the commands will fix everything. I have, in fact, been the guy that said, well, it's really pretty simple. Just think of branches as... And so, yeah, anyway. I relate to this comic far too much. What it really boils down to for nerds like me who want to talk about branches and things is just a bunch of command line stuff that does things to track source control, track changes and store source code in a way that's distributed and safe and so on and so forth, right? But to be honest, that's not really the interesting thing about Git. There is lots of interesting stuff about Git, don't get me wrong. But I don't want to, I could sit here and talk about it for days if you let me. So rather than do all that, if you go to this URL or if you search for GitLab on about.gitlab.com, I think, or docs.gitlab.com, they have a page that summarizes lots of stuff about Git, and in fact, I've got the page open here. And if you look, there are resources about getting started, and concepts, and working with Git on the command line, and troubleshooting, and advanced topics, and all kinds of fun stuff, right? And it just goes on and on and on and on and on. So I don't want to spend all day teaching you about Git, because that's actually not the fun part. I do want to talk about a little history, though. So Git has been around since 2005. I won't tell you the whole sordid story behind it, but needless to say, Linus Torvalds, the guy that also gave us Linux, wanted a source control system that he could use for managing the Linux kernel. He wanted it to be distributed. He wanted it to be fast, and he wanted it to be frictionless, because anything else and he wouldn't use it, right? So Linus decided to write his own, because that's what Linus does, and he wrote the back end of the thing that we still call Git to this day in a couple of weeks. Honestly, mostly knocked it out in a weekend. It was insane. The Linux kernel mailing list posts from back in that time are just a fascinating read, because he goes through all of the reasoning why he did things the way he did it, and yeah, it's a great read. Everybody jumped on to Git because it was awesome. There were other tools at the time that did similar things, but they were mostly all slow. And Git was anything but. A whole community popped up around it, started building the command line tools around it. It really took off. In 2007, development began on GitHub. I have to mention GitHub because GitHub actually gave us a lot of advancements in the way that people use Git. By the way, 2008 is when GitHub.com actually launched. But the development started on in 2007. GitHub was not only a web front end to Git that would let you view your files and download things, and you could use it as a central repository, but it also started the idea of tacking on a wiki to a Git repo to a project, so you'd have an easy place to put documentation, and probably the most important thing that they did was prior to that, if you had a Git repository somewhere and you had a copy of the repository and you were making some changes and somebody else had their copy and you wanted them to pull in your changes, you'd have to coordinate via email and all kinds of stuff. And GitHub made it really easy to just click, 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 done. You have something that looks like just a ticket, right? So that's when Git started to really take off, was after GitHub came along. In 2011, development began on GitLab.com, and the story that, as I understand it, is that the guy who started building it wanted to be able to run something that looked like GitHub locally, and he wanted something that was open source, right? So GitLab gives you the ability to run something that looks like GitHub locally, and also, say, it's open source. It has since evolved. In 2012, I think it was, GitLab.com launched. So there's actually a hosted version of it that you can use, much like GitHub. The GitLab, the company that started up around this, eventually became a open core company. So everything I'm talking about today is the open source version, the community edition, but there is an enterprise edition that adds additional features. All right, so enough of me yammering on. Let's go look at a demo. I have GitLab all spun up here on my laptop. And so I've only got a couple of projects in here, but you can see this is what your main page looks like, and it just kind of shows you an overview of projects that you've recently worked on. If I go into one of these projects, you can see that we have all the files in the repository. We can look at individual files as much as we want. Much like GitHub, it automatically renders your top-level README file, as in this case it's Markdown. So we've got some basic documentation. When people stumble across the repository, they can see. If we go over to the side over here, you can see we can not only look at the files, but we can look at individual commits, so we can see the Git history. We can look at branches, because branches are a thing. Tags are another thing in Git. You can tag a specific point in time, specific commit with a helpful name, and you can see like contributors and some other fun things. So hey, look, lots of James Evans in here. Let me see here. And there's also these fun things like you can see a graph of your changes and stuff. So as you create branches and things, they do some visualizations. So this is basically the extent of the part of GitLab that's really focused around Git per se. A lot of the stuff that makes GitLab interesting actually has very little to do with Git proper. For example, we have issues. So I wanted to remind myself what I wanted to talk about, so I created myself an issue. And we have now talked about repos, commits, branches, tags, that sort of thing. So let's talk about wikis. If we go to a project, over here on the left side, there's a wiki. And I don't have much there, but you can just go in here and you can create pages and stuff. And they've even got a spiffy new editor that'll do visual things so you don't have to do Markdown if you don't like it. But that's going to look very similar to what you'd expect if you've been a GitHub user. Let's mark that off. So let's talk a little bit about issues. So we can get our issue list. I've just got a handful in here, and I've got labels on my issues. I can kind of categorize them with what kind of an issue it is. So I know that a bug may be a higher priority than tech debt or a feature request or whatever. These are just whatever makes sense for your environment, right? I'm going to go into this issue here, and this particular thing is an easy one. I actually know how to do this off the top of my head, so I'm just going to create a merge request real quick. Except I actually have to hit the button. Oh no! Demo fail. I'm having to running this all in Vagrant, and I've got a port forward, and every once in a while it tries to use the name of the VM, and that doesn't work so hot. I thought I could create Is it going to do it? No? Oh, why do you hate me? I swear I did this the other day. You know what it was? I'm an idiot, and since the last time I ran through this demo, I upgraded GitLab. I should know better. Rookie mistake. I'm out of practice. It's been 2 years, right? Anyway, what are you going to do? All right, so let's go about this a different way. So I am actually going to go into this project, and I'm going to open up the web IDE. So this is, again, built into GitLab. If you're used to using any of the Electron-based editors like Atom or VS Code, this should look very familiar because it's the same kind of backend. I'm going to go in here, and I'm going to make a couple of minor little tweaks to some files. I'm going to say mod, and I'm not going to bother explaining what I'm doing here. It's Puppet stuff. If you're not into Puppet, you're not going to care. And if you are into Puppet, you're going to know exactly what I'm doing. So I'm going to go into common.yaml, and I'm going to add ZRAM. All right, so I've made a couple of changes. You can see here that I've got a change to my Puppet file and common.yaml. I can review those changes, and I can say I already forgot what issue that was. Ugh. You're killing me, man. Go double check what issue number that was. Number 3. All right, so I'm going to say fixes number 3, create a new branch, issue 3. Really? This was working just the other day. I should be able to go. So what I was trying to do was avoid going to the help on here and seeing the little thing that says there's an update available. And so I thought I would be clever and just go ahead and do that upgrade. Okay, so actually, let's so we're going to say add ZRAM. And we are going to create a merge request. So if you're used to GitHub, then you're probably familiar with the idea of a pull request, right? And that name pull request, like say, comes back from the days when you would, by email say, hey, can you pull my changes from my Git repository, right? So it made some sense. GitLab decided that it made more sense to call these things merge requests because you're asking to merge this thing into your tree, right? So it is probably the single most frustrating thing as a GitLab user when you're going back and forth between GitLab and GitHub, because you'll say MR and then you'll say PR, and they both mean the same thing, but it gets when people aren't used to GitLab, you say MR and they look at you like you have two heads, and anyway, it's just a thing. All right, so anyway, so we have our merge request. We can go in here and we can double check. We'll look at the changes, and we can see I made a couple of minor changes. If we go over here to pipelines, what we see is that there was a pipeline that finished. And I'm just going to open that in another tab here. And so what I have in this project is a CI pipeline that just does a simple YAML lint and then deploys the code. Nothing too crazy, but we do a quick check with YAML lint. What this is actually doing is on a box there is a thing called GitLab runner, and this GitLab runner is actually configured to use Docker. Fun fact though, the Docker on here is actually Podman running rootless, so that's totally a thing that you can do. One of these days I'm going to write up a whole blog post on how to do it. But if this is a thing that you're interested in, feel free to ping me directly, and I'll walk you through the process. Anyway, so what this does is this grabs the Python stock container from docker.io, and it runs a simple shell script in there that installs YAML, the YAML lint Python package, and then runs the YAML lint command against the repository. And anyway, that job's not too terribly interesting. I have another job that is a little more interesting, that actually deploys this Puppet code using a shell runner on my Puppet server that actually deploys the code and then runs Puppet generate types, which is a thing you got to do. Fun fact about this, this is actually in a whole separate repository. The one repository, when a change is made, actually triggers this other repository to actually do the deployment. This little setup is actually something that I started building at home and realized that it was going to be helpful for a customer, and we knocked it around a little bit, got it into shape, and got it deployed at a customer site that has Puppet deployed like globally, has compile masters all over the place. So it's kind of cool, and anyway, it's fun. I could go on about that for a while too, but I'm not going to right now. Anyway, all right. So going back to our merge request, everything looks good. So I'm going to approve that, which it was completely optional because it's my thing, but that's the way you normally do this. Normally you'd set approval rules. So, like one or two people on your team, or maybe certain specific people, would have to approve a merge request, and then somebody has to actually hit the button to merge the thing, right? So we hit the button, we merge it, and what you'll see is another pipeline starts to run. So we've so this pipeline here is basically going to do the same thing that the other one did, except that it's going to deploy instead of the issue 3 environment, it's going to actually deploy the production environment in this case. So and you can see as it does things, it just kind of shows up here. Also, if we go back to the issue, one of the things that, because I had the comment fixes number 3 in here, the reason I wanted to try to find that was because that little comment then told it that when this merge request is merged, go ahead and go close the associated issue. So if we look at that issue shows up closed. I didn't actually touch that ticket, right? So anyway, now I'm going to back up just a second. I've been comparing this a little bit to GitHub up to this point, and a lot of the features of GitLab were obviously inspired by GitHub. Like I said, the wikis, the pull requests, a lot of this stuff. But then there's a lot of the features that are actually probably more inspired by some of the other potential competitors like Jira, Confluence, things like that, right? One of the cool things here is that unlike the Atlassian stack, where if you want all of this functionality, you have to install Bitbucket, and you have to install Confluence, and you have to install Jira, and then you probably need something like Artifactory for your builds and whatever. That stuff is all built into GitLab, and in fact, like I said, there's some version of it in the Community Edition, right? So lots and lots and lots of functionality. Actually, since I mentioned it, if we go over here to packages and registries, there is a package registry built in. You can drop in, forget what it is, like Maven and NPM, I think, out of the box. I don't remember exactly. There's a link to tell you about it. And then there's a container registry, I believe. Maybe. Let's see here, infrastructure registry. Oh yeah, there's a Terraform. There's some Terraform integration that you can do here. Actually, speaking of integrations, there's integration that you can do with Kubernetes. You can actually use GitLab directly for GitOps. You can also the runners, where I was saying I had systems that had Podman running on them that using the Docker runner. You can actually replace all of that with just a hook into Kubernetes, because Kubernetes is basically just spinning up containers, right? So why not just spin those up in a container? I am guessing that part of the reason here is, yeah, we can see the Kubernetes. So you can, like I say, you can hook this straight in. Lots and lots of stuff. What did I do? Let me go back to my ticket to remind myself what I was going to talk about. All right, so we've talked a little bit about issues, and I didn't mention there is support for epics, milestones. Oh, boards. That's what I didn't do. So yeah, so if we go back here, go back to this Puppet control repo. If we go into issue boards, I mentioned the comparison to Jira. So you can have issue boards. Now this board's just got open and closed, right? But you can also add other things. So what I was supposed to have done, and I forgot, was actually move this ticket from open to in progress while I was working on it. Show you, it just drops a label on it. So you can, any label that's available, you can make a column for it, right? So so we can have our our open in progress, on hold, closed. I think I had one for pending review. Yeah. We don't care about on hold. So you can do the issue board, and so if I wanted to work on this next, I could drag that over there. If I wanted to just ignore this one for now, I could drop that into on hold. And then, like say, the closed column is tickets that are no longer open. So that happened automatically when I merged that ticket. So the issue boards are pretty cool. This is one place where I will tell you though that this is definitely a difference between the Community Edition and the Enterprise Edition. I've gotten kind of spoiled because at work we use the Enterprise Edition, and we set up boards for all kinds of things, right? So different things we're trying to track and whatever else. In the Community Edition, you appear to get a board, one, called Development. I think you can rename it, but that's about all you can do to it. So you can change the columns in it and stuff, but you can't have multiple boards, even though they have a thing to switch the boards, and there's no other boards there. Oh, actually, create new board. Wait, that's new. I'm sitting here talking, not even looking at the screen. This actually must have been something new in the most recent, the update that I just installed that's causing me other problems. So yeah, so what happens with the way GitLab works is they introduce features in their Enterprise Edition and on GitLab.com, and eventually they trickle those down into the Community Edition most of the time. They've got some rules about when they'll do it, how long they'll hold on to stuff in the Enterprise Edition. So this must be a thing that got filtered down into the Community Edition on the last update, which, by the way, they drop on the 22nd of every month and have reliably now for 6 or 7 years. Like every month on the 22nd of every single month, they drop a new release. So, and there's new features always. So, look at that. I can do new boards now. Neat. I could not do that the last time I ran through this. That's fun. Okay, so let's see here. All right, we've talked about that. We talked a little bit about merge requests. I gave you a little demo of CI pipelines and jobs. I mentioned the container and package registries. So talk a little bit about some other features. Actually, let's back up before I go there. I mentioned the pipelines, but I didn't explain how that works. So the way they do this, if you're used to like using Travis or something like that, I know with Travis CI, like you'll drop a .travis.yml in the root of your project, and that's where it gets all of its configuration. So GitLab kind of works like that. There's a .gitlab ci.yaml in the top level of your project, and this defines your pipelines. So in my case, I've got a test stage and a deploy stage. Showed that to you when I was showing you the pipelines. And this is the entirety of the definition for the job that runs YAML-int. And then my deployment jobs, there's a couple of variations on it. So I have a couple of different blocks down here that do different things. But this is how you define your jobs, and you can use these jobs to do builds. You can kick off all kinds of actions, just anything that makes sense, right? So I've used this obviously for Puppet deployments. That's fun. But at work we use it to build packages, like RPMs and things like that. We use it for building static websites. Because we're using a static site generator, so it'll build the website and then deploy it. Just all kinds of things. So just it's basically with the Docker runners and the shell runners, you're basically just running shell scripts. You can do custom runners that will let you basically do whatever you want to do. And not to mention the fact that GitLab also supports doing things like webhooks, right? So if you want to do things that way, so if you want, whenever there's a commit, you want to have it trigger a webhook somewhere, you can definitely do that too. The webhook thing just isn't quite as easy to configure and flexible as just being able to run shell scripts, you know. So one of the other cool features that they added in the last couple of years is the ability to run code scanners against like static analysis tools against your code base. And the way that you run those things, basically if you don't have a CI configuration, GitLab tries to guess what makes sense, like which things it should scan, and you know what kind of checks it should run. If you do have one, all you have to do to enable the static code analysis tools is a one-line include at the top of your .gitlab ci.yaml. Just tell it to include the code scanners. So that's pretty cool. They've got some, again, additional features in the Enterprise Edition that give you a little more visibility into all that, but those tools are available with the Community Edition as well. Okay, so I mentioned Kubernetes integration. The version of GitLab that I'm running here is what they call their omnibus install, right? So it includes everything. You basically install one massive package and it sets up everything. So most of GitLab is written in Ruby. So it includes, you know, a vendored Ruby. It includes all the Ruby gems. It includes all of the code for GitLab itself, and all the supporting tools and everything else. It's all in one big package. They've also got some things that aren't actually related to GitLab, but are handy to have alongside of GitLab. One of them is Mattermost. If any of you are familiar with Slack, basically Mattermost is an open source alternative to it. It's actually quite nice, and it's a one-line config change to enable Mattermost when you install GitLab from the Omnibus Edition. So that's kind of cool. I actually have intentions of setting that up for some of my users group stuff. I want to get some of, right now, running on old servers, and basically I'm the only one that has access to anything, which is not really a great way to want to run a Linux users group. So my intention is to set this up and get where the website's managed, you know, all in GitLab. Everybody in the group that wants to be involved can be involved in, you know, in GitLab, and then we'll use Mattermost for, you know, talking amongst ourselves, and also then, like, you know, sending notifications whenever there's been a change or something like that, right? So cool stuff like that. I think I've mentioned Community Edition versus Enterprise Edition. Like I say, the Enterprise Edition is quite nice, and honestly, if you're a business that relies on this kind of thing, I say toss them a few bucks and you know, go for it. And that just personal opinion. You know, they've got some plans that are fairly inexpensive. But the feature list that you get really is only makes sense in a little bit larger team environment. You know, there's some stuff you can do with scoped labels. There's like, say, the issue board thing was one of them that I was going to say, but that's not a thing anymore. There's random other tools that are just kind of nice. As you can see, though, the Community Edition is completely usable and quite nice. And if you really don't want to mess with all this, but if you like what you see here, but you don't want to mess with having to build your own servers and set this up on your own systems and whatnot, you can just use GitLab.com. GitLab.com has it's running the exact same code. They make a big thing out of that. They upgrade it on the same schedule as they drop new releases. It's basically running the Enterprise Edition. One of the things that GitLab did early on was they would let people do unlimited private repositories. GitHub, if you guys are familiar with it, until fairly recently, you could only do public repositories, right? So it was really for free, or if you wanted to use the free version, basically all your stuff had to be public. If you wanted to pay them for it, then you could have private repositories. GitLab has had the ability to do private repositories since as long as I've been using it anyway, on GitLab.com. Eventually GitHub did change things and they've added that. Actually, I apologize, I had a thought earlier and got off track. I was gonna say GitHub has actually added a number of things that kind of look a lot like GitLab. They've added issue boards, they've added the GitHub Actions that let you run CI jobs and things like that. And absolutely don't get me wrong, I am not here to bash GitHub in any way, shape, manner, or form. I'm a happy GitHub user as well for various open source things. And if you're a happy GitHub user, don't let me talk you out of it. But I actually do think that they've been playing catch up with GitLab on a few features. Personal opinion, I'm not involved with either company, not representing either company. But yeah, so I think that was the last thing that I wanted to talk about. So let's go back over here. And are there any questions? I am completely blind, so you might have to, I see a hand over here.
So I thought it was pretty clever the way it closed the ticket automatically when you wrote fixed number 3.
Yeah.
Is that like a static statement that it looks for?
Yeah, there's a page on their in their help that actually goes through all the different variations that you can use. You can say implements or closes or fixes. You can say fixes, close, closes. There's a big long list of different variations you can use. You can also say it relates to, so it won't actually close it, but in the ticket you'll see a link to the other to the merge request. So that when you're looking at the ticket that, oh, this merge request was related to this thing, but didn't completely implement the thing, right? Funny thing, actually, all of that stuff works on GitHub too, with exactly the same syntax as near as I can tell, because I keep catching myself. I'll do the things on GitHub and realize that I was doing the thing that I had trained myself to do in GitLab, and turns out it works. And actually, anytime you say like number, like in that case I did number 3, it knew number 3 was issue number 3, right? You can actually reference like merge requests by putting an exclamation mark in front of a number and various other things. And as you're typing it, if you start typing one of those, it'll give you a list of things. So you can actually pick the thing. You don't necessarily have to know the number. Unfortunately, I kind of sort of needed to know the number a little bit here because I've got so few tickets, and I think it doesn't start expanding until you hit the first character, if I remember right. So anyway, but yeah, so there's actually, since I mentioned the help, let's go back over here. So there is a help system, built in, and this is the thing. This is the reason I updated, because I didn't want that coming up orange saying that there was an update available. But anyway, in every install of GitLab, you end up with a bunch of documentation, including, I think, that page on Git. I think that's actually right here. They've got Git basics, yeah. So yeah, I think this is no, that's not the same page. Anyway, they've got some of the same, they've got all the same documentation. That stuff's all available on the internet, but you can also just get it in your local GitLab install. I know this kind of stuff is kind of cool, because if you happen to work in a very network restricted, internet restricted environment, you can install GitLab and you get full functionality all totally offline, and it's pretty cool. But any other questions?
Well, I got one more for you, though.
Yeah, go for it.
Okay, the ticketing system, is that the only ticketing system you use, or do you have other tools that you use to track work?
For work, it's the only thing we use. We've got various projects that we do that are out on, like they actually live on GitHub, and so we'll use GitHub issues for things, and we've used Jira for some things for, again, projects that host their issues in Jira. But for our work internally, we use GitLab's issues entirely. And I don't know, maybe my coworkers have some have thoughts about that, but it seems like it's very functional. I'm getting thumbs up over here from the guys that care.
For me, I wasn't sure how fully functional it was, or if it was just sort of a bolt-on, hey, we have a ticketing system.
It's quite nice. I mean, it's simple. You can't do, and there's a ton of stuff that you can do with Jira, just a ton of stuff. Unfortunately, my experience with Jira is that most of the time people do that stuff, they make it too complicated to make it, for it to be usable, right? So I think in a lot of ways the ticketing system is the issue system is just is the right level of complexity, if that makes any sense. Yeah. Oh, I suppose we were supposed to use a mic because I guess people watching online can't hear what we're saying. Whoops.
Can you hear me?
Yeah.
So what's the workflow look like when users send you a patch or merge request and it's not right and they need to rework it?
You can just put. Actually, that's great. That is a great question. So let's go.
In a follow-up, I don't want to do. I want to rebase my merges. I don't want merge commits.
Yeah. No, actually, that fun fact. I'm totally with you on that. In the settings for an individual project, is that under here or repository settings? It's under. So right here in the merge request settings, you can say whether you want merge commits with a semi-linear history, or fast forward merges only. And so I say fast forward merges only, and yeah. And actually, usually what I'll do is I'll set this thing so automatically resolve merge diff discussions when become outdated. And I usually encourage the checkbox to squash commits. You can change it. So if you don't want to squash commits, you can change it. But in the merge request, it'll default to the checkbox that says to squash. And then we can also say pipelines must succeed and all discussions must be resolved, and save our changes. So now when we create a new merge request, the defaults will be changed. But yeah, in a merge request, oh, that's fun. It created the thing that I didn't actually, oh well, anyway. You can, let's go back to merge requests here and look at closed. Okay, am I in the wrong place? All. Yes, I went merged. Okay, so we go in here and we look at changes. And so when you're reviewing, you can just go in here to the diff and you can add a comment, right? So I can just go in here and I can say, you know, hey, you need to do blah, 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 or, you know, I would do it this way, or whatever. And then you can, once you've said whatever, you can either just add the comment or you can start a review. And so you can actually like go through and add all of your comments and then hit submit review. And so it'll kind of show up as one thing when you're looking at the overview, but then it shows all of your individual comments in line in, you know, when you look at the diff view. So it's kind of cool. I could just delete that. But yeah, so that's what the general workflow looks like there. Does that answer your question? No?
What does the user do to make those changes, though?
Oh, they just push a new commit to their branch. They.
Do you have to force it, or they create a different branch?
Well, it depends. I mean, they can either force, if they want to like do a new commit, squash it, force push, they can do that on a branch. You can have branch protections set up so that, you know, people can't force push to like the production branch or, you know, main or master or whatever. But then they can push to, you know, their branch, you know, or you know, all they want, right? So they can either force push or they can just add another commit because it'll all get squashed when the merge request is done.
Oh, okay.
Right? So anyway, any more questions? I'm running out of time, but I got like 5 more minutes. Anybody? Yes, sir.
But you might want to mention
that is a really good point. A little trick you guys might not know is when you create a commit message, the first line of the commit message actually gets used as the title of your merge request. And then, so what you usually want to do is you want to do a one-line short description with a couple of line feeds after it, and then a block of text that it has whatever other information you want to add to it, right? And that becomes the body of your merge request. So let's see, if we go new merge request, I can't just create one at random. I got to have changes. Anyway, I won't worry about that right now. But yeah, so first line is your title, and then the rest of it is the body of, the description of the merge request. And by the way, all of that renders as Markdown. So you can put Markdown tags in your commit messages, and those will, so if you put links in there, the links will work. You can, in your commit message, you can put that, fixes number 3 thing, and that'll just show up in the description. All that stuff just works. So it's Markdown pretty much everywhere. Actually, that's another cool thing that GitHub started doing that GitLab has followed along. Like any place that's a text box pretty much handles Markdown. And if you're as big a fan of Markdown as I am, then you should love that. All right. Any other questions? If not, if you want to get a hold of me, the QR code on the right is my LinkedIn profile. Feel free to send me a connection request. And the link on the left is a link to Secura's website. Again, we have a table right out here. We do compliance automation. And and actually I would be remiss if I didn't mention that my coworker pointed out that I should say that this entire demo is actually, that I have also pushed into GitLab, is actually all code, every last bit of it that stands up everything. I basically just do a vagrant up, and this entire GitLab instance, including everything that's in it, gets created. I did add one other little task I have to run, so I have to run one other command line in order to create all the issues and the labels and everything else, because I also wanted to be able to use this kind of generically. So theoretically, and if this all sounds interesting, come to my talk tomorrow, because I'm actually going to talk about how I built this. So that's actually that's going to be a thing. It'll be fun, or at least for me. All right. If there's nothing else, I guess I'm done.
We're at 10 minutes ahead. So. That's fine. If you want me. Our next talk starts in about 10 minutes. Everything I learned about team building, I learned from The Last Dance, and it's by John Kimball. So, got about 10 minutes. All right. Our next speaker is John Kimball. He's served in various IT functions, Unix admin, web systems engineer, web architect, integration engineer, and this is his 7th Ohio Linux Fest and his 2nd time as speaker. Thanks for joining us, John.
Thank you. Thanks, everybody. All right, we've got my slides up. Everything I learned about team building, I learned from The Last Dance is my presentation. You can reach me at jmkimball42@gmail.com. There are other links. I'm on Twitter and LinkedIn. Those links will be provided at the end of my presentation. If you'd like these slides, please contact me. I'll gladly provide them for you. My lawyer said I had to do the following. This is a disclaimer. The thoughts and opinions expressed during this presentation are mine and mine alone. They in no way reflect thoughts and opinions of my employer, family members, or anyone else. This presentation is intended for educational purposes only and do not replace independent professional judgment. Statements of facts and opinions expressed are those of the presenter individually and unless expressly stated to the contrary are not the opinion or position of my employer or anyone else. With that out of the way, let's get to the presentation. Who the heck am I? I'm a proud graduate of the State University of New York, College at Oswego, class of '87, so yes, I'm really old. Al Roker is a graduate. Steve Levy is a graduate. He is the lead Monday Night Football announcer. And seriously, in the field of IT, it's Doug Lee. Doug Lee is a computer science professor, and he taught a few CS classes that I attended. He is best known for the field of concurrent programming and has written 2 concurrent programming in Java books. I've been in IT now for 32 years. My first 10 years in IT were spent as a Unix sysadmin. I worked with a lot of commercial Unix operating systems that I listed, Microport, SCO, worked my way up to SunOS, then it became Solaris, AIX, and IRIX, but I do love Linux, and after all those commercial Unix operating systems, I worked extensively on Linux and love Linux. The middle 20 years of my career have been spent as a web systems administrator, engineer, and architect. Got into the web field, which I absolutely loved, but after 20 years, kind of got sick of it. The last 2, I've been specializing in implementing DevOps principles in the areas of integration and security. Currently, I am at a American major grocery chain for the last 19 years and since 2002. So why was The Last Dance your inspiration? The Last Dance is the greatest 10-hour sports documentary ever made chronicling Michael Jordan's years with the Chicago Bulls of the NBA, the National Basketball Association, Pro Basketball. It is currently available on Netflix. I say it's the greatest 10-hour sports documentary. It is probably the only 10-hour documentary concerning sports. The documentary is about a team that won the NBA championship 6 times in the 11 years Michael Jordan actively played on the team. This is astonishing and outstanding, and has rarely been matched in the annals of sports. Given this, I found a lot of insights as to how teams are formed and flourished over a decade and can prove beneficial to fields outside of pro basketball, such as IT. Also, there are many life and work lessons that can be learned from this documentary, and I'll go over the ones I learned. So the NBA and IT, not as different as you think. So I go over some similarities. Both fields feature young, fresh out of college talent. The young talent is either nurtured to become a valuable professional within the organization that drafted, hired him or her, or it leaves their first team or company for another team or company in another city, or sometimes in pro basketball and even in IT, another part of the world. An average NBA team has 12 members. An average IT team has 8 members. Now, the 8-member figure I got from the Amazon doctrine that says that it's a 2-pizza. A team should be composed of enough people to finish 2 pizzas, so that's usually 6 to 8 members. An average NBA and IT team features members that differ considerably in age and experience, so that's definitely true. And both fields usually have a single supervisor or coach, and assistant supervisors or coaches in the NBA. They're called coaches. Both fields want team members heavily committed to the business. So, let me get to the next slide. So how is this presentation going to go? I'll be presenting team building lessons I learned from The Last Dance and compared them to an IT setting. The purpose is to identify characteristics of a good or a bad team and to see how this may apply to your companies and or work environments. So, when is it time to realize your team isn't good and needs to change? Well, in The Last Dance, Michael Jordan was drafted by a team that wasn't very good. And this is normal in the NBA and in sports, just really quickly. The worst teams get the first selection in the college draft. Those are usually the next great players. And the best teams usually get the last picks to try and promote what they call parity, where the bad teams eventually become good and breeds competition. So basketball is not the only sport that does this. Baseball and football, pro, are examples. Not only were the Chicago Bulls not that good, but it appears that some of them were drug addicts, and I'm not going to go into that. During the Netflix documentary, they touch upon that in the first episode. In the NBA, the easiest metric to measure how good a team is how many wins did they get. Well, in Michael Jordan's rookie year, the Bulls only won 38 games. They play 82, so they won less than half. But by Michael Jordan's 4th year, the Bulls won 50 and lost 32. There was only one other player that was still with the Bulls from Michael Jordan's rookie year, and they were also on their 3rd new coach and or supervisor. I have some notes concerning that. So sometimes change is good. So quick explanation, like who was responsible for the changes between Michael Jordan's rookie year and the 4th year? Much like businesses, teams in the NBA have a general manager, and the general manager is a position that's usually below the owner and above the coach, and he is responsible basically for making the team. He orchestrates all the trades and the draft picks to create the team. He also has a say, along with the manager, as to who coaches the team. I'll be talking about Jerry Krause throughout this talk later, as he, of course, played a pivotal role in the making of this team. So in IT, when is it time to realize your team isn't good and needs to change? Well, if you have team members who are resistant to change and are set in their ways and love the way things are currently, which is bad in some instances, that might be a telltale sign that you need to change your team members and the makeup of your team and maybe your culture. Some metrics that can be used to measure the value of your team include, I listed a few examples: support ticket reduction, reduction in security vulnerabilities, the number of projects completed successfully on time, lead time and SLAs, to name a few. If these numbers aren't improving or getting worse, it's probably time for a change. One other metric that's gained some popularity lately has been the quality of products that your IT organization creates, and also are you able to achieve key results, also known as OKR. In the top companies, your IT team has to be continually measured for effectiveness. Amazon, Google, and other examples I state later are really good at that. So I do realize that in the field of IT, you really can't just one day, I'm going to fire everybody and start fresh. You kind of can do that in sports with trades and acquisitions. So there is a little bit of a difference, but granted, I mean, there are times through such methods as transformation and voluntary retirement options and other methods management has used to change the makeup of the team and to make it a culture shift. Netflix is a good example. And from 98 to 2012, they changed and expanded their team drastically during this era. And by the end of it, their stock price had tripled. They had a customer base of 29 million. And Netflix in their culture statement stated, "We're a team, we're not a family." And the Bulls and Netflix were after the same thing, excellence. The power of effective drafting. So back to the NBA example, Jerry Krause, as I mentioned earlier, is the Bulls general manager. He did a very good job of recruiting and obtaining top-notch talented players for the Chicago Bulls following Michael Jordan's rookie year. This is, of course, laid out in the documentary. A few examples I cite, Scottie Pippen, one of the 50 greatest players in the NBA and a member of the Pro Basketball Hall of Fame. He was on all 6 of the Bulls championship teams with Michael Jordan. Horace Grant was drafted by Jerry Krause one year. He was a very good player. He's a keystone player, played on 3, half of the Bulls championships teams. And Tony Kukoc, an example of thinking outside of the box. Jerry Krause drafted him and he had never played in America. He was a European star, and Kukoc turned into a dependable, solid player who played on 3 of the Bulls championships teams. So in IT, what is the power of effective recruiting? So many companies throughout the last decade have been truly great at recruiting IT talent. Some examples include Amazon, Google, Microsoft, Apple, and Salesforce. One common thread with all of these companies is they conduct rigorous interviews and have high qualifications set in place for all their applicants. I know for a fact that Google used to have this test that was like a Mensa test. I mean, you had to have graduated Stanford with honors to try and pass it. They have since done away with that, but one of their early recruiting techniques was to have a test. And, you know, we've all heard of these companies before. These companies are arguably some of the best companies in America and some of the best to work for and are pretty much captains of the IT and tech fields. They truly value their associates / players. One thing to note is if you had bought some stock in all of those companies around 2010 and you're still held on to them, you'd be quite rich. And I'm available for stock tips following the presentation if you'd like. So I put this up. Nice guys sometimes finish last with a question mark. And throughout the documentary, you get this sense, Michael Jordan, not so nice. Phil Jackson, the coach, nice. if you had a choice, who would you rather be? There's really no right answer. I mean, they were both very effective, and I'll go into this later in my slides. Sometimes your most valuable players on a team aren't nice, but I'd still want them because Michael Jordan was phenomenal. He led the league in scoring almost every year. He was instrumental in all those championships. So how's that similarity in the IT field? Steve Jobs, I'd say, not so nice. Bill Gates, I'd say was nice. If you had a choice, who would you be? There's really no right answer. I mean, Steve Jobs is arguably the greatest entrepreneur and, in the IT field, yet Bill Gates is the second richest person in the world. One chose innovation and the other chose money a lot of times. The source I got for this is from a 1990, how I came up with the assertion that Steve Jobs wasn't nice and Bill Gates wasn't nice. There's a really good, somewhat obscure made-for-TV movie in 1999 called The Pirates of Silicon Valley. Quote it right? Pirates of Silicon Valley, based on the book Fire in the Valley. You get the sense that Jobs was a tyrant, kind of like Michael Jordan, and he hated IBM. You also got the sense that Gates was really laid back, wanted to make a lot of money, and he had no problems working with IBM. Passion and devotion are good. So in the field of basketball and in the documentary, it would be hard to exceed the amount of passion, devotion, and commitment to excellence that Michael Jordan had in his years with the Bulls. It was all these traits that led to excellence. Basically, he hated to lose, and it is very apparent in the documentary. He also made the players around him better with drive and determination. Some called Michael Jordan demanding and a tyrant, and they do so quite a bit in the documentary. But I'm like, okay, he really just wanted the best out of every player and to work as hard as he did. And he wanted the best out of you every day, including practice. Back to practice. Jordan in practice challenged a young player called Scott, his name was Scott Burrell, mercilessly, and that's in an episode of the documentary. But his motivation was that I'm going to need him in battle. And I have a quote from Burrell. Scott Burrell said Michael Jordan taught him, he wants to win. Nothing is easy. Nothing is given to you. So how's that apply in the IT field? Passion and devotion, I think in the IT field are good. You really want to have associates who have passion, devotion, and a commitment to excellence. Devotion is seen in employees who have a thirst for curiosity and who are continuously learning. Positive passion is good. The desire to fulfill your role to the best of your abilities. Examples of passionate leaders include Jeff Bezos and Bill Gates. So I just wanted to state, I wrote some notes here. Passion is sometimes seen as a negative in the workplace, but I don't think it truly is. Some people have been called a-holes for being passionate, but a lot of times they're just like Michael Jordan in this documentary. Sometimes demanding bosses just want the best out of you. Bezos has a passion for exploring new opportunities. This is why Amazon evolved from the biggest bookstore to the biggest store in the world. You sometimes need a calm force to manage the team. So Phil Jackson was the coach / manager of the Chicago Bulls. He was able to manage all these diverse personalities with relative calm. To him, it was all about breathing, centering, and focus. According to Wikipedia, he has a holistic approach to coaching that was influenced by Eastern philosophy. And I have an example of some of his I have an example of this. It's called the Dennis Rodman story. And it also is, you can get from this story the difference between Phil nice and Michael Jordan not so nice. So Dennis Rodman was a player on the Chicago Bulls, and one day he stated that he needed a break in the middle of the season. And he expressed this to the coach, Phil Jackson. Phil granted this. Go take a break during the middle of the season, which is almost unheard of, but again, he's a calm force. Dennis, however, decided his break was to party in Las Vegas. And after nearly a week of being gone, Michael Jordan asked Phil, "Where the heck is Rodman? And when is he coming back?" Phil stated that he's in Vegas and will come back when he's ready. Jordan stated, "He's had enough time off, I'm getting him." So Michael Jordan flew to Vegas and dragged Rodman back to Chicago to play basketball. It's also been said that Phil Jackson connected to his players on a deep personal level, and that was the way he got the best out of him. So how's this apply to IT? I think sometimes you need a calm force to manage your team in IT. Throughout my career, I've found the best managers are calm under pressure, especially during outage bridges. Have you? I tend to not be very calm during the outage bridges. I'm really focused on trying to get the service back up, while a lot of senior managers and members in management are a lot more calmer and are able to work under pressure a lot better than I. An example of someone who works under, is relatively calm and a very successful member in the IT community is Sundar Pichai, who's the CEO of Alphabet. He's been described as a calming force who avoids confrontation while embracing cooperation. He's also been noted for bringing the best out of others, much like Phil Jackson. Healthy conflict is good. So I will describe one time Michael Jordan got in a fight with one of his teammates, Steve Kerr. I have some details here. So one day Michael Jordan and Steve Kerr got in a fight during practice. Michael Jordan took umbrage that Steve Kerr seemed to be taking practices lightly a year after losing in the playoffs to the Orlando Magic the year prior. Jordan was frustrated that day at Phil Jackson, the coach, calling Jordan for fouls. It eventually escalated in a fight that got Jordan thrown out of practice. Jordan immediately apologized to Kerr, and Kerr called it the best thing I ever did was to stand up for myself with him. So what does that tell us, and what was the outcome of this fight? They both came out with a tremendous amount of respect for one another. They came away with a lot of trust in one another since then. They went on to win. They went on to go to a 72-10 record, which at the time was the best ever. They won the championship that year. And Steve Kerr ended up being a phenomenal coach, leader himself. After his playing days, he coached the Golden State Warriors to 3 NBA championships. So how is healthy conflict is good in the IT field? At Amazon, healthy conflict is a way of life, they said. In a Forbes article, it was stated that at Amazon, there's an incredible amount of challenging the other person. And in a Business New Daily article, it states, a healthy amount of workplace conflict can be valuable to the growth of an organization. Debates, competition, and industry disruption are all examples of conflict that can lead to fresh perspectives and growth for a business. Myself, I worked in an environment long time ago where you would get a bonus if you were on a project that completed on time and under budget. This created a situation where project managers would assemble teams of the best engineers or developers, knowing that they would likely obtain a bonus check because their team was so talented and could deliver. It created really good, healthy competitiveness, and it was quite good working there. So in conclusion, as you can see, there's a lot you can learn from The Last Dance. Some examples are healthy conflict is good. You sometimes need a calm force to manage a team. Passion and devotion are good. When is it time to realize your team isn't good and to change? The power of effective recruiting or drafting. And nice guys sometimes finish last. It was all these characteristics that produced a team that won 6 championships. The Last Dance is a truly incredible documentary, and you don't have to be a sports figure to enjoy it, and I highly recommend it. Email me if you want slides and guides to clips in The Last Dance I reference in this presentation. Due to copyright concerns, I did not show clips, but I can, if you email me, I'll tell you like what episode and where is the Steve Kerr Michael Jordan fight, or when is the Dennis Rodman affair, and stuff like that. References, couldn't have done this without them. I'll briefly explain these. Oh, the first one is a Netflix, the Netflix HR culture slide deck. I found a lot of good information concerning that, especially how Netflix's culture works and their approach to HR. It's a little dated, but it's very applicable. The second reference is how Netflix reinvented HR, another reference. That was from the Harvard Business Review. Professional development companies hiring talent, how 6 companies hire talent, like Salesforce and Amazon. Just Wikipedia, I love Wikipedia, everything's on Wikipedia. This link I'm pointing to now was Jerry Krause's draft picks, some more information concerning that. He was the general manager of the Chicago Bulls. And 12 Amazon Technologies of Jeff Bezos. Healthy workplace conflict, why it's actually a good thing. And of course, Netflix. The documentary is currently on Netflix. If anyone has any questions, please step up to the mic. If not, this is my contact information. You can give me an email at jmkimball42@gmail.com. I'm on Twitter as jmkimball42, and I'm also on LinkedIn as jmkimball. Thank you. My one and only animation.
Oh, take my mask off? Okay. All right. Good afternoon. Our next speaker is Chris Volney. 10 years developing in the information security, web applications, and connected system spaces, the author of RESTron, a Django REST WebAuthn module. Author of @cvolney, she lists the URL here, NPM WebAuthn REST client this year. She left the embedded DoD system space and joined Duo Security, a Cisco subsidiary, as a developer on the cloud SSO platform. Prior to this, she worked in secure containerization of DoD systems, mobile device management, connected vehicle, back office web services, SSO web applications, and device health identifications for regional government MFA. Chris?
Hi. So about me, you heard the intro, 10 years in InfoSec. I started in 2005 at the University of Toledo. While I was out there, I went into regional government, writing custom MFA for terminal server, connection negotiation, data transformation, dependency detection, graphing. Went into grad school, later moved on to GM and then later OnStar within GM, working on connected vehicles. Then later changed gears, went over into the DoD space, working on embedded Android and Linux systems, and then all of the connector pieces to make that work together, mostly Yocto Linux. And then at the beginning of this year, I switched gears, moved over to back into cloud security, came over to Duo Security, which is a Cisco company, mostly async Python, JavaScript, and React. Actually, when I was applying for jobs is when I first learned about WebAuthn, or passwordless authentication. And at the time, I was taking a cybersecurity course in grad school, and I remember seeing this weird name on a job posting. And so I Googled it, and I went, OK, that seems pretty cool. And about 5 minutes into it, I said, you know what, I think I can write that. So this talk is based off of that work, cybersecurity course project, adapted into a broader discussion about passwordless authentication and then giving a demonstration. So our agenda today, why passwordless? A little bit about the history of authentication factors, passwords, and cryptography, really high-level stuff. Introduction of the FIDO standards and specifically the WebAuthn API. I'm going to give a demonstration of how these systems look to your end users, and then also how us as system developers get to build these systems out. We're going to discuss a little bit about system design considerations when you're building passwordless systems with WebAuthn. We're going to have some time for Q&A at the end. OK, so why passwordless? The big statistic everyone loves to talk about is the Verizon DBIR. 80% of breaches involve brute forcing or lost or stolen or poor quality passwords. That's pretty terrifying. So that's been a high number. It's actually gone down a little bit. Last year it was 81%. So good job, team. Why does this matter to me? Well, I really like this slide. I pulled it from somebody else's deck. I fight for the user, but also I am a user. I really like convenient. I really like secure. And so should you. So a little bit of history on passwords, because we have this addiction to them. And so why? It's an authentication factor, something you know. This dates back way to Roman legionnaires. Are you a friend or a foe? Do you know the password to get into the encampment? It's been the de facto computer security mechanism since the 60s. I think the first documented case I could find was the MIT timeshare system, which interestingly enough is also the first time that there was a leak for passwords. In '62, somebody grabbed the password file, and keep in mind this is all clear text. This is before we knew to do hashing. Grabbed the password file because they wanted to get more access time to do more research work. Later in '66, the message of the day and the password files were swapped. So that's open-ended security there, right? And we've also been asking this question of like why we're using passwords way back to 2009. Some researchers at Microsoft published this work. Passwords, if we're so smart, why do we still use them? Over on the side, just some like quick examples of ciphers. We have the Caesar cipher table. We have a transposition cipher. That's a route cipher. And then this is actually an 1899 State Department code book that's been since obviously declassified. Basically, for these phrases, use these numbers, so that's kind of neat. So discussing passwords, I really love to tell lay people, think of it as a time lock. This is really anything with security cryptography. It's a time lock. How long does it take for this information to get broken into? So when we think about passwords, we think about search space and online versus offline brute forcing timings for those, or attacks. I really like this tool, this haystack search. So even with what we would consider to be like a strong password, I mean, it's only 4 characters, it's very short. But upper, lower, alpha, like numeric and characters, that's an extremely fast offline cracking time. Also, I like to tell people, you can either have a random password or you can have a memorable password. And those are an exclusive relationship generally, so you gotta pick. And then you have to rinse and repeat that for every new service. That gets pretty exhausting. So what do we all do? We use password managers. This generates impossibly long passwords for everything, and you encrypt this payload of all of your honeypots of passwords with one very strong password with some big hopes attached to that. I hope you don't forget it, because if you do, you lost it, everything inside of it. I hope no one copies that password or listens when you enter it, and I hope that password was actually strong. It doesn't do us any benefit to generate 32-character passwords if hello world is my decryption key for the whole locker. Later, we see the entry of multi-factor authentication. This is effectively defense in depth. So we know passwords aren't working. Something you know is not sufficient. People are not picking strong enough things that they know. So we have to also add something that they have or that they are. So now if I need to log into a system when something's down, shoot, where's my phone? Where's my YubiKey? So there's these additional things that put load on the user, but do secure our systems. There's a few different variants of this. There's voice and SMS 2FA. There's one-time passcodes, push for unlock. I really like that. And then certificate or public key infrastructure. Maybe even backed by a secure enclave or TPM. So don't use voice or SMS. This is absolutely trivial to hijack or phish. Couple bucks, you can redirect anyone's SMS messages to you. So not a good solution. OTP codes, kind of the same thing. Phishing's a big problem for those. Usually some sort of exfiltration or software on phones nowadays that can extract these tables. I love push. We do that at Duo. I think it's great, especially when you have additional monitoring or other tools in place so that you see who's accepting the push and at what times. I like certificates and PKI, obviously. That's WebAuthn, and we'll get into how that works. And it's even better when it's backed by a secure enclave. By that, I mean a device, well, we'll get into it, I guess, on a later slide. Also, we have single sign-on as another option. This is what I do. This is my bread and butter professionally. And also, I'll talk a little bit at the end, how Duo specifically introduced passwordless and proliferated that into our systems. So single sign-on, we got 2 flavors available to us. We have social login, and we have other protocols like SAML or OIDC. Usually social login's backed by OIDC. Social login's the Wild West. I like to say, like, it's kind of Bruce Schneier's like data feudalism. You decide which organizations you want to trust with all of your internet access and history and records. So now if you use Facebook login, Facebook knows every website you ever log into and when. SAML and OIDC are generally only available to enterprise customers. It's really hard to write an identity provider, as we're working on right now. Over here, this is actually kind of neat. We've been building an OIDC identity provider for our Duo SSO platform, and we had a lot of interesting spin-up time as we're trying to figure out like which specs do we need to read. And I really like this diagram. It perfectly encapsulates everything we needed to learn in order to even ship just this protocol. So there's a ton of specifications for all of these. Okay, so back to security keys. We see these a lot in multi-factor. So what are they? They're a secure enclave. They're generally tamper and extraction resistant. So the idea being the information stored in your security keys should be really, really hard to extract out of it. And so, you know, there are certifications for these products, and each vendor is going to do it a different way. They're all based on, or generally based on, asymmetric cryptography, which we'll get into a little bit more. They can also embed, that's supposed to say resident key credentials, which we'll talk about is basically not just passwordless, but also usernameless authentication. Sometimes they're built in, your Touch ID on your MacBooks or on your iPhones, or your fingerprint and face unlock for your Androids. Sometimes they're peripheral, such as your YubiKeys, and sometimes they can be used to unlock even larger vaults. So you can imagine something like you Touch ID in to get a decryption key to unlock your hard drive. Pictured over on the side, we see like the Google Titan key, Touch ID on an iPhone, and then YubiKey launched their biometric key this year. That's kind of neat. A little bit about cryptography. Asymmetric versus symmetric. Symmetric is same key for encryption and decryption. So that's a shared secret between both ends. When we talk about the CIA triad, confidentiality, integrity, and availability, symmetric cryptography only guarantees us confidentiality. So you need to know the secret to read the information that's sent over the wire. This is oftentimes used for securing data at rest or during a transport session, the data that's being transmitted. Some examples are DES, Trip DES, AES, Blowfish. Asymmetric's newer and cooler, I think. That's one key for encryption and one key for decryption. Generally speaking, like RSA and a lot of these, you can use the public key to encrypt. It can only be decrypted by the corresponding private key and vice versa, so it's reversible. That gets us confidentiality and integrity. So I can guarantee that the person sending it, depending on how they sign it, I can guarantee that they are who they say they are by virtue of they're the only people that should have that private key. RSA was published in 1977. It's named after RSA. That's the abbreviation for the, I can't remember off the top of my head. What I found really interesting when researching this was Ellis and Cox actually developed it in '73. This is a couple of GCHQ mathematicians, wrote the underpinning of RSA crypto, but that was classified because that's too important to let get out. So that was later declassified. These are used to secure those transport negotiations, such as like over the web. So when you do your HTTPS exchanges, you're usually doing PKI to negotiate a transport key that's symmetric. RSA, Diffie-Hellman, elliptic curve are examples. We use this every day for SSH, PGP, and TLS. Okay, so that's the super high level of crypto. Let's talk about FIDO. So this started when PayPal and validity sensors started talking about we really want to strengthen online shopping. By the time 2012 rolled around, the FIDO Alliance was founded. They had recruited a bunch of other companies. 2014 was the big first product of this. The Samsung Galaxy S5 had fingerprint e-shopping, and that was huge for us. Next year, FIDO 1 was published. Later in 2015, Bluetooth and NFC support was added. By 2018, FIDO 2 gets published. That's the specs we're going to be talking about. And 2019, we see there's a really wide adoption of that standard. The philosophy behind the FIDO Alliance: strong crypto over passwords and OTPs, limited scope. So think about that in terms of your cookies are usually bound to a domain. You are generally defining only a key pair for a specific service provider. And then device attestation is which devices do I want to trust? So I can actually specify if I want to do platform specific or specific vendors. Let's talk a little bit about the spec adoption. So we see a lot of green on this board, and that's good. We love to see that. That means support. So a lot of these systems, this is from 2020, so they didn't actually include any Linux stuff on there, which, right, what, who is she? Comes to a Linux con who doesn't have that. But, we do have this with libfido2, so don't you worry. So wide browser support for the big ones and platforms. Okay, so FIDO2 standard. That encompasses CTAP and WebAuthn. CTAP is Client to Authenticator Protocol. This is your hardware OS API and transport mechanisms to the hardware, like between the hardware and OS. So these are system calls. Usually define transport mechanisms, is this a USB or NFC connection, low power Bluetooth, and then also like how to communicate with the TPM devices. Web Authentication API, WebAuthn for short, is just for web applications. So this extends all of CTAP into your browser environment. So now you've got this JavaScript API in your browser, and then a couple of server-side libraries to make that all go on the back end. So system calls, think Windows Hello or libfido2. Nope. OK. So when I say this is a JavaScript API in browsers, like, this is it. These 6 lines is basically it. So that's the talk, right? No. But anyway, so this is effectively what's going on there. We're going to dive a little bit into what these public key credential options, et cetera, are. High level, how this works for an end user is user is usually presented with some sort of that API call to create. User has to say, hey, I want to go ahead and do you want to create a security key for this service? User approves, usually does a fingerprint or enters a PIN or something. Key gets generated, and then information to register the key is sent up to the server. For login, it's very similar. The difference being you tell the server what your username is, and it tells you here's some information about what authenticators are registered for that user, and then also here's a code challenge. That code challenge is then taken. User is prompted, do you want to log into this service, verify your identity as we see over on the side. They say yes. They go ahead, fingerprint whatever your user settings are. We'll get into that later. And it signs that challenge information, sends it back up to the server where it can be verified against the public key that's been registered. OK, so I have a couple demos here. Caveat. One on the left, that's an Android recording. Anytime the screen goes blank, that's actually the OS prompting me for my fingerprint. It won't record that. It's kind of a neat feature of Android, I think. So here's an example on WebAuthn IO. This is from Duo Labs. You guys can go out and do this yourselves. Most of your smartphones have this, as we saw in that previous slide. Yeah, so here's my prompt. I fingerprinted. This is only registering it as a platform authenticator. So now I can log in, fingerprint prompt again, and boom. And we get to see exactly the sort of information that's stored on the back end. So this is really just public information and identifier fields. The library we're going to be talking about in a little bit is the one that I wrote. This is on my personal site. So this one's OS X Chrome. Log in. I get to pick your YubiKey. Yep. Our setup, I have to enter a PIN to use my YubiKey. That's an additional setting you can apply on the browser. That's a neat little shim for if you don't have a password authentication available or a fingerprint or biometric or something. There's a way to verify that the user is who they say they are before they're allowed to encrypt. OK, so high level of my demo, there's 2 pieces. JavaScript library, Django extension, and then a demo app to use the Django extension. But JS library is Axios with some CBOR interceptors. CBOR is short for concise binary object representation. Think JSON with encoding. That handles login and register functions. The Django module is a Django REST framework extension. This includes some CBOR renderers and parsers, some base 64 in there, as we'll see. Has a couple of models, authenticator and login token, some API views, and some very simple templates for testing. So let's talk about the Axios stuff. This is kind of neat. We define in our Axios client the CSRF token stuff that you would need to do for that support in Django. But additionally, we're registering these interceptors. That all those end up doing is check to see what your content type is on the request or response and decode or encode as needed, and you get back a JavaScript object. The login function is a big old wrapper for a generalized how to talk to WebAuthn function. But the super high level of calling this is you need a success callback, a failure callback, and your authentication payload. For a fully passwordless system, like my site, that's a username, my username. For a multi-factor setup, which you could also extend this to, that includes like password or OTP or whatever additional factors you want to include. Moving on. The registration looks very similar to this. That's why the generalized internal function is used for both of them. It's basically defining a slightly different callback to either get or create, and then how to translate the response that you get back. Okay, moving on. Also, please bear with me on a lot of these code samples. You guys can get the slide deck later. All this stuff's out on GitHub too. I just want to go super high level over it. On the Django side, we have two models. We have a login token. That's just a email reset kind of thing for initial registration. I need to be authenticated before I can register something, because you can't just take someone's word for it. I want their user IDs. The other model is our authenticator model. That's basically just storing a nickname for the authenticator device, the public key information, base64 encoded, and a big text column, incrementable integer for how many times this authenticator has been used. You can detect whether a device has been cloned that way. For REST and for the REST side of things, I also had to implement some CBOR encoders and renderers. I also put some base64 stuff in there so that you can use the demonstration API pages if you're in demo mode for your server. But all these libraries are out there. They exist. They're nice, easy to use. This is just all glue. So each phase of authentication or registration is 2 requests to the back end. So it's not just a collect username and password, send it off, and get back an OK or a not OK. For login to function, we need to get that code challenge, as well as the identifiers for what security keys are registered for the user. So there's a login begin, part of that ritual. In this particular case, we're just looking up the user, pulling back all their authenticators if the user exists, and then report that back out along with a challenge. There is a passwordless backend that makes this all go in Django. Basically, when you register a authenticator backend, you can apply extra quargs on there that will make sure that your backend is the one that picks up. And that either returns a user model or it doesn't. At first glance, this looks pretty terrible, right? It's, all right, give me your username. OK, great, there's your user. Don't trust that. We can see in this demo page over here, Django REST is really nice when you're in debug mode. You can just kind of use this neat web form. I think the ASMX stuff for Microsoft does something similar, but I like this better. But you can see base64 encoded, the challenge and the authenticator public keys coming back. So in this particular case, I'm trying to authenticate username Chris. And I can see that I have 2 public keys registered. We're going to talk a little bit about this, but that relationship between do I have public key or do I have authenticators registered or not is a bit of a username enumeration fault. So we'll talk more. Login complete. So now that I've got my code challenge, my user approves the authentication attempt. That's going to encrypt that challenge, send it back. So I give you the credential ID I used, the client data JSON, authenticator data, and signature. Signature is what's coming back out of the authenticator. And you get back a detail field that just says OK. And then your user information. So in this particular site, it's username, full name is staff. So let's talk some design considerations. So is this part of a, we really need to talk about the posture, security posture of your environment that you're deploying this to. Is this a system that's it's very important that people have multiple factors of authentication? You can include this as part of your multi-factor. If it's something that you're fairly confident that these security keys are biometrically enabled or something like that to make sure that there is that baked-in additional factor, you can use this for a completely passwordless system. So I think that's really important to just pay attention to what are your risks that you're taking on by adding this authentication infrastructure instead. Also, I mentioned before this resident key credential concept of username list. Basically baked into these systems, and I have a screenshot down here from Chrome, the authenticators can store the username information or details. And so you can actually tell the server, just use this ID for me. And then it'll usually keep a separate profile for you of name, email, all that stuff on the back end. But I don't even have to type in a username. That's pretty great. If you don't want to do that, some authenticators like the Google Titan don't support it. You can just set a cookie for username, generally speaking. That's usually a safe thing. So we also have some requirement parameters that we get to specify as system designers. I mentioned the discriminator on authenticator type. So you can specify I only want to support platform authenticators, or I only want to support YubiKeys. External authenticators we call cross-platform. Built-in we call platform. So think SE or TPM backed platform. Additionally, I can specify user verification. So you saw a PIN required in order to use my YubiKey. That is specified by the server to say that, no, just the fact that somebody clicked isn't enough. I also need to provide some additional things. So what are we doing here? We're pushing multi-factor off into the client in a way. And because of all of these systems of us saying, I only trust keys from these vendors, I only trust keys of these type or these built-in modules, we get to trust this whole chain. And as I mentioned, there's a biometric functionality for a lot of these things. And then also there's this attestation level. This is important because when you think about the certificates that are used to verify the authenticity of the vendor of the device so that I can trust that this is a YubiKey of this model and it supports these things, that's identifiable for the end user. So baked into the specification is this idea of we don't want this to be used to track you next. And I looked a little bit and I didn't see anything in the wild per se, mostly because WebAuthn adoption by server side is a little bit lower. But it's a design consideration of how much information us as system administrators need to know versus how much the user's allowing us to see about their devices. Oh, and I also really like this concept that Duo's going in with adaptive authentication. So you can kind of think about when we do multi-factor, paying attention to what are the conditions of an authentication event. Is this within the normal user behavior model that our system's trained against? Or is it something anomalous, authentication request from China? I should probably ask for more factors when the employee works in Ann Arbor. Oh yeah, wrong state to say that. All right, so some additional notes. I mentioned the username enumeration issue. This is a problem that you're going to see. Username enumeration doesn't necessarily matter unless we're talking about like email spam. When you're not being able to brute force an authentication, we trust that a 2048 bit encryption key is going to take until the end of the universe to crack for now. But when you think about these hybrid systems, as you sometimes see out there in the wild, where you can choose passwordless or you can choose multi-factor with a password, it's a design consideration that when you support passwordless, you also need to put additional security controls in to make sure that this system isn't used to look up, here are all the user IDs on the system. So just a thing to pay attention to. While we're on that note about good security practices, don't do what I did. Don't roll your own crypto or security. This was a term project. So it's out there, like feel free to use it, pick it up. It's a good example of how to use the FIDO2 libraries. But I don't know, I use it on my dumb website. Like, don't use it in the real world. But use passwordless. Just use it from somebody that's smarter than me that wrote it. Django views an API to React is, I'm a web dev, and this is still really awkward to me. So this is more of just a note about that as I integrated these systems together. And I just kind of included these little screen caps over here because I thought it was neat. There's a couple different ways you could do this. I really like the Django. You can just dump a JSON blob in the middle of your template that comes back, or you do API requests back and forth. But I still think there's a a better way that we can be doing this. I'm open for ideas if you have any. So with that, here are some resource links. So there's a WebAuthn 101. I really like that. That explains everything. The Duo demo that I showed you guys earlier from Android device, that's there at WebAuthn.io. FIDO Alliance, if you want to see, here's some identity provider libraries. Here's some certify providers. You can look those up there or more information about it. And then I have a couple of links here. This is my Django REST-Authn extension, and then also the React WebAuthn client libraries. Feel free, grab those, fork them, play around with them. So, questions? Oh, yeah, and if you have questions, please walk to the microphone and ask the question.
So on the topic of brute forcing usernames with that scheme, that's actually something I had written down as a question I asked before you even brought it up as a tip. I'm curious, you didn't actually mention how to prevent that. Obviously, there are things like CAPTCHAs, but that just means you have to pay people a penny for each username instead of preventing it altogether. So I'm curious what your recommendations are there.
Sure. That's a great question because as somebody that works in systems that use passwordless in a hybrid environment, trying to figure out how to protect us from that, I went and I looked at the spec and I said, okay, what do you specifically spell out here? And it says there's a username enumeration problem. You should pay attention to that. So there isn't actually baked into the spec or that a suggestion. I have sat around and thought a lot about the problem. Like, do I sample real user information and then send that back as a response for a known bad username? Like, because I can look up the user early on and say, is this going to be a successful auth path or not?
So like a red herring?
Yes, exactly. But so how much real information do I generate these things? Okay, so now as an attacker, I need to make 2 requests to make sure that it's actually the same keys that are coming back each time or something, because it can't be random per request. So I got some ideas floating around. That's definitely more in my research bucket for later. But I don't have a good one. I just have a couple of strategies. We can talk more after. But those are kind of the high-level things I would do, is either sample real-life data that is deterministically looked up, or to generate sufficient spoof data that is also deterministically looked up or generated. Because again, you can't just send back a junk response, because if the attacker just F5s and get a different response, it doesn't tell anything. It just doubles the amount of time it takes to enumerate. Good question though, thanks. Next.
So I may have misunderstood, but if you're going for a general audience and you have no idea what hardware they have, they probably don't have fingerprint readers or anything cool like that. Are you basically just expecting to fall back to a PIN? Do you have better options than that, or?
Oh, like in the auth example where I used a PIN to provide the additional factor for.
Right, or.
Yeah, that's so far, that is the browser solution to things. Okay. Is to either call out to the OS for whatever the screen unlock protocol is, which would be for most smart devices, face unlock or touch ID or something. Or to fall back to a PIN. But yes, that's going to vary from browser to browser on how they want to polyfill that functionality in for you.
Okay, thank you.
Thanks. Additional questions? All right. Thank you. If the code examples were not useful to you at all, at the very least, here are some cute pictures of my cats. But feel free to grab me after the talk if you have more questions. All right, thanks a whole bunch for your time, guys.
Thanks, Chris. We got about 26 minutes for our next talk, which will be automating a Linux Fest, and that'll be right here. So get some time. Ready? We're going to start right at 4.
I wanted to make sure my computer was still awake.
I hear you.
Yeah, probably people's gonna give me shit for using Windows. No,
I had to use it one time. I had All right, everybody. This is Zach Underwood. He's one of the core staff members of Southeast Linux Fest, and here he's going to talk about automating a Linux Fest.
So yeah, this is probably one of the more unique presentations probably will be given today. So about me, I'm a South Carolina native, born and raised my entire life there. Done 10 plus years in IT, everything from help desk, Linux sysadmin, unfortunately Lotus Notes administration way back in the day, Windows Active Directory, Exchange, and then also Linux sysadmin stuff. Right now I'm currently doing network administration, mainly on Wi-Fi, and I've gotten my Red Hat Certified Systems Administrator under version 6 and Certified Systems Administrator under 5, 6, and 7. Again, I work for a company that does wireless networking for mostly student housing, and we got about 60,000 APs under management right now. About self. This is the Southeast Linux Fest. Please God, do not confuse it with the other self, known as the Southeast Leather Fest, which takes place typically on the same weekend as we do in Atlanta, and it makes for some wonderful Twitter hash collisions between us and the Leather Fest. Our self started in 09 in Clemson, South Carolina, as an extension of our local Linux users group. It's like Upstate Carolina Linux Users Group is the name. And in 2019, we brought in about 800 attendees, which does make us on the larger side of the Linux Fest in the US. I started doing the networking for the event in 2014. Prior to that, it was a mostly volunteer group of the Slackware gentlemen would come together and do the networking the best that they could, but no one person was dedicated and took it on. And so in 2014, when I was with my employer at the time, I got them to sponsor me and the equipment to take over and do the event. We do 70 speaker sessions over 5 concurrent tracks, with 4 of the tracks being recorded and streamed live. And we do it all entirely automated. We have one person, primarily me, doing the managing the automation system, and then other than that, that's really all the volunteers that we need to do the system. The services that we offer, aka what needs to be automated. So there's some obvious ones on that list. So there is recording and live streaming the speaker sessions. That's actually how the automation platform got started. We were having issues with the slide or with the recordings being stopped and started at appropriate times, and the audio levels and the video levels being correct when they get recorded. And unfortunately, once they're wrong, there's no going back. So it was actually automating the video was the primary driver of the system. But once that got working fairly quickly, I decided to start adding additional services that we do for the event and the speakers.
So we have a little box that's got some LEDs in it that will flash appropriately to tell the speaker how they're doing on the time. So they'll give a 5-minute warning when the presentation's almost up. And it will also tell them, communicate with them when the videos are starting and stopping. I did forget to add, if you have any questions, go ahead and interrupt me. I'd rather talk about them during than save them all for the last. The next is we put cameras over, PoE style surveillance cameras over all the doors into the ballrooms. And using that, we count people coming in and out, and we can determine roughly how many people attended each session. So this can be, we can use this for future to determine whether the speaker drew in a good crowd, whether the topic drew in enough people, so we can help steer both the speaker and the content selection in the future based on popularity. The next is we have vote boxes. So if you've ever been to IKEA, and as they're leaving, they have a box right by the exit. It's like something to the effect of, how did we do? And there was a smiley face and a frowny face. And you hit it right as you leave, and that gives them an idea of how they did. So we're doing something similar. We got pictures of it, and those are, as people are leaving, how did you like the session? Was it great? Was it neutral, or did you hate it? And we don't ask, we don't have the interface to ask, was it the content? Was it the speaker? Did it smell? Or for whatever reason, how did you think of the presentation? We provide event-wide Wi-Fi that is open to everyone. We actually shut down the hotel's Wi-Fi system. And they actually help us with doing that. We have a good relationship with their maintenance staff, so that they don't interfere with our network. We do a LAN party. So in the LAN party, it is an excuse to get a bunch of people together and play games, whether it's Minecraft, Team Fortress 2, or something else. And all the games do run natively on Linux. The next is event-wide information displays. So if you notice in here, they have the monitors outside of each room that displays the information. We decided to hijack those and use those for our purpose in our hotel. And the next is monitoring. This would be your more standard network monitoring. The backbone of our automation is Node-RED. Node-RED, I discovered it via the Home Assistant project. Node-RED is, I believe it is based off of Node.js and JavaScript, but don't quote me. But also we use MySQL as a database backend and MQTT as the transport mechanism, so that the little hardware devices can speak to the automation system over a message protocol. One of the things I love about Node-RED is its drag and drop. You can define these nodes, and some of them could be a database query, some of them could be a switch, so it's an if statement. Some of them you can use to change variables, and I found this system very easy to pick up. I don't like programming. I don't have a background in programming. I'm not very good at it, so this is a way that I can build a system that is extremely powerful with very little in programming knowledge. And I'll show a little demo of Node-RED in a bit. Recording the sessions. So we use a small form factor desktop, think about yay big, that will, it runs entirely headless on purpose. We did not want a display or a keyboard for someone in the room to mess with. And it either runs Gentoo or Ubuntu, depends on who gets the final say, whether it's me or another gentleman. And we use AnyDesk to access it remotely, or I also have a KVM over IP connection that I can plug in on the back of it. Since these are consumer grade desktops, they don't have an ILO or an IPAM or an iDrake or a lights out. All of our recording is done with OBS with a WebSocket extension installed, and this WebSocket extension is what allows us to do the automation for OBS. The only part of the automation that we care about is starting and stopping the recordings. Everything else is already predefined, and so that's the only thing we care about is start and stop. I couldn't figure out how to get Node-RED to do it, call this WebSocket API directly, so I had to write a little Python glue script using lots of examples that is bashed together into something that will actually function. OBS will then write out the video to an NFS share. Because the WebSocket at the time did not have an API to ask what file name you're currently writing out, we have to scrape it using LSOF, basically list open files, and I sort for the specific directory that OBS should be writing to. Then that file name is stored within the database so that we don't have to, so that we have the file name and the folder path that it's in for the rest of it. For the capture, we use Magwell USB 3 HDMI capture devices, PoE cameras capture the speaker, much like they're doing with a much more expensive camera, and then a USB audio DAC, which does give us balanced left and right audio. I have a particular disdain for Apple and their HDCP. We have found, because we're using splitters to come from the user's or the speaker's laptop to a splitter, and then from the HDMI capture and to the projector, some Apples and some configurations will block the signal to the Magwell device because it's trying to enforce the HDMI copy protection. So I have a disdain for Apple. Recording part 2. The sessions, after the session is over, Node-RED will then upload the video to YouTube, and then we also, new for 2022, will be sending it to Internet Archive, and if we can find a good instance, PeerTube too. And our goal is to get the session video up online as fast as possible after the session is over. We ran into a problem with the YouTube API. Based on how they do their API query limits and uploading videos, after about 5.5 videos, we get locked out for 24 hours. There does not appear to be any fix for that. We've requested extensions to up the limit, because we only upload videos for a weekend. After that, we don't upload videos again until the next year. But again, being YouTube, they have never gotten back. Live streaming. Live streaming is handled a little bit different. Again, it's OBS that does it, but we have partnered with Noah, who does the Ask Noah show, and iSpeed, and he manages the streaming servers. So what we do is, at the very beginning of the day, we set up OBS to stream to one of his servers, and then he takes it over from there. And we do embed the live stream on our website so that from our website you can see the live stream. And again, remember, we're doing 4 live streams at the same time and uploading videos when the sessions are over. Here are the speaker lights. One of our staff members has a laser cutter, so he cut out with balsa wood with the laser cutter and made these nice little boxes. It is a Node MCU ESP8266 Arduino board, specifically running the ESP Home project. ESP Home project is think of it as an operating system for the ESP devices, and it allows me to just define a configuration file, JSON configuration file, and give it to the ESP home, and it will compile the code on a desktop and then upload it to the ESP device itself. Those connect over Wi-Fi, unfortunately, 2.4 gigahertz only. And again, it uses MQTT to listen, in this case, listen for messages of when to fire the different colors. So green is it's recording. Yellow is when the yellow starts flashing, that's a 5-minute warning. And red is stop, the video recording's been stopped. And we tell our presenters the recordings start and stop within 10 seconds of the scheduled times. So if you start early, it won't capture it. If you run late, it won't capture it. People counters. We're using, at the time I could not find any good open source options. You could probably do it now today with TensorFlow, but I actually found it's not terribly expensive. It's about 120 bucks, a perpetual license for some software called Camlinux. Basically, it's camera analytics, but spelled funky. And by mounting the camera directly over the door, we count people regardless if they're stacked together. So if 2 people come in shoulder to shoulder, if you had a camera from the side or the front, you might miscount because the one person will be obstructing the other. So by putting it directly overhead, it's easier to count individual people as they're crossing the door. And the Camlinux software is aware of direction. So we put an arrow so we only count people as they enter the room. We don't count them as they leave, just to try to keep from double counting. And the Camlinux software has a JSON HTTP API that Node-RED will query and be able to then store how many people entered that room into the database. Next is the vote boxes. Our artwork used to be, as some people call it, a little more offensive as far as the frowny faces versus just thumbs up, thumbs down. And again, it's based off of Node MCU, MQTT, and Wi-Fi, and it's USB powered, exactly like the speaker lights. Again, same thing, running ESP home. It's just a different JSON configuration for it. And when the session is over, we'll have how many people attended that session and how many people voted and what the vote was. So in the database, it's real simple. An upvote is +1, a blue vote or neutral vote is 0, and a negative vote is -1. So at the end, we can tell exactly how many people voted and then what the vote was. So we can tell with a pretty good certainty without physically surveying people of how good that session was. And so that can then help us influence the topics and the speakers for future selection. Again, we do all of the Wi-Fi networking for the event. We use nothing of the infrastructure provided by the hotel. We run our own cable, Ethernet and fiber. We put it in the ceiling. We've actually been able to leave a lot of it in the ceiling year to year. Hotel may or may not know that's there. I don't advertise it's there, but if on the setup day, I'm going around with a ladder and popping ceiling tiles and dropping cable down. So if they pay attention, they'd figure it out. We bring in our own internet connection. Again, we don't use anything from the hotel. We run it. I own all the hardware, and I manage it all. And all of the automation and everything else, all the services that we do, none of it's cloud-based. It's all hosted on-site. And I want to do that for reliability if in case there was an internet outage. We can only afford to get one internet connection. It's a gigabit. It's like 940 by 30 coax connection, and it still costs us $800 to get it, even though we only use it for 3 days. We do 6 servers, 20 plus APs, and 7 switches. Again, I own all that. Most of those servers are bare metal. There is some virtualization. When I said we run our own cable, it is quite literally we run our own cable. In 2019, we expanded into a new wing of the hotel, so I needed to extend our network into the new wing. In order to do that, there is about a 5-foot diameter pipe that runs between the 2 sections of the building underground, where they have things like steam cables, fiber, and communication cables. And so if you actually look, you can see our fiber right there at the very top, draped along everything. I did not go with armor. I paid $200 for the fiber. If in the run-up for 2022, I'll go up there and test the fiber. If it tests bad, I'll run new fiber. It's cheaper to get inexpensive fiber. It's about 800 feet worth than it is to buy more premium fiber that might sustain a little more damage. And the other picture is the NOC, where we set up all the cables come back to the NOC, and we have all the servers. It does get quite warm. We have trip breakers. I'm trying to get better about not tripping breakers because it's a real pain when that happens. If you look, you can see the cables coming down from the ceiling. So we don't have any cables that are laying on the floor on any walkway. All of them go up into the ceiling. LAN party. So we host on-site servers for Team Fortress 2, Minecraft, and Unreal Tournaments 2004. What's nice about Team Fortress 2 is it does have a native Linux edition, and it's free to play. All you need is a Steam account, and you can download and install it. We set up, 2019 we did about 30 or so positions, and it filled up in the evenings. And in each position we provide power and a hard Ethernet jack for anyone who brings anything that needs to be wired in. We do gigabit all the way, and 10 gig between switches and the backbone, and all the servers are in 10 gig too. Displays. This is how we used to do it, and I hated this system. It became out of date. It looks janky and cheesy. Basically, we'd print out the information and tape it to the wall. And so right next to it is a wonderful display that the hotel has conveniently placed there for us, for their use. So what it really is a VGA display and an HDMI display, depending on exactly how old the display is. And behind it is some embedded computer running some of their system. So what we have now is we have 25 Raspberry Pi wireless zeros that we're going to be hooking up behind this display. So we're gonna take apart their display, unhook their display from their computer, plug it into ours, and be able to manage those displays. And those displays are running Ubuntu with Firefox and kiosk mode, and they just refresh over and over a URL on the server, and Node-RED writes out the file for the HTML. It's just straight HTML, a little bit of PHP and CSS, and again, those are all Wi-Fi based. Monitoring, bulk of the network monitoring is LibreMMS, which is a pretty cool SNMP based platform. The next is for LAN cache. So we run an on-site cache for most game platforms. So when you download a popular title, it's probably actually being downloaded from our cache, which we have 10 gig interfaces on. The screenshot you see is it's an EKL stack that produced that, and it can even show down to the game title in Steam which title has been downloaded the most and which IPs downloaded when which service has been downloaded. Then we use mtop-mg, which is a historically a NetFlow analyzer, but we use it, I use it to try to gain a sense as to where is the bulk of the traffic going. Is it going YouTube? Is it going Facebook? Is it Google? Is it Amazon? Is it Cloudflare? It does not see the NAT side, so it doesn't see the private side. It only looks at from the public side of the firewall. And we do run full IPv6 dual stack, so everything is dual stacked. And then we also get the statistics from the wireless controller, whether it's Unify or Ruckus. Historically, it's been Unify, but I now have a wonderful employer that has a lot of Ruckus APs that I'll probably be borrowing, and then we can do Wi-Fi 6 because the APs I own, the Unify ones, are AC only, and I'd like to gain AX. More details. I've been slowly writing it up on my personal website along with the GitHub link. It has a lot more pictures and a lot more details of everything. This was more of an overview. Questions?
How many days does it take to set up and tear down?
So teardown is easy, about 2 hours. It is fascinating how fast it is to take everything down. Setup actually on site, we start on about a Wednesday afternoon, and we take Wednesday afternoon, all day Thursday, and we're ready for 8 a.m. on Friday. And it's me and one other gentleman that does it.
Thank you.
We have an online question from Chris Baker. New question. Zach, you say it is all automated and you're the only volunteer worker, but it must take a small army to do all the setups in power and tear down. Yes?
The setup is, again, really only me and another gentleman. I do all the configuration of the equipment at home. Typically how the planning works for the automation and the networking, I do it kind of hand in hand, is I will start it in January. With the event being in June, I'll start in January, start the planning and deciding exactly what I want to do. And then about March, I'll actually start testing, and because I'm reusing the automation over and over. So it's just building upon last year's event, which we didn't hold it in 20 or 21, unfortunately, on site at least. And so about March, I start pulling the pieces together, and typically by the end of April, I have the system fully working, and at least the bugs that I realistically think we would hit have been squashed and fixed, and workarounds dealt with. I don't try to do every corner case. It's just, it's only me.
You said you used LAN cache to cache Steam games so that they could be downloaded from the local network rather than going out to the internet. I didn't think that that was possible anymore. I'd done stuff like that in the past because all that stuff is served over TLS encrypted.
Not quite. So specifically with the big game platforms, so Steam, Origin, GOG, which is Good Old Games, Riot, Wargaming, even the Warcraft people, none of them encrypt their game downloads. They don't need to. What they will encrypt is they will establish a TLS connection, which they will get an encryption key and a hash of all the files. When the client finishes downloading the files over HTTP, it'll then hash it, and if the hash fails, it will then switch over to an HTTPS connection, bypassing the cache and going directly to the origin. And Steam actually does officially support it. There's a special host name called LAN cache, It's landcache.yourdomain, your fully qualified domain name, that if the Steam client finds, if that resolves to an RFC 1918 IP, then it will automatically download from that. So we don't even have to intercept. We don't have to do any DNS.
Oh wow! So that's not even a proxy. It's literally just. Yeah. Oh wow, that's crazy.
Yeah, it's an officially sanctioned procedure with Steam. The other clients, we do have to intercept their DNS and redirect it to us so that we can rewrite it.
Is there anything other than game services you guys do that with?
Yes, we've successfully done it with Linux repos, so CentOS, Ubuntu, all of those download over HTTP. We have done it.
So they just expect you to download the MD5.
Yeah,
which we all definitely do.
Yeah, exactly. It also works with Apple, so iOS and macOS updates also cache, and Windows updates also get cached.
Apps?
Yep, apps too.
Really?
Yeah.
Wow, I had no idea. Okay.
The LAN cache in 2019 saved us about 1 terabyte of bandwidth that it served that we didn't have to download.
All right, awesome. Thank you.
I do want to show you Node-RED. So this is Node-RED. If you can actually go full screen on the screen share. It's, again, I find it really easy. I do my SQL statement, which then goes to a SQL node, and out of it, I'm just checking to see if there's a payload. If it's a null result, it won't even go on to the next procedure. This particular flow right here is if the database thinks if the database thinks OBS should be running for that particular room, every 3 minutes it is going to check and reach out to the API, not API, it's the WebSockets, the OBS WebSocket, to see if the status is still recording. If the status has failed, but the database thinks it should be still running, it will then fire off a note to Telegram, which all the staff members use, and we have a specific Telegram channel that staff members can join that will get the failed messages. And I just have a little example right here where I'm injecting something into this var, which will send it to Telegram. And you can see the Telegram message came in here that the Ballroom A's recording has failed. So that is a push notification to everyone in the group. And I can just add people into the group, and they can also get the notification. So it's a great way for us to go, oh crap, OBS has crashed, OBS is not running for whatever reason. Go into the room and try to troubleshoot it and save as much of the recording as we can. I thought I had a picture of it, but I guess it didn't. I live about an hour and a half away from the venue, and all of the networking equipment, it takes, I fill up a Suburban and a 20-foot trailer. There's that much. Particularly if I have the frames for the, where was it? The wooden frames, I build them on site, and like in 2019, I took my chop saw and a pile of lumber, 2x4s, and built it. We weren't sure whether the system would work, so I didn't want to invest in fancy truss systems that are like $500-600 a door, and we're doing 4 of them. So about $20 in lumber is a lot cheaper. These Husky rolling totes, I've got 4 of them now that get filled with cables. Again, we got 7,000 feet of cabling. The vast majority of that cabling is in bundles. So it's anywhere from 2 to 8 individual Ethernets are bundled together and will basically act as a trunk line so that we can just drop it down and run it across the wall of a ballroom, and instead of having to run individuals. But that takes a lot of volume to, to haul that much cable. What was that? And actually, I have, you don't see it in the picture, but on the right-hand side, there's another table with another 4 monitors. And again, the system is entirely ran by one person. We do have, in each ballroom, we have one, we call them room moderators, but basically they are the point of reference for the speaker. We try not to get them to mess with the audio because skill sets are different and sometimes it's more damaged than good. So we get them mostly to act as a liaison for the staff to the speakers. Question?
Somebody else have a question, I think. Is that right? This young man here? Oh. Did you have a question?
No. It was a stupid one, but I was going to ask.
Use the mic.
Sure. Counter-Strike 1.6? Question mark?
We host a server for Counter-Strike. I don't play it, so I don't know anything about it, but it's there. We host about 6 or 8, I can't remember exactly how many, on-site servers.
Yeah, because I noticed it runs pretty well, like most systems, so I thought pretty cool. Also, Quake 2.
What was that?
Also, I was wondering about Quake 2, if that's a possibility.
I mean, if there's a dedicated server that I can run on site, I'm not opposed to hosting it. I have plenty of hardware to host it.
Nice.
What you see up here now is actually our cable documentation. So this is the level of planning that I go into. So these cable bundles, let me see if I can zoom. Here we go. So I have how long they are. Each cable has a unique identifier, and then each strand within that identifier also is labeled A, B, C, D, E, F, G, depending on how many runs are in it. So in here in the, I haven't filled it out yet, never mind. But I'll basically put down what each cable is ahead of time. So you can see how many runs they are, how long they are, and we have how many labeled cables? Yeah, there's 66 different labeled cables that we keep track of, and this is typically anything over 20 feet. If it's less than 20 feet, I don't care. It just goes in a big box. Is that all the questions?
I think so.
Thank you.
Thank you, Tack. Appreciate it very much. Our next talk is starting at 5. Now hiring open source, and it's by Kara Pritchard. So you got some time, about 23 minutes. Okay, our next speaker is Kara Pritchard, and she completed one of Red Hat's first RCE programs in 1999, published the first Linux certification study guide, RHCE Linux exam cram, how do I say this, Coriolis? Coriolis. That same year, she went on to continue learning about certification by working with the Linux Professional Institute for several years. She joined the training and certification team at the Linux Foundation in 2020. Please welcome Kara.
Hi, everybody that I can see. Those are amazing. I'm here today to talk about what it's like to work in the open source community and getting jobs in the open source community. My perspective, I feel like it's a little, well, I'd say unique, but I think lucky more than anything. I've basically spent my entire professional career working with Linux and open source in one way or another. I did start in the 90s. I started working with Linux users groups and with some special Linux projects. Most notable would be the Linux.com and LPI, as Eddie mentioned. When I got a little older and I had a kid, I wanted to balance a career with parenting, so I did the self-employment thing for a while. I ran a retail computer service shop. I had a 4-foot penguin on the sign, and if you knew who he was, you knew what we did, and if you didn't, you just thought he was cute. And it worked out pretty well. Then, as my daughter graduated and went on to college, I was ready to go back into corporate work. And I got really lucky, and I found another position with an open source company. So today, I thought we'd talk a little bit about the stuff that I've learned along the way, and maybe share some stuff that you all have learned too, working with open source. So who am I? Although I think he caught all my spoilers, but that's okay. I am your speaker. For the next 30 minutes or so. As fast as I talk, it may only take about 10, but that's all right. If I do look familiar, it could be because you've been coming here for a while. For the last 15, and we're arguing this morning, 16 years, my husband Stephen has been talking here at OLF, and I'm usually the one in the back, the tech linum. It's a lot of fun. It's the funnest job to have here. If you have been doing lug events for a while, we may have met at one of them. I had somebody a few years back come up to me from across the show floor here at OLF because they remembered me from a conference over a decade earlier that I helped with out in California. And that was very weird, very humbling and nice, but very, very weird. But you might remember me for some of them. Otherwise, you might want to go check LinkedIn or Facebook for some of those friends that we both have mutually forgotten. We all have those, like, how do I know you? September this year was the first conference that I've been to since OLF in 2019. It was the Open Source Summit in Seattle, and it was kind of cool because they had some presentations that weren't just strictly, this is how you would use Git, as to borrow Stephen's from earlier today, but a lot of professional career tracks as well. And I went to one that was hosted by Dawn Foster from VMware, and she was talking to everybody to challenge them to be willing to speak at a Linux conference, or any conference, technical conference. And so challenge accepted. I'm here. But why am I making myself do this? This is the first time, even though I've been doing stuff for so long, that I've agreed to present an event. I have hosted them, I've organized them, I found speakers for them. I'm happy to help with all of that, but I've never agreed to stand up here myself. If you Google it, there are 40,500,000 references to public speaking being the #1 social anxiety, and I can corroborate every one of those posts personally. It's the scariest thing I've ever done, and it didn't show up. I've been hit by a tornado on my way home from work. And I'd like to say that's exactly why I wanted to show you that picture, but it was more so that I could show you where you could put a cute penguin or two and keep your windows from breaking. I know Linux is like 30 years old, but that joke is still funny, right? Yeah, okay, thank you very much. We can talk later if you want to exchange tornado stories, yeah, that was totally cheating. But anyway, so who am I actually? I am Kara Pritchard, and I do work with the Linux Foundation on the certification and product development team. Excuse me just a minute. I have been learning about Linux and open source now for 26 years. I hope to continue learning about Linux and open source for at least 26 more, since 1995. Some of the most interesting things that I've done have been Linux certification related, which is why I'm going to talk mostly about that today. Can anybody here tell me who was first in Linux certification? Did somebody say Red Hat? I think somebody said Red Hat. Yeah, Red Hat was first. They did come out with their program in 1999. And it was kind of cool. It was a week-long experience. You would go to their offices in Research Triangle Park, spend 4 days in a classroom with a whole bunch of big CRTs and giant servers to learn about how to do your own Linux administration. At the end of that week, you would get 3 exams. 2 of them were hands-on testing. They would teach you how to set up and install a Linux system. You would come back and go to lunch and take a written exam about a bunch of details that you forgot about, and then you come back and figure out how they broke your Linux system and you'd have to fix it. So it was really cool. And the reason that I got to do that was because those publishers that I was working with to connect with users groups, getting them free swag and speakers and all kinds of fun stuff, one of them was asking me what kind of topics would be cool, if I heard of anything to let her know. And I said, well, I heard about that Red Hat is doing a certification program. I don't know if anybody remembers those rows and rows at Barnes & Noble or whichever bookstore you preferred of red books and all of the MCSEs and NT programs and all the other certifications. I thought it'd be really cool to see one that said Linux on it. And she said, that sounds great. You want to do it? So I was like, okay, all right, I'll go and I'll do that. So it was the second week of that program that I got to do that. So I was trying to look up some stats and figure out like where I stood. Red Hat's not publishing, at least not that I could find. Maybe your Google skills are better. They're not publishing their numbers now, but the last one they did publish was in 2009. They had over 40,000 RHCEs. And given that I think I was number 60-something, that would have put me in the first 0.1% of those RHCEs. So by now, I think I could claim that I was the first. It'd just be a rounding error. But I will talk a little bit more about RHCE a little bit later. LPI came just a few months, there you go. LPI came just a few months after RHCE did, and I met them at a trade show in Atlanta, the Atlanta Linux Showcase. And my book publisher was there, and I had this really friendly, excited guy from Germany who came and talked really fast, even could talk faster than me, but it was really exciting. He told me I had to meet these people. And so I got to meet some of the founding team of LPI, and just a few months later, I joined their team to get to work on their program. They came out with LPI Level 1 first, and that was really cool. But my big project that I first got to step in on them was helping them design the LPI Level 2 program. So that was pretty cool. But I'm going to talk a little bit more about that with them a little later too. If you've been around a while, you may have heard of this one. SARE, Linux and GNU, they were really big at conferences. They were doing a training boot camp along with their certification program right about the same time, kind of targeting some of the same market as LPI. They moved around a bit, and there were some mergers, and I honestly don't know what ended up happening with them. They aren't with us anymore, but I did want to pay a little bit of respect to their history. But that next year with LPI was kind of fun, because several of us got to sit on one of the first boards with CompTIA to help put together their Linux Plus program and operate kind of as their first round of SMEs, their subject matter experts, and so that was a little bit different. If you do go looking up their Linux Plus program now, they used to do a co-op deal with LPI where you got dual credits, but as of I think 2019, that changed. So if you are looking at any material that talks a lot about that, you might want to look for something a little bit newer. Put a little bit of a gap in it. The Linux Foundation, while the organization was founded in 2000, they didn't start coming out with their certification programs until 2014. They did start with the LFCS and LFCE programs. They were their 2 performance-based exams. My role with them is that I get to work with a team of about a dozen people. A little more than half of them are actually working on coding the environments and the infrastructure and everything that supports a performance-based exam. And the rest of us get to either work on the content or we get to work with the different projects at the LF to build these certification programs that helps their communities either bring on more skilled people into their community or actually set up a revenue source that helps them make some money for their organizations while they're growing. And LF will be the other one I talk about in a few more slides. Before we go, I still wanted to talk about or mention 3 others that are out there right now. We've got SUSEs, which you may have known as Novell, and then may have known as SUSE again. The SANS Institute isn't as common unless you're in a real heavy secure or government environments, but they're a very, very big, very high stakes program. And Oracle has one as well. SUSEs is still independent. From what I don't know as much about them, but it does look like it's a performance-based exam right now. They do a refresh with every one of their releases. I saw some news about that recently. SANS used to have a GIUX. that was dedicated to Unix and Linux administration and security topics, but now, because it's so embedded all over the industry, they've kind of got it spread out. So they did retire that one, but they still have some amazing coverage for that. Oracle looks to be a single multiple choice exam, and I got to admit on that one, I know it's current. Their online information was a little confusing, so I do know they have at least one. If you know more about that, I would love an update on that if you could help me out, because the online, that was a little confusing. But to move on to open source jobs. A neat thing that LF has been doing since 2012 is they've got a team that does a bunch of research to see what the open source job market looks like. And so they do a jobs report every year. Has anybody here seen or know what I'm talking about? Okay, so you haven't already seen the slides. That's good. You know, they tell us something, I swear it's not copy and paste, and I'm not sure it's going to be a huge surprise to very many of you, but open source jobs and Linux jobs are growing. The demand is growing every year. Big surprise, right? Yeah, no. What you may not have thought about it being kind of, well, duh. If you think about what we've gone through in the last couple of years and how much everybody here and everybody with kids at home and everybody with jobs, their lives have changed the last 2 years, the infrastructure that's made that possible and what demand that's put on our open source technology professionals and the demand for them, it's just skyrocketed. So those numbers, I said, I'd love to see how over the next 2 years we see that those things change. All right. Who can tell me why you wanted to have a job or a career in open source? Beth Lynn, why did you want a job? Why did you want to work in open source?
I came for the software, and I stayed for the community.
Nice, nice. I knew she would have a good answer. That's why I picked on her. Thank you very much. Yeah, so yeah, we like working remotely. We heard there's good opportunities. We're just really, really passionate about it. Maybe because open source runs on everything. Yeah. Anybody else? Everybody's agreeing? Yeah, because everybody says the same thing. And that's true. It's validated exactly by what that report said. The number one answer is my favorite one. 58% of them said open source runs everything. That's why they want to have a job in open source. And it is kind of mind-blowing to see the differences over the last decade or two plus, whenever you've been around, just to see that it is everywhere. So if nothing else, it's kind of nice that my parents finally can tell other people what I do for a living. Yeah, not really. They just know more of the words, and that's kind of nice too. The jobs report has got a whole lot of statistics in it, and I will admit it feels a little book reportish when I'm going through them because that's not the world that I do live in, but I did want to share some of them with you anyway. They like to talk to a lot of the hiring managers, and again, not to our surprise, almost all of them are struggling to find talent. What they're stressed out about, though, is catching up to the demand. They said that their needs are like doubling over the next 6 months, and trying to figure out how that they're going to find those skills. Because it's hard to figure out if they're the right skills. If you've ever interviewed with the HR team, they're trying to get in to talk to those technical people. The technology is huge. It's really hard for them to connect with it and figure out, okay, do you actually know what it is that you're talking about? And it's a big challenge. And just because you have somebody that's really smart, knows everything about some topic, as fast as technology changes, you don't know if those people can adapt on their own, learn on their own, and be able to fill out those roles. And trying to find somebody new to fill the gap is not fun. As a result, they're having to look towards certification and certification training to help fill those gaps. And they did get, of their managers, they said 72% of them admitted that they have to rely more on finding people who are certified. And luckily, 88% of them said they're willing to help pay for it. And that's really the big news, the good news for all of us. But in the end, whenever I'm going through all of these jobs reports, what I'm hearing is that certification is a huge key to solving the open source staffing shortage. Another research project that the LF worked with this year is with the IDC and the ITCC, which is a IT certification council. It's a nonprofit group just for technical certifications to get together and work out things that are in common with them, but the LF is very active in that. So they did a market research, and for the marketing and research nerds, they really like that NPS score that I got to learn about. My husband gave me a little bit of a tour on that one. That was a stat I wasn't familiar with. And they're really excited because they got a 30, if you have a fully certified team, that they are known to have 36 higher NPS scores. What I thought was interesting is they found comparing fully certified teams to ones that were partially, they reliably were 20% more likely to scope out a project properly and 35% more likely to finish their projects ahead of schedule, and their managers really, really like that. So this report from IDC tells me again, certification is a big key to solving our staffing problems. If we know the world needs more open source IT staff and the hiring people are looking to get more certified people to fill the demand, then you're looking at what choices. And we've already talked about a whole bunch of them on that a few slides ago. But I feel like I'm kind of in a unique position because I haven't met anybody else that has been a piece of so many of the programs and care about them all and can actually tell you and feel very, very confident you can't really go wrong. Whenever you're looking at the different programs, you could get all of them if you wanted to. If you go to LinkedIn and you scroll down by the people with their badges list, it looks like some people do it, just that. I don't know how they get anything else done because they've got every single certification on the planet. But it is impressive. There's going to be overlap, foundational core skills. They're going to overlap between programs. The nice thing about core skills in Linux or open source is that there's so dang many of them. Not any one program can cover them all. So that's a plus. You might have some help because you're working on a team or you're wanting to move to a team that's already heavily embedded with something you want to learn about. Like, you're going to go into a RHEL environment, so the Red Hat programs are going to make sense to you. Or, you're wanting to find out about Kubernetes, so you're going to go hit the CNCF project exams with the LF. But you might be going down a different path that isn't obvious. You might be going specific into that developer work or specific into cloud infrastructure work, or something completely different, going into Amazon or Google's. They've got programs of their own too. But the nice thing is that they're all kind of mix and match, and they all support your career paths, which gives you a lot of flexibility. So while at first look it's overwhelming, when you look at it again, you kind of realize it's all related. So it's really hard to not be, any way you choose, you're not going to be wasting your time, which is nice. But if you are going to be looking specifically at Linux and open source technologies, your 3 programs that are going to cover the most skills and have the most options for you are going to be Red Hat, LPI, and LF. And I think 5 times now I've warned you I was going to talk more about them. Red Hat's program now is almost exclusively performance-based. When I say that, do you guys know what I'm talking about? Okay. Everybody here, and if you've got around it, I want to know how. You've all had your multiple choice and standards exams where you get your exam, your questions, and all these answers, and there's a whole bunch of really interesting science behind it, psychometric science behind it to make sure that those tests are valid and prove skills. So that when you have a multiple choice exam, that's what those are. When you go, you sit down either at your computer at home and log into a remote system, or you go to a testing center and you sit down and you actually sit down and log in at a terminal, and you're given tasks to do, and you have to go and do them. You have to go and fix them, and it submits all of it, and it goes into the background, and you figure out, did you get the right answer? How did you go get the right answer? Did you use the right tools? Did you complete the task? And you get to find out if you passed or failed, usually a little later, because it's got a whole lot of work involved to get there. That is a performance-based exam. They're both different ways to test you on some of the same and similar skills, but they're very different experiences. Some people don't do very well with having to check through. They want to get their hands on it and actually go through an exercise that makes more sense to them. And other people, that stresses them out too, because it's like having 4 big spotlights and a camera on you. And you can get a little bit of anxiety from that too. So you get different experiences and different options for those exams. So those performance-based exams are the ones where you are sitting at a computer and doing the actual work and getting scored on it. The Red Hat exams, I do believe they're still doing some in-house training programs. They've all adjusted a lot with COVID, so their online material isn't all current for that. What I've seen Red Hat respond whenever you can't get out to one of the training centers or the training programs that have had to put that stuff on pause, they've developed a really cool remote. So if you've got a team that you've got enough people wanting to go through a Red Hat program, they're going to send you USB bootable drives to set up an environment on location and complete their programs in your offices, which is really cool. They have 2 primary tracks still. They did add to their RHCE, they added a prerequisite to that, which is the RHCSA. But if you go to their website, you're going to see 30 different programs that are listed there. They're all designed to be mix and match. And it's kind of neat because they've got specific programs. If you get their RHCE and you get a collection of specified additional certs from them, they've got an architect program now, a microservices developer, and a JBoss developer, all built off of their RHCE. All their training is done and developed and partnered with them, so it's very, very extensive for that. I did leave a URL up there that was kind of neat. I hadn't seen it before, but they have an assessment tool. You do have to log in for it, but it'll kind of give you an idea of where you're at and which of their programs might be beneficial to you. Oh, that was kind of neat. LPI is designed to be and it has been from the beginning, distribution neutral and vendor neutral. Like to be friends with everybody, which is very, very important. They are a strictly multiple choice exam environment. Most of them are 90 minutes, though I do believe their entry level one is a little bit shorter than that. They're all proctored online or at testing centers, and I believe those are still with View. LPIC 1 and 2 are still their core exam programs. They are prerequisites for one another. But they do have the level 3 specializations now that came out, which are new. I don't know as much about them, but they're really neat. Multi-platform security, virtualization, and high availability. So when you're wanting to get those engineer and high-level skills, they've got those available, as well as a couple of open technology certificates, one in DevOps and one as a BSD specialist. They don't do in-house training development. They work with partners for that, including one of them, who I believe is doing some classes or was doing some classes around the corner, and you see with them every year. Something really neat that they've put together in the last few years is a membership program. Once you've completed one of your LPIC certs, you can join as a member, which gives you voting rights and discounts to things that they do. And if you stop by their booth, they're going to give you a lot better information on that than what I can. But it is something that's unique to them. The Linux Foundation, a different collection of certifications. Most of them, we are primarily performance-based exams as well. Last year, we did add our first multiple choice exams. They're being targeted for entry-level programs, and they did it for 2 reasons. One is to get a program that was more affordable in countries where there aren't as many resources available for buying that sort of thing. And also to make them more accessible for entry-level and people starting their career. Again, trying to grow that pool to fill a need, but just because the need is so desperate. They are all and have been remote proctored online exams. Has anybody sat through a remote proctored exam? You loved it, right? Yeah, it is rough. It can be rough, and it is a very, very different experience. But very, very important to make sure that your credential stays valuable. And it is you who take the exam, and that everybody has as same of an experience as possible whenever you don't have the control of being able to do that in the environment. The LFCS is the core Linux program for the Linux Foundation. We do have 14 other exams for the 7 different projects that are separate from the LF core exam. The newest ones are those multiple choice ones. A few weeks ago, we came out with an entry-level Kubernetes multiple choice exam with KCNA. And this week, we opened up a beta for the first TARS certified developer exam. That was a very different one. The LF does do training, but it's a completely different team than what I work on. The training team actually works with the projects to build courseware, and whenever they've built an exam, or the projects have come to us to build an exam, then they will figure out which courseware helps candidates prepare, but the courseware is not written to the exam content or vice versa. So if you've ever completed one of the courses and like, they didn't test me on that, that's because that's not what the courseware were designed for. I'm always eager if you've got anybody or you yourself feel like you're a subject matter expert and you'd love to get into doing exam development or helping update something we have or something new, I'd love to meet you. And I would get in trouble if I didn't tell you that we are in the middle of our Cyber Monday sale. So if you've ever been interested in any of the Linux Foundation certifications or training programs, you will not find a better price than right now. That sale ends on December the 6th. And in case I forgot, I did give myself a slide, Cyber Monday, December 6th. All right, back to our favorite stats reports. Over the years, I'll have, whether it's students or employees I've had working for me, they always want to know, what should I go learn to make the most money? You know, what's hottest? And it's always a really hard thing for me to answer, because I always want to tell them, I don't care what's hottest. It's what, worry more about what you can do and do the best at that you're willing to do, even if you've had to do it all day and all night, and 3 days later you're not tired of it, and be most successful at that, then that's going to be the path that you should follow. But right now we've got a need, so we kind of need to focus on that a little bit. So not a big surprise. Research says cloud and container technologies are our hotspot right now. So if you love working in that space, then that's great. But I do want to warn people who do jump straight to the developer certs or these courses not to skip the fundamentals. And those are going to be largely covered in your Linux courses, your Linux administrator courses, because you can get through the HR interviews and you're going to get the hiring manager that's so desperate for that skill that they'll figure it out and they'll teach you the rest of it, which is good and important. But you're really going to shine if you're good in your environment. And especially coming in from students, because they're not teaching all these things. They're doing a lot better in the college courses and high schools and things like that. But they dive into these programs, and it makes a huge difference. So if you are trying to figure out what to do, excuse me. If you are already working somewhere, before you start getting signed up and log in with your account, if you haven't checked already with your HR team or your boss or whatever, make sure you don't already have a training program at your company to take full advantage of. They're getting more and more friendly. They're doing so much better. We keep hearing the words of investing in our employees. It's really important because we're trying to keep them, and they're doing better about that. So if you haven't talked to them in a while, please do that. If you're getting started though, if you're a student or your company just doesn't have the resources to have a training support, there's an awful lot of free materials online to support all of these. And it kind of surprises you that it's not all just on YouTube. Does anybody have a free one before I start talking about anything else? Oh, someone else said LF. Okay, I love it. That's good. But I'm actually a little embarrassed. I didn't realize how many amazing and how deep the free courses were at LF before I started there. I was kind of excited about one of the benefits was that I was going to be able to sign up and go through some of the bigger courses that I couldn't have afforded on my own, self-employed, doing that whole parenting thing. And then I started seeing the ones that I was most interested in that I could have had all along already existed. So, oops on me. But if you go to training.linuxfoundation.org and under resources, you're going to get a list of what the free courses are available. They do host those at edX. And if you go direct to edX's site, you'll see that they've got a whole slew of other things. Just searching for Linux, you can see the Red Hat ones already popping up, and the list gets really, really long. I will mention, if you go there now and you haven't been there before, you're going to start seeing new branding. I updated it because last week or so they've joined up with 2U. I don't know how that branding is going to change, but I don't want you to worry that you got hijacked and taken to another site. It is all still the same company. So I can't really talk about open source jobs without talking about how do you find one if you don't already have one. We all know that referrals from our friends is the best way to get in the door. We're all recruiting our friends. We want to work with people that we like, that we can teach, or we want that referral bonus depending on the company that you're at. But what if you don't know anyone? And we all know the answer to that too, is that you're going to go online. And I did find it kind of interesting whenever I was trying to find Google out stats for that. 5 years ago, they said there were 10 new jobs being posted every second and over 16 million active job listings. With the way things have changed, I can't imagine what that looks like now, but it definitely explains why the online resources and search tools have gotten pretty amazing. My favorite one is Google. And even whenever I was pointing these things out to my husband, he said, well, where do you go to find that? And I said, you just go to Google. If you go to jobs.google.com, you're going to find places to post jobs, but not this cool search engine. If you start treating it like where you're going to find dinner tonight, and you're like, looking for ramen near me, or something, or ramen near St. Louis, you can do that with your job. Linux near me, Linux job near me, and you're going to get some pretty cool filters off of that. My favorite ones are the titles. Because then you get to see all the various jobs you didn't know that your skill could be looking for. How recently the job was posted, because it doesn't do you any good to find that job that was posted on that site 6 months ago. It's long since been filled. Or of course, narrowing it down to the company that you want to work for. I actually use these tools for research too, because if I've got maybe one of the programs feels like it needs to be updated or isn't hitting the right market, I'll go and be looking for those jobs to see who else I need to be talking to. And there's a lot of inspiration there for that. LinkedIn's a pretty obvious one too. My favorite filters on that one, I like to see the experience level compared to the job postings for them. Though that mismatch is always kind of a little bit interesting. But you can actually search for jobs that have only been posted within the last 24 hours. And I think that's really cool because there's so many repeat job postings. You don't know what's current. You don't know what's been filled and the recruiter forgot to take it offline or whatever. And so seeing what's actually active is really valuable. while we are Googling and Indeeding and salarying and everything for everything online, I don't want people to forget to go to the source. If you got someplace that you know you want to work at, you still want to check out their website. You don't have to talk to a recruiter, although that does seem to be a little bit more successful once we get into some of these specialized careers. The companies will still just talk to you directly about hiring you. I wanted to share LF's career page for a couple of reasons. One is that it's not just LF jobs that are here. So if you're looking to get involved in one of the LF projects, whenever they have openings, they post them straight to the career site on LF. Also, you don't have to be a coder to get a job in open source. And I don't know how many people know that or even think about it. You know, if you're a rock star with Jira but not Java, you know, you've got project management jobs. If you could sell air conditioners in Antarctica, you've got lots of marketing and sales jobs. And those are really prevalent on the LF site too. So if it's not necessarily you, but you've got somebody in your family or your contact sphere that loves what you do, but they're no good at, they're never going to sit down and code, then those are fantastic resources. And then you should get them involved there. But if you do want a developer job, I did leave myself a note here. I'm so glad we have notes. So you're looking for like maybe an entry-level developer job. They do update those. I think the LF does update that weekly, and because you never know when's going to pop up. Like maybe even on my team at the beginning of next year. You know, feel free to ask me about that or send me an email, kpritchard@linuxfoundation.org. Yeah, I'm not good at nuance. I don't know if you picked up on that. Hitting up on those slides again today. This one isn't a specific career job posting site, but I hadn't run into this before, and I thought it was really interesting, primarily because the articles were current. I get a little lost on that whenever I think, oh, this is a really cool story, dated 2006. Oh, crap. But Red Hat sponsors opensource.com, and they've got a lot of really neat articles on their careers page. And what I thought was interesting is they do talk about if you're trying to get into or start or change your career in open source, but there were also articles about how do you turn the job that you really like into one that you love by involving open source. So last one, and this is kind of, I was just throwing that up there. Hopefully I even spell checked it. I think that's good. I just didn't want to forget because it's something that especially new people forget whenever they're getting their first jobs in open source, what kinds of things to do when they're negotiating that job. And I don't mean the salary and the vacation time and all that kind of stuff. That's not fun to negotiate either. And if you enjoy that, okay, good for you. But the things that are kind of special to us, we've already mentioned several times training. It's absolutely important. If you want to make sure the company you work with wants to invest in you, that they're giving you the time to grow your skills, especially if that they're allowing you to do that during business hours and not expecting you to do it on Saturdays and Sundays kind of thing, supporting the cost to do it. Those are kind of the no-brainers. Another thing that's kind of new that people are starting to talk about is the 20% time policies. Does anyone here know what those are? All right, good. If you don't, it's companies that are talking to you about that they're willing to allow your job to have 20% of the time, or basically a day a week, to do something that's not the project you're being hired for, but ultimately still benefits the company. So maybe it's going to be you learning and getting the training programs that we've been talking about, or that you might be contributing, whether it could be to a local nonprofit on their behalf, or that you're donating time to an open source project. And those qualify too. So finding out if the companies that they're getting more creative like that to help with retaining their staff, and it can make your job a lot happier place too. So find out if you have any options there. If you're coding specifically, and this is one, I think I saw a table out there that there's somebody who's going to be walking around that knows a whole lot more about this than me. But if you are coding or you're going to be working with code, finding out about the pre-invention or IP rules around the company, especially if they're not one that's already heavily embedded in open source, might save you some pain later. So I said, if you're going to be in that space, at least ask about it. And this is where I got to ask, does anybody else have any last minute negotiation tips for me to add to this list? That was like added today. Okay, good. All right, I want to thank you guys for being my first audience today. I really appreciate that opportunity. Does anybody have any questions for me? All right, yeah, so use that mic so everybody can hear you.
Okay. If there's a college student who earns a certificate before they actually get their degree, is that something that you think companies are still going to be interested in?
Oh, absolutely.
Okay, good to know.
Yeah, I can say that confidently. I don't even have to say, I'm sorry, I don't have a good answer for that. I was worried about that. No, absolutely. I bet you that there's a good chunk of this room who say they've got certifications and no college degree. I see anybody? Yeah, I'm seeing hands. Yeah, they're going to be good. All right. We have another question walking out?
More of a comment.
Okay.
You got it. Go.
Oh, you guys are coming out of the shadows. That's neat.
Well, check with your company. A lot of them will put you, because the free stuff out there, there's like linked learning and Skillsoft and stuff like that. You just have to ask the questions, and they'll lead you to it. If you start with them, they may not pay for training for like 6 months, but there's a lot of free resources out there.
Good.
And then also, there's an online thing called Udemy. And if you start taking a few courses, they'll start sending you letters, hey, because the courses are like $200, but once you're in their mail list, they'll say, hey, we got a sale on this $200 course is for 20 bucks.
That's a good coupon.
Yeah, so it's like, once you get on your mail list, then you're going to start getting all kinds of stuff.
Yep. Thank you.
Similar to that.
Please tell your words.
I was here in 2019 and my topic was continuous learning, and there were 10 really inexpensive sites you can go to teach you anything. One I wanted to mention, Udemy was one, UDEMY, he mentioned. That's very good. One I'll recommend is Eduonix, EDUONIX. I have it if you want it.
Okay.
I just did a search for Linux while you were talking. Courses range from $4 to 20 bucks. And again, once you get on the list, they're like, here's a free one. And so there's a lot of low-cost resources out there. I highly recommend them. You get on their list. I mean, you could spend like $100 and get 4 to 10 classes.
Yeah, you combine
They're
those
well worth it.
Yeah.
There's e-certifications. It's getting to the point, I told my son, I was like, if I were you at your age and wanted an IT degree, I would spend $1,500 on classes at Udemy and get 10 certifications and then just apply for jobs as opposed to going to college.
Yeah, you definitely have a lot more options. You combine those with, if you look online, especially if you're in a metropolitan area, you can't hardly throw a rock without hitting a user group. And granted, a lot of them are meeting online with that, but you start meeting with everybody here who's super eager to help. Now you've got your classes, and then now you can go get your personalized free trainers because every one of those user group resources are just going to put their arms around you and teach you everything you know, whether you like it or not, which is kind of fantastic.
The one thing I will reiterate and confirm with you is cloud certification's hot, and it's also a very inexpensive path.
Thank you so much.
You're welcome.
To kind of tie into what was just discussed, there are also a lot of colleges that are offering certifications in conjunction with degrees. I just graduated from Western Governors University and ended up as a part of that program also getting about 12 different certifications, including Linux Plus, LPI, Amazon AWS, Project Plus, A Plus. I mean, just a huge stack of certifications. And even with that route, somebody like Western Governors as an online school was probably a third the cost of a traditional brick and mortar school. So especially if people are not yet in that space, not yet with a college degree, but looking for both, then those options are out there too.
Good. Thank you. All right. We got, do you have another one? Oh, no, okay.
I've got a question if I don't have something on the... Hang on a minute.
So my question's more general about the open source hiring market, and probably applies to most technical hiring. It seems to me that I read a story about a shortage in candidates for jobs. There's job openings across the United States, and it I have been involved in the past in trying to hire people and working with hiring organizations, and it just seems to me that the way that hiring managers approach finding viable candidates for positions has become fundamentally broken. And the more
I read about, people quitting corporate America and leaving traditional jobs behind, I get the feeling like this is metastasizing, like it's getting worse. Like there are job openings that are just remaining open because they can't seem to find people to, fit the bill. And I don't know if you've seen some of this or talked to some hiring managers that are like expressing these kinds of things are because of your certifications and the types of jobs that are being filled, their candidates pretty much being found. Is this something real that I'm observing, or is this, just the press saying, oh, there's 15 million job openings and nobody to fill them? Which is it?
I think it's real, and I'm sure there's probably 15 other opinions on that. I think the press has kind of coined that great resignation, and it's not just in IT, it's in everywhere. I do think there's more openings than people, and then you've got, with everybody adjusting, you've got people that don't even have time to go find their people because they're too busy trying to keep things afloat, so they never can even get around to calling people back. So I do think it's really real. I do think that's why you're seeing companies completely embracing the remote work, because people have found new home life work balance, and so they're embracing that and getting rid of their offices. You're finding the additional training programs, anything they can do to keep their staff, because they don't want to have to fill that spot because they know how hard it's going to be. So yeah, I think it's absolutely real, but I do think they're in the middle of it.
Those of you that may not be aware, and I can't imagine that you aren't, 3% of the workforce quit in August. Think about the statistic. 3% of the workforce quit in August, and a larger number quit in September. And we haven't got the October stats, but if it's going to be a continuing trend, if that happens for the next 11 months, it'll be a third of the workforce will have rearranged itself.
Yeah.
Now, some of this I'm sure is driven by what you're talking about. These forces work from home, whatever. But I read an article recently that said a lot of people are doing basically what I did in 2009. I just gave up, started my own company, and started consulting. Yeah. Why work for someone who doesn't understand what you do? You can be that person.
Yeah, I think they're responding to that.
I don't know what I do.
And just trying to do what we can to get ahead of it, and that's kind of why I enjoy what I get to do, because I get to prepare anybody who's wanting to jump in, and so that's kind of fun.
Interesting, though. Thank you for your.
Thank you. All right, do we have anybody else today? All right, great. Thank you very much.
By the way, my line when I did that was, if I have to work for an idiot, it will be me.
All right, there we go. Welcome everybody to the 19th annual OLF Conference. It is a treat once again to have John Mad Dog Hall as one of our speakers. He has a long history with the OLF, as many of you know. It literally wouldn't exist without him. He personally financed the second ever one, renting space in this very hotel when we were not able to secure a location. And fortunately, we did pay that back, I believe. But he's given us so much over the years that it's difficult to say too much about him. But I won't keep you away much longer. So I will just introduce, with LPI, John Mad Dog Hall.
Thank you. Thank you very much, Vince. And before I start, I want to tell you that for the past year, I've been kind of working with the program team on this, meetings sometimes every week, sometimes twice a week. And the amount of work it takes to put on this type of an event is amazing, and these people are amazing. So my talk today is, they have done it again. And notice there's an asterisk in front of the word it, so you can replace that with any two letters you want to do. I want to dedicate this particular talk to Alan Turing. Most of you know a little bit about him. He was a war hero of World War II, helped to decode the German Enigma code, and is credited with saving the lives of 14 million people and cutting 2 years off of the war. Now, I'm also going to take this opportunity to remind all of you that we have a drawing raffle of types for various prizes. And I wanted to make you aware that one of the prizes is this Monopoly game, because Alan Turing loved Monopoly, although he wasn't very good at playing it. And the son of his mentor devised a board of Monopoly just for Alan Turing, and they used it, and then it was lost for a number of years. And in 2012, they found it again in the attic of his son, of the son of his mentor, and they was contributed to the Computer Museum in Bletchley Park. And they said, well, gee, we'd like to turn this into a real Monopoly game. And Milton Bradley said, well, you know, we'd have to sell at least 1,000 copies to make it worthwhile. And Google said, okay, we'll buy them. And Google bought 1,000 of these, contributed them to the Bletchley Park Museum. I happened to have visited there right after that. I purchased this in 2012. It is still in the box, still in the shrink wrap, never been used, and is part of our raffle. In addition to that, there's a deck of playing cards. Now, these playing cards are 27 years old. They were produced in 1994 on the 25th anniversary of the Unix operating system. And on these cards are the faces of some of the people who helped to develop Unix. These cards were made by the Unix Association. I've had them for the last 27 years, still in the wrapper, still in the box. And you have faces in there of Ken Thompson, Dennis Ritchie, Steve Bourne, Rob Pike, Doug McElroy, and other people. No, I am not in here. I wish I was. They lamented that they didn't do a canasta deck, which would have doubled the number of people they could have honored. So, to Alan Turing, to Alan Turing, there he is. So who am I? I'm somebody who was in the right place at the right time and sometimes made the right decisions. Had a long range of different things I've done, and I'm proud of most of them. So up front, I'm going to tell you that this talk is made up of observations that I've made. Most of them are based on facts, and some of them are based on opinions, but most of them I think are true, and your mileage may vary. And later on, during the happy hour, I can give you many real-life examples of what I'm going to talk about over beer. I also want to plug the Old Farts Barf Tonight at 9 o'clock. It's something along the lines of, why did this happen? Why did we do it this way? And what does it make any difference? And we hope to have both old farts and young whippersnappers there to exchange ideas and things like that. So let's go back in time a little bit, to the time before 1986, where open source and free software, in fact, software of all types, could not be copyrighted. You couldn't copyright or patent software. And that changed in the time frame of games coming in, because game manufacturers would develop a game ROM, put it on the board, and their competitors would come in, copy the board, copy the game ROM, and be able to undersell them in price. And so the game manufacturers went to the US government and said, we need to have copyright on these ROMs. And later on, they said we need to have copyright on the code, the source code that made the ROMs. And believe me, there was lots of arguments back and forth. And so copyright happened. And then when copyright happened, you had to be able to license the software. And that's where the licensing that we have came into being. Now, for a certain type of software product, like a university, they wanted to give away their software for free. And when you're giving something away for free, you can't spend $1 million on every copy trying to protect it. So they decided that they were going to have a permissive license, MIT, BSD. Take our software, use it for anything you want, but just make sure that we sometimes get attribution in certain places and things like that. And so all of the licenses that we consider to be open source came from that. With one kind of exception, this is called the restrictive license, because it restricts people from using the code unless they're going to make the source code available to the end user. And this is where the GPL came in, and the LGPL, the concept of copyleft as a play on words to copyright. And this is the one that Microsoft considered to be viral, okay, like a virus. And especially Steve Ballmer, he liked to call it viral and virus. And he sounded a little bit like a big jackass penguin. And there is a prize in the raffle of penguin feet on a canvas that was done by the Jackass Penguins at a penguin exhibit and contributed by Beth Lynn. And that's part of the raffle also. So I want to give you a little background behind that. The Jackass Penguin lives in South Africa and actually does make kind of a baying sound when it sings. So that's why it got its name. Now, Steve Ballmer thought of this as a restrictive license. I happen to think of it as a liberating license, because when you say free software, in the United States we have this problem with the word free. We have this problem with the word freedom. So I'm going to extend this a little bit and say that when you have freedom, you have control over your life. You can do what you want to do. Nobody else can tell you what to do. That is freedom, okay? And this is what free software gives you. It gives you control of your software, control of your computer, control of your business. And I could go on for hours on this, but we don't have the time to do that, because I'm going to tell you why Microsoft is screwing up again. So what is Microsoft doing again? They're obsoleting a version of their operating system and making you make choices about whether you continue to use your hardware or not. We'll go into why they're doing that. But I'd like to point back that this is a little bit like Windows XP, where millions of people were still using Windows XP, and they just decided that, nope, we're not going to put out any more bug fixes on that. We're not going to allow people to continue using it. And we're going to see in a little bit how bad that really was and is. So they're isolated. They're forcing people to go to Windows 11, which doesn't support various types of hardware that people are using. And these people may not be able to afford to simply go out and buy a new system that will support Windows 11. And then Microsoft says, oh, just upgrade to Windows 11. And there's lots of reasons why you don't want to do that. Mainly you figure it isn't broken. It's perfectly okay. But it will be broken, because sooner or later there's going to be you're going to try and have to get a new piece of hardware to fit in that old operating system, and the device driver is not going to be available for it. Or you're going to have some type of bug happen that you haven't detected before. or you're going to have some type of security hole that's been found you haven't been aware of before, and you're going to need a patch for it. So you can't just sit there, because when you sit there, in fact, the software works backwards. And even if all of that wasn't true, upgrading is disruptive to you. It's disrupting to your business, it's disruptive to your users. They have to go. And typically, there's no budget for it. This is sprung upon you, and you have to make a decision sooner or later what you're going to do. But why does Microsoft want you to upgrade? Well, it's easy. Even though they're a very large company, they have lots of people working for them, not everybody is a software developer. Now, Microsoft has about 200,000 employees, but not all of those bear the title of software engineer. Some people are product managers, some people are sales support people, some people put software into boxes, some people take software out of boxes, some people work in the cafeteria, some people paint lines on the parking lot outside. And when you really look at the number of people that have said software engineer in Microsoft, it's 100,000 people. Still sounds like a lot. However, only 47,000 of those 100,000 are developers, and it's spread across a whole wide range of different products. So when you find out that there's actually only one person still working on Windows, I'm saying it's more than one person, 2 people, maybe 3, that, you know, they want to take those people and put them onto the next operating system. They don't want to be supporting this old broken down operating system called Windows 10 for the rest of their lives. So, how many open source developers do we have? Well, there's lots of different ways of measuring this, but according to IDC, which a lot of people look at, they see there's 5 million full-time open source developers, and 7 million part-time developers, and 7 million people that don't get paid at all for developing software, but they just happen to like it, okay? And granted that there's huge numbers of open source projects, but not all of them have people even working on them. They got to a certain level, they have a declared in fact bug-free, there's no more bugs. All they have to do is be recompiled every once in a while, and they go on. And, you know, and people do cross work. Some people support 3, 4, 5, or 6 different software projects at one time. So it's hard to imagine this, but I've been using, in effect, the same text editor for over 50 years. E, ED, EX, VI, and Vim, okay? And I looked at supporting Emacs, but I didn't want to have an operating system as my text editor. But some people like it, so I'm not going to go against them. And the other thing you have to ask is, why are these Microsoft engineers doing their programming? Do you really believe that a Microsoft engineer who works on Microsoft Office actually uses Microsoft Office that much? I mean, they're a software engineer. They probably haven't written a text document in their entire lives. And how many of them actually use every feature of Microsoft Office? My God! They only probably use about 10 features, and all the rest of them they've been supporting over the years because people asked for them one time. And by the time they got around to giving them that feature, it was too late. That person had died. So there's, 90% of Microsoft Office is probably only used by 2% of the people, if that. So why do open source people start projects? They start them typically because they say, hey, I need this for my own work. And I find a bunch of other people who are in the same boat. We all work together, but we're using the product because otherwise we wouldn't have started it. We're not selling it. We're not starting it to sell necessarily. We're starting it because we need it. If you take a look at things like Blender. Blender started up as being a closed source proprietary product. They went out of business. And when they started selling off the intellectual property, the users of Blender liked it so much, they bought the intellectual property and then set up the Blender organization as a nonprofit organization to keep it going. They loved Blender. They wanted Blender to succeed. And this is the type of thing that happens in the free software space. Now, one of the other things you're going to hear about in open source and closed source discussions is the security of software. And some people say that closed source is more secure because you can't see the source code, so you can't see the holes in it, so therefore you get security through obscurity. On the other side, the open source people say, well, many eyes see the issues. You got all these people that can see the software and they can find the holes and fix them before people see them. And I call crap on both of these. Because I used to work for Digital Equipment Corporation, I used to see pieces of software that only one engineer ever worked in that software, only one engineer ever saw it, and sometimes that person would died, okay? And on the other side, I see open source projects that only have one person working on them, so there's not many eyes, okay? And neither one of these have any meaning at all. You want to know why? Because the most important thing is the fact that when you find the problem, you can fix it. This is called mean time to fix. And mean time to fix is the most important thing in security. That when you find out that there's a hole, you get it fixed quickly. And on every machine you have. Not just that you have the software working on Intel and it's fixed on Intel, but what happens if it's not fixed on ARM or one of the others and your operating system or your other software works on that? You need to have it fixed all the way along the line, and you do that with source code. Now, I will give you a real-life history about this. I worked for DEC. We had an operating system called Ultrix. It had come to end of life. DEC actually sold off the intellectual property to a small company that had like 4 engineers, and they were supposed to fix bugs and stuff like that. And then along came the Morris worm. How many of you are old enough to remember the Morris worm? Ah, yes, just swept through Unix systems, just knocking them down right and left, And my management fixed it on digital Unix at the time that ran on the Alpha, but they refused to fix it on Ultrix. And I knew that there were thousands of Ultrix systems still out there running it, and they were just dying right and left. And I had to blackmail my management into creating the fix for that and get it out. But we still had to get the engineer in there. We had to get the engineer to understand the problem. We had to get the engineer to generate the patch. We had to test the patch. And so it took us 3 weeks to get that patch out to our customers. And in the meantime, their systems were dropping like flies. How long did it take the open source community to find the problem and fix it? 3 days. 3 days to get the source code patch out there so that people could fix their system. No, I'm sorry, it wasn't 3 days, it was 3 hours! 3 hours! And they got the open source patch out there and people could apply it to their systems. And this is why InfoWeek magazine for 3 years in a row gave the prize for the best customer service, not the Hewlett-Packard or IBM or Digital or Sun or any of those others. They gave it to the open source community. And after that, they stopped giving out the prize because they knew the open source community was going to win it every time. But before we talk about Windows 11, I'm going to remind you the concept of promises. We all live in the United States, most of us, some people from Canada. And we have had deals and promises that we've given to Native Americans that were good as long as the grass shall grow and the water shall flow, which usually lasted 2 or 3 days. And so this is why people say, well, I buy my software from big companies like DEC and Compaq, and they'll always be around. The companies like Enron and Kodak and Sears. I have a Sears refrigerator, I have a Sears vacuum cleaner. Good luck in getting replacement parts. And sometimes, even if the company is still in place, they have product lines, and they wipe out product lines. I won't say anything against a company called Google, but, we've all, I think, experienced some times where Google said, oh, we were just kidding about that. It was just a test case. So how much can you trust these companies to keep going and stuff like that? So you have to balance the cost of taking control of yourself, your software and things like that, versus the cost of trusting people who may have good intentions. I mean, I don't think companies go in to business with the concept of with the thought of we're going to go bankrupt in 3 years, unless of course you're some of the financial institutions we work with. So, but on the other hand, a lot of people don't have, they say, well, I don't have the experience or the knowledge or the people to be able to create this trusted system. Well, maybe you don't. But maybe you have a community of people who do. And maybe you can help to support that community of people by buying services from them and stuff like that, instead of spending your money in useless licenses from companies that are not as good at it. And so if you had an operating system that was obsolescent by the company that made it, if they released the source code, you might be able to form a community around those people to maintain that into the future. And maybe companies and banks and government institutions would join in on that to give that operating system a longer life. Oh, and there's also the concept, I mean, Microsoft sets up these areas, these buildings, where if you want to look at the source code for their operating systems and their products, you can go to this building. You're not allowed to take cameras, you're not allowed to take notebooks, you're not allowed to take phones, you're not even allowed to take a pen and pencil, but you're allowed to look over the internet and see the source code for their operating system. Now, if you believe that the source code you're looking at is the source code that generated the operating system that you're using, I have a bridge to sell you in New York City. And you're going to have to fight off a whole bunch of cheap politicians who want to sell you that. So let's talk about Windows XP, my favorite. That's the Vista. It was retired in 2009. But there's hundreds of millions of systems at that time that were still running Windows XP. And the only time that Microsoft veered away from its generating patches for that was with the Spectre and Meltdown issue in 2018. And that was so horrible and so egregious that they actually broke their own policy and generated the patch for that. But what else didn't they patch at that time? There was lots of other bugs and lots of other security holes that were less likely to be, so they didn't patch them. Now today, people estimate that 0.6% of all the desktop and laptop PCs that ran XP are still running XP. And 0.6% doesn't sound like a lot, but if you think about the fact that there were 2 billion desktops and laptops and stuff running Windows XP, that means that there's 12 million still running it. And yes, they're run behind firewalls and other types of protective stuff, but they're still out there. And some of them are still being used by banks. And some of them are still being used by our military. Doesn't that scare you? It scares the shit out of me. And there's one country in Eastern Europe who actually has 60% of the systems in that country are running Windows XP. So, let's remind ourselves that Spectre and Meltdown was so horrible that even Microsoft had to create that patch. But what is the major reason given for Windows 11 breaking hardware? Because it will. That major reason is security. We want to make it more secure. And to be fair, if I'm ever fair to Microsoft, we have the boot code, which is going to be UEFI, the Unified Extensible Firmware Interface, which will replace the 40-year-old BIOS, which needs replacing. I will admit, that's good. And it will allow you to implement secure boot. That's also good, where you'll be able to say, I trust this operating system that's on my trusted piece of hardware, and the operating system has to trust the applications that are going on it, and up the line, you can create that long list of trust. That's good. The part that's bad is that the certificates for that trust are only coming from one vendor, and we can all guess who that is. We don't have to guess. We know. It's Microsoft. Now there's ways that you can get an application that will be signed, so will be able to be booted, and that application can pass off the trust to the next operating system that's going to run. That's fine. But why not use an open source version of UEFI that you don't have to do that? And maybe you get some other certification agency to do that. Why can't we do that? I don't know. So Windows 11 allows the secure boot, but implements that through UEFI. But that's only part of it, because there's this other little thing called TPM. It's a chip that has complete control over your operating system, and your data can go anywhere and do anything. And it's used for security, and it's used for applications to be able to boot systems. Even when you think they're off, you can still boot them if you know the right magic, okay? And those two, or the lack of those two things, are going to limit the hardware that Windows 11 will work on. And Microsoft says, well, just run Windows 10, and eventually you'll buy some new hardware which will have these capabilities. But they're still running Windows XP. So now we're going to go a little bit beyond that. We're going to talk about the issues of binary blobs. Most of you know what binary blobs are. They're things of binary objects you can't get the source code to, you can't figure out how you made it, you can't reproduce it. It comes from people who write device drivers and people who write accelerators like GPUs and stuff like that, and people who write boot code. And they have these pieces of your operating system that you can't look at, you can't figure out what it is, what it's doing. And then you go down a level. What's below the operating system? Well, it's the CPU and the GPU. And you have two basic types of that. You have complicated instruction set computers known as CISC. That's best represented by Intel and AMD, where every single machine language instruction that you can see is actually hundreds or even thousands of these tiny little instructions called microcode. And you don't know what they're doing. You don't know what type of exceptions are happening inside the system. You don't know that maybe a trapdoor is actually generated inside of that. You can't see it. But then compare that to RISC, reduced instruction set computers, where every single instruction is one instruction. And yes, the electronics is doing something inside. You can't see what it is, but it's a very simple thing. And you can time it, and you can try it to see if it's been monkeyed with. And you can investigate where that chip. And beyond that, there's a new RISC chip coming out called RISC-V, RISC-V. And that's an open architecture that's being worked on by many different people to define a new instruction set, a new architecture for computers to simplify and to learn from the stuff where we made mistakes for the last 50 years, and we're still paying for them. We're still carrying those mistakes forward. And they're now beginning to create chips that are very simple, have the minimum of instructions to run an operating system, and then extensions for acceleration, extensions for other things, but you don't have to have those just to run Linux. You can just deal with the instructions in what they call the core instruction set, a handful of instructions. What else does this do? It means that the processor itself can be very small on the piece of silicon, that one piece of silicon can actually make 5 times or 10 times as many processors as an Intel chip could. Because the Intel chips are massive. They have to have all this crap that nobody ever needs, but they have to carry it along just in case somebody wants to. And so you can follow this. It's an open architecture. You don't have to pay any money to license it. And people have actually created RISC-V processors by using emulation. They've used RISC-V processors by using FPGAs. We'll get to that in a moment. And people have used their own, they've gotten access to fab plans through things like the Skywater plan that's supported by Google, where people have designed RISC-V chips and then are able to actually have them put on a piece of silicon through this program. Now, you say, my God, you know, I mean, I can barely understand what the operating system does. What about a chip? Why should I not trust Intel? Well, first of all, they put the stupid TPM thing there. That was one thing why you shouldn't trust them. But the second reason is we live in a wonderful country called the United States. I love the United States. My rights are protected by the Constitution, except for one thing. It's called the Patriot Act. And if I talk to somebody outside of the United States, I could be a terrorist, and people could listen to me. Now, you know, we'll get to this in a moment, but just imagine, start to think about, what if you live outside the United States now? And this is more than just a CPU, it's a GPU too. That GPU is a little program that, you know, works on huge amounts of data, doing a single thing to it across the board. It's sophisticated, it can hide stuff. The software drivers for it can hide stuff if they're binary blobs. And the USB is the same way, and the Ethernet's the same way, and your SATA disk controller is the same way. They can all hide things from you in the hardware. And a possible replacement for all this is to use something called a field programmable gate array. Now, the word gate relates to something, it's a transistor. The word transistor and gate are almost interchangeable. Two transistors make a flip-flop. Two flip-flops make a half-adder. Two half-adders make a full-adder. A bunch of full-adders in a row make a register. A bunch of registers make, and a control unit make a CPU. So it all comes down to a gate, a transistor. And what a field programmable gate array is, an array of gates, an array of transistors, which you can reconfigure in the field programmable gate array. And one moment, the field programmable gate array could be a CPU like RISC-V, and in the next moment, a field programmable gate array could be a GPU. You just give it a different program. And what this means is you now have control completely over the hardware and the software in your system with no binary blobs. Now, if you people think that this is an impossible thing to do, well, the University of Sao Paulo, one time I went down there, was upset because GPU makers were not making a lot of open source GPUs, not telling us how to program them. And I complained to the professor at the University of Sao Paulo, you know, embedded systems, you don't need a powerful GPU. You just need something to do a little bit of work, you know, very simple. I mean, the whole thing could be replaced by an FPGA. He looked at me kind of strange. He said, "You're right." And 6 months later, 2 graduate students had created a field programmable virtual GPU that could run the entire OpenGL test suite and all of the codecs that GPUs normally work with. 6 months. And it was fast, even in emulation. So the next step is to take the emulation part and put it into a real FPGA and make it available. And all of this work that they did is up on GitHub. It's all freely available for people to use. And we could use the FPGA to replace the GPU. So you can do all sorts of interesting things when that happens. Now, Linux and Unix always was more secure than a lot of other operating systems. Because while MS-DOS was a single user system that came out before the internet was reaching into people's homes and offices and businesses, it was a single user system. You didn't even have to log in. You didn't even have a password. But Unix was always a time-sharing system, even from version 1. And so it had to be built with the concept of security in it. Now, it's not perfect, of course. There's lots of things we can add to it to make it better. But it was way more better than the original personal computer operating systems. And again, I know this is not the only operating system that came from this, and had these capabilities. Certainly BSD also did. But it's something to build on. And so if we take a look at all the solutions we have for Linux that are available to our fingers, we have things like encryption. Now, a lot of people will tell you that encryption, especially politicians, will tell you that encryption is evil. And I will point out to them, I'm sorry, but encryption is the basis of authentication. And if you don't know who you're talking to, you can make a big problem. So you need good encryption and you need good authentication. And I would periodically write 4 or 5 page letters in fine print to various politicians who are trying to create laws in the United States to eliminate encryption, as if they could. We've also had GPG as a long-running example of that. And we have other open source encryption capabilities. And if people think that obscurity is the only way to keep encryption good, that's exactly the opposite. You need to make encryption so secure that you can publish every single line of code that makes it up, and it still is mathematically impossible to break it that way. That's when you have a good encryption technique. And we need to teach people how to use encryption. We should encourage them to use it all the time. Encrypt everything. Encrypt your lunch menu. Encrypt your mail you send to different people. Encrypt your file system. Why should we be doing this? Because then the powers that be that want to spy on us, they want to look at our personal communications, are going to have to go back the way they did it before. They're going to have some reason to look at you. They're going to have some reason to go to a court and get a search warrant or get a subpoena from a judge, that then they come to you and they say, we have to decrypt this. You have to show us this decrypted thing. It's not something they're going to do in the background, behind your back, okay? And the thing is, although every encryption technique is breakable through brute force, and with, some of the newer, faster computers coming out, they're going to be able to decrypt things. If you encrypted everything, they wouldn't know what to decrypt. And so they'd be right back where they started again, right? It's not clear text anymore. So what do we have with Linux? Well, you can encrypt an entire file system, or you can encrypt individual files if you want to. There's many different programs for doing encryption. You also have things like Linux Pluggable Authentication Modules, PAM. The same thing that was used in Unix, re-implemented with Linux and free software, allows you to authenticate individual users to run individual programs, sometimes on a time basis. You can only run this program from 9 to 5, Monday through Friday. You can't access it any other time. You can mount this file system during these time frames. Otherwise, it's kind of invisible. You don't see it. You don't have to modify the source code of the program to do this. You can just do this through the tables in the Linux system. There are also some GNU Linux systems that are more secure than others. There's some that specialize in security, like SE Linux. Originally started by NSA. Oh my God, the people we're trying to protect ourselves again are helping us create the secure system. Yes, because they too need a secure system. And they helped us design it, and Red Hat supports it as a basis of their system. AppArmor is another that does the same type of security on an application by application basis. And that's used by SUSE Ubuntu and is turned on by default in Debian 10 and beyond. You also want to be able to limit destruction, because in this day and age of ransomware, all of us, whether we have money or not, are liable to be hit by ransomware. And it creates huge amounts of damage. Now, you can set up, if you really want to work at this, you can do things like set up jails, so if people try and break into your system, they think they're in your system, but they're really not. Honeypots are another example of this, where you can keep people busy trying to think that they're destroying your system, but they're not. You can set up containers and virtual machines to protect your system too. We have all these capabilities that are available if you know how to use them. and if you want to go through the steps of using them. We have Samba to allow you to share files across different operating systems, stuff like that. And there's whole distributions that specialize in security. Systems that block your IP address from being seen by other people. Systems that allow you to test your own system to see if it's secure. So you can make your system really, really secure. Here's a thought. If you have a gateway or if you have a firewall, why not use a non-used CPU a lot? Why use an Intel CPU for that? Why not an ARM? Why not a RISC-V? Because if somebody's going to create a program and they expect it to run on that system, they're going to be surprised. You know, they're going to try and have their Intel-based application working on your RISC-V-based system, and it just is not going to work. So these are all things you can do to make your system and your systems of systems more secure. You also should try and configure your systems for what you're doing to a minimum standard. The more application software you put on a system, the more likely it is that somebody's going to get access to it through a bug. So set it up for a specific thing to do, and that's how much software you should have on there. Start to use IPv6 addresses. 128 bits of address. Typically, the upper 64 bits are used by the ISP, and they give you the lower 64 bits to work with it. So you can spread all the systems in your environment amongst those 4 billion times 4 billion addresses. And so if somebody's trying to brute force log into your system, they're going to have to go through the 4 billion, or at least half, on average, of the 4 billion times 4 billion addresses. It could take them a long time. They'll probably get tired and go some other place. If you really want to frustrate them, every once in a while you switch the addresses around. And also remember, you can have different ports on each address. And so you can really screw them over. Here's something I found interesting. Recently, I had a friend of mine from Brazil, a young person, say, I want to get a two-factor authentication key, but they're really expensive down here. I want to buy 2 of them, they'd be $150. And so I never really put much attention into this before, but I said to him, aren't there any open two-factor authentication keys? And one search of the internet, one line search, found this company, Solo Keys. And they had just come out with the version 2 of their key, which is completely open hardware and open source software. They publish a circuit diagram, they publish the Gerbers for creating the PCB boards, and they publish all of the software that they use inside the system absolutely free for you to use. They're lower cost than the traditional ones that he might have bought in Brazil. And so using a key like this, along with multi-factor authentication, can make your system a lot more secure. Now, one of the other things we have in our little contest or drawing or things we have today is something called the Freedom Box Pioneer. This is a little open hardware single board computer, which is made by a company called Alamex. They publish their circuit diagrams, they publish their bill of materials, they publish the Gerber files. They allow you to make their systems if you want to, but it's really cheaper if you're only buying like 1,000 to simply buy it from them. But you can see everything it does. And the hardware controllers on there are completely blobless. And attached to the bottom of that is a little docking station that they sell for €9 without a disk. I happen to have a 1 terabyte disk in here. And this is going to be part of our raffle that's online. Somebody will walk away with this hopefully tonight. If not, they can receive it by mail. Now, that would be interesting enough, except you could also use this because it runs Debian 10. You could use this as a NAS server. You could have RAID 1 set up on it, software RAID, if you wanted to. It actually has a SATA port, an eSATA port in it, so you don't have to tie down your USB ports. And it has 1 gigabyte of RAM in this particular one. Now, I have a little NAS box at home with 2 12 terabyte 3.5-inch discs in it with eSATA. And I'm gonna, when I get back from this, I'm gonna set that up because one day before I came here, I had gigabit per second fiber installed in my house up and down. So that's gonna be my basis of my web server and stuff like that. But the Freedom Box, just the hardware would be impressive, but the software is more impressive. Now this was created by a man named Eben Moglen, who is a law professor at Columbia University in New York. Eben was probably most famous for having written the GPL version 3. And Eben's a good old boy, and he got concerned about 12 years ago about people sending all of their most private stuff to the Google Cloud and to AWS and places like that. And he said, I think we need to have a little secure server that can plug into your outlet at home, doesn't need air conditioning, doesn't need, 3-phase power, all that type of stuff. And you can put your most private of information on that. And you still send all of your cat pictures to Google. They love them. So he got together with some people. They started a project called the Freedom Box Project. And 10 years later, they came out with version 1.0 of Freedom Box. It allows you to set up your own VNC server. It lets you set up your own Tor server. It allows you to set up your own web server, your own email server, things like that. And all of the software is included in Debian 10. So you don't have to buy a system from Olimex. You can just use your Debian 10 system and Debian 11, of course. Debian 11, by the way, is a long-term support release of Debian that will be good until 2026, or at least until they drop support for Windows 10. So there's a lot of functionality here, and there is a front panel on this, a dashboard on this. Doesn't make it mom and pop easy to install, but it makes it pretty easy to install, okay? So I think most of the people in this room would be very easy to install and set up a really good Freedom Box. They even set it up so that you can set up your own certificate. You don't have to go to some nasty company in Redmond, Washington to do that. Now, on top of this, in the future, they're going to put federated social media. Things like Diaspora, Mastodon, GNU Social, and others. And so you'll be able to set up a distributed social network so that Mark Zuckerberg will be really upset. Okay? And you can do things like exchange ebooks and stuff like that amongst yourselves, amongst your little community. Because Freedom Box is not just about a personal secure server. You can set up a community server off of it. And there's a little book on the Freedom Box site that says, well, what does this mean, setting up a community server? It's very interesting reading. And along those lines, you still have the traditional things we do with Linux, firewalls, gateways, packet filtering, demilitarized zones, so you can set up a place that people can access the internet without getting into your internet. And it's just pretty amazing. But all of these things are things that you have control over because you are using Freedom software. But all of these things typically needs training. And I'm going to put in a little blatant advertisement for lpi.org, where we do certification of systems administrators, including security systems administration. But you don't have to take our tests. You can go to our website and you can see the objective of each test. You can say, yeah, I know how to do that. Yeah, I know how to do that. What in the God's name are they talking about? What's this System D thing? I don't know anything about that. Probably good, but I don't know anything about that. Maybe I should learn something about that. And if you can go all the way down that objectives list and you feel confident you can do that, then you're probably a pretty knowledgeable systems administrator. That's what you need to know. And so the bottom line of all of this is that we have to bring the control of our systems back to the users, back to the people that own the hardware, back to the people that own the system. And instead of migrating from Windows 10 to Windows 11, we need to tell them how to migrate to Linux. Because I've been using basically the same Linux system with incremental upgrades I never had to pay for ever since May of 1994 when I met Linus Torvalds. And you have to fight for the control of your hardware, and you have to fight for the control of your software. And that will be the last migration that you have to do. But you also have to train your users and your management that this is the reason you should be going there. Now, people from time to time ask me about the future. Say, what is your prognosis of the future? And I say, we've always had antagonists, but now they're even worse. Because in the beginning, they were simply script kiddies. People would find these things on the internet and they would apply them against 10,000 systems, break into one, and they would tell all their friends, and then their friends would rat on them to the FBI, and then the FBI would go and arrest a 10-year-old kid. But now we have serious people. People doing ransomware, governments doing terrorism and e-terrorism. And it's only going to get worse. In fact, we have people in various countries, I won't name the countries, but you could probably think of them, who actually have set up businesses in selling software to break into other people's systems. So they don't break in themselves, they simply sell the software to these other people who will use it to break into systems. And it's only going to get worse. And then we have the really serious people, the agencies we dare not say their names. And this is where you have to think of yourself as maybe living outside the United States, because everything changes when that happens. Dilma of Brazil found out that the NSA was reading her email. She was quite upset about that. But then, even if you live inside the United States, you have other agencies. You know, when I was growing up, they were the KGB. They changed their name, but not their tactics. Now they're the FSK. And there's another type of security, supply chains. We in the United States have been shipping all of our production over to China. We have to stop that. How many of you heard of the fact that China managed to grab the major cobalt mine in the Belgian Congo after the United States, for over 50 years, poured money and stuff in there to woo the Belgian Congo people into selling us the cobalt, which will be used for making batteries for electric vehicles. And China just went in there and said, capitalism, free trade, we want to buy all your cobalt. So we have to protect our supply chains. We have to get the manufacture of chips, fabrication plants, back to the United States. And I tell every country that will listen to me, you need to secure your supply chain. If you're a small country like Monaco, you can't possibly develop everything yourself. That's okay. You make friends with your people around you, and all of you are in the same boat. And you make sure you have a supply chain. Because the days are gone where we could send something into space with a slide rule and a set of books like they had in Hidden Figures. That's gone. It's gone that we'll be able to fly planes, because if I snap my fingers like this and all of the computers disappeared off the face of the earth, planes would crash from the sky, you know, traffic lights wouldn't work, traffic would be in a mess, we couldn't pump oil, we couldn't pump gas, everything would just fall apart. And now we can do that at 1 billion cycles a second. So what keeps me awake at night? Bad beer and scotch. Bad scotch. Fortunately, I got some good whiskey from the OLF people. But what really keeps me awake at night is Internet of Things and infrastructure. And Internet of Things is terrifying. It's already bad. It's going to be mega bad, okay? Unless we build the security into it and unless we make sure that we are in control of the data. Not Mark Zuckerberg. Definitely not Mark Zuckerberg. And I'm not paranoid. Because if I was paranoid, I would be thinking about things that aren't true. And my conspiracy theories are true. They've already happened. And they're continuing to happen. And I'm diabetic, and I'm fat, and I'm old, and I'll probably be dead in 10 years, but some of you still have some life left in you, and you're going to have to worry about this. I'm going to become senile soon, so I won't have to worry about it at all. It'll be your problem. And finally, a word to any Cs in the audience. That's CTOs, CIOs, all the other Cs. Stop treating your systems administrators as if they're an expense item, a necessary expense item, and treat them like the asset that they are. Listen to them so they can help you set up your system better and it'll be faster and more efficient than what you have already. Give them a voice in your company. And know that no system is completely insecure, but you can certainly frustrate the people who are trying to break into it so they go off to somebody else instead of you. Here are some references that are available. You know, you'll have access to the slides and things like that. And final little advertisement for the drawing is the quilt. This quilt is made up of 42 panels of t-shirts from my collection of 15,000 t-shirts that I've collected over the last 50 years. And the LPI actually paid for the manufacture of these t-shirt squares into this quilt. It has a very nice fleece backing, very soft. I have a king-size one in my house, and I sleep under it every night. So this is also part of the raffle online. You have all these gifts, and you also have Beth Lynn's canvas, as she says, with the penguin feet. And all of the money goes to help to support OLF, so we have more events like this next year. So thank you very, very much for attending. And I'm going to have a BOF later tonight. I have to tell you about the BOF. This is the BOF of old farts and, whippersnappers. So come there. It's just going to be a fun BOF, not any slides, no main speaker stuff. We're just going to wing out and people tell stories and stuff like that. It'll be a great time from 9 to 10. Thank you very much. Any questions? Can I answer any questions or any points that people would like to say?
Make sure you use the mic if you ask questions. We do have an online comment, John, which is apparently OnlyKey. OnlyKey.io is another security key, which is fully open source.
Yes, I didn't cover all of it. I became aware of that one a couple days ago, and I just didn't have time to work it into my talk.
Somebody have a question?
Okay, well, I'll be around for the rest of the night in the BOF and stuff like that. And you might be able to find me at the bar later on under the table.
I got a quick question.
Okay.
So you mentioned historically that it wasn't until the late 70s, early 80s that software was recognized as being copyrightable, which then obviously led to the advent of proprietary software and the open source free software movement.
No, actually, it was proprietary software before that. It was just protected with a different method, contract law.
Okay.
And
Okay,
if
well,
if you didn't protect it with contract law and it got out, then it was just public domain.
mm-hmm.
Go
Okay.
ahead, but do you have more part of the question?
Yeah, so my question is, do you think that we should go back to not having software be covered under copyright legally? Would you advocate for that?
So this is always a point of contention with Richard Stallman and myself. Richard Stallman didn't believe in intellectual property. He didn't believe in copyright. And I had to point out to him that without copyright, you had no way of forcing the GPL license on anybody, right?
Mm-hmm.
So without copyright, his GPL was worthless. And people would have just taken the code that somebody made visible, change it, create a binary, and he wouldn't have had nothing, nothing he could have done to stop that. So I do believe in copyright. I do believe in intellectual property. I do believe in the economic business of making free software. Now, one thing that Richard and I always agreed on is that you should be able to sell free software. And you should be able to make money from it. It's just that the total economic model says you can't sell it for a huge amount of money, just rape people over the coals, because if you do that, somebody will fork the software and offer it for less money. So I think there's a little company, you may have heard of them, called Red Hat. They've been very successful at selling free software. And when I first started programming, my mother came to me and she said, "John, what do you do for a living?" And I tried to explain to her how I was writing these ones and zeros and instructions and stuff that would tell a computer what to do. And she would say, "Never mind." And then years later, I actually gave them a PC. And believe it or not, it ran Windows. I think it was Windows XP when it first came out. Because I'm a pragmatic person. I knew that the people around my mother and father only used Windows, would be able to help them if they got into a thing. And I lived 10 hours away, and I was not going to be able to be their support person. So after she used it for a little while, I came to visit. She says, "John," she says, "I finally think I know what you do. You write the programs that we use on our computer." I says, "Well, Ma, I used to do that like 30 years ago. But now I'm using GNU Linux. So right now, basically what I do is I sell free software." She thought about that for a little while and she said, "Never mind." Did I answer your question?
Yeah, I have a follow-up one if that's all right.
Okay. I'm perfectly happy.
So it sounds like you are saying that obviously the GPL would not be enforceable if copyright law did not exist. It does not sound like you're saying that you think that proprietary software should be allowed. Do you think that the GPL should be codified into law? Obviously, this is hypothetical.
I don't believe in a mandate that says how you obtain your software, okay? I believe in educating people as to the advantages of using free software and encouraging them to use free software. Just as like I don't really like open source, you know, because open source is great for the developer. You get access to all this source code and you say, "Oh yeah, this is great. I cut down my development time. I have much more stable software, stuff like that, because it's used in other places, da-da-da-da-da." However, you can still create a binary-only distribution for your customer, and they're still in the same boat as if it was Microsoft or Oracle or Apple or anyone else.
Apple actually uses that concept with your iOS. It's based on BSDs.
Right.
Not GPL.
Right. And so, you know, if you're going to say that the only way you can have software is to have free software, well, then you're forcing everybody. And there'll be some people who say, "I'm not going to develop software at all." So my job is to convince people of the business models of free software. and that this is really the way to go. And you know something? I think I'm winning. I think we're all winning. For the number of people that generate free software and use free software and, and create products that are truly free. And, I believe in that very strongly. And I have a whole drawer of things that were developed with open source software that they never opened up their software. The companies that produced it have gone out of business, so they stopped producing that product, and I can no longer use it because it wasn't free software. And free data. Don't forget free data. Creative Commons. Okay? We need to be able to do that too. We need to have collaboration. So if you listen to Bernie Sanders, and I'll admit I'm a Bernie boy, okay? I voted for him in 2016. I voted for him in 2012. No, I'm sorry, 2016, 2020. And I believe in his platform, and particularly what he calls democratic socialism. Because another word for democratic socialism is an employee-owned cooperative. There's lots of those in the United States. If you've ever bought Land O'Lakes butter or milk or cheese, that's a farmer's cooperative. If you're in the rural states and you have a rural electrification program, that created a lot of cooperatives. In that case, they're owned by the customers who vote every year for the management and stuff like that. There's actually a software support company down in Texas that's a cooperative. And all the people that work for it are owners of that. You see, when you're a capitalistic company, you may have the owner and the board of directors and the stockholders live 20,000 miles away from the company, from the manufacturing plant that's polluting the river, that's polluting the air, and they don't care. All they care about is making their profit. But when you're the employee and you're living right next to that river or breathing that air or having that black lung, maybe you're going to try and do something to stop that because your kids are dying of cancer. So I'm not going to tell people that they can't produce closed source software, but I'm going to tell people that what you should be buying is free software.
Thank you.
You're welcome. I'll see you at the BOF, and then maybe the BOF.
I do have one statement, Mad Dog. Mad Dog? I do have one statement. I have two perfectly good laptops. When I went from 8 to 10, Microsoft wouldn't support the Wi-Fi, so they're now Linux machines. Now I have 3 PCs that won't go to Windows 11, so once they stop Windows 10, that's going to add 3 more Linux machines. So, it's not a conscious decision. They're just driving me to the Linux operating system.
But there are some people that are not going to do it for all the reasons I gave you, right? It's inertia. They're afraid. They feel they can't get it. I have another talk I give sometimes, the 10 reasons why I can't use Linux and the 10 reasons why those 10 reasons are crap. And for every one of those 10 reasons, I have 10 reasons why they're crap. But yet I still keep having it. It's like an urban legend. It's like a vampire. It never goes away. It's like a zombie. You kill it 10 times, it still comes up. But all we can do is keep killing it. Keep trying to kill it. Thank you again, folks.
I'm Vance Kokendorfer. I'm the conference chair for this year's OLF Conference, Open Libre Free. And thank you all for coming out. You here in person and out also on the stream are why we put this together. And you folks have given us a lot of financial support as well. People who buy the supporter pass, people who buy the OLF Institute pass, and as Mad Dog made my point for me, we also have the raffle going. That's being conducted online. You can find the link from our sponsor page. And speaking of sponsors, I will also point out that we have a beer in the happy hour, and not only are the sponsors doing pretty cool stuff, but they also have these. These are drink tickets. So why not go and talk to them and maybe pick one up. So I will also say that we have the Birds of a Feather sessions coming up at 8 o'clock and 9 o'clock. There's a whiteboard out by the registration desk with a bunch of sessions listed, and I think there are still open spaces if you would like to host a BOF of your own. So please go ahead and take advantage of that, and I will not keep you from the beer any longer. So thank you.